Okay. Hey, if you're trickling in, feel free to just put something in the chat. Uh, Not that I get like a critical mass, but I do tend to like to wait to have like two people often to start. But I won't wait any more than like 5 minutes or so. It just helps so that I'm not like re-explaining the basic concept of the stream like every 5 minutes. Maybe I can do that every 15 or every 20, but normally waiting to get someone helps. I need to think though. I have like this stream has to be different from the Friday stream and from the regular concept of the weekly stream in one very important way, uh, which is I already read the top papers from the week, or like the most popular ones. I already read all of the most popular papers that stand out to me in any meaningful way. So, we're just gonna have to look in different places to find, let's call them like, as the title says, to find diamonds in the rough, right? Hugging Face daily papers can be a fine place to find some of these, but part of the issue is like, I mean, I only barely started submitting to this maybe a few months ago. I'm not sure how long it's been around, but I think actually we can find out how long it's been around. Uh, let's see. Why is it not like a yearly? That'd be pretty handy. I guess we'll see how far back it goes. I mean, it's been around for at least over a year. So obviously I should have been doing this sooner than I was, but and actually I think I lied. I think I did have like randomly a paper or two, but it was never a thing that was really like in my head, like, oh, let's go upload to Hugging Face Daily Papers until someone mentioned it to me recently. I'm very curious when it started. Was it really 2023? I mean, probably we can just guess URLs, right? Like, what if we tried January? Okay, no. So definitely not January. May 2023, I guess, is the very start of Hugging Face Daily Papers. So I suppose if I started making sure all my papers were on here a couple months ago, I was 2.5 years late. So that's fun for me. Anyway, um, if you're just trickling into the stream, type something in chat if you've never been here before. I'm going to assume most people have watched the stream at least a little bit before, so they kind of know the basic concept. I'm here, I'm reading papers. Um, I have this idea that like there's a weekly stream and then maybe like bonus streams, and there's some overlap. Basically, like the weekly stream, I think I want to do it like I did it on Friday, where I start with this like speed dating thing where I read the papers, set a timer 1.5 minutes per paper, and then at the end of that time, I decide I'm going to look closer or I'll just close the tab. We did that on Friday, got through like 30 papers, and then did deep dives on like 10 of them or so. That was fine. I want to do it better. I'm not going to say all the ways in which I want to do it better, but I want to do it better. Um, Today, because I want to do it better, in this bonus stream, I am going to do that kind of thing again. Let's call it practicing, or let's call it clip farming. I don't know. Call it what you want to call it. But there's a big difference. When I got the papers on Friday, I came here and like I was getting the top papers from the week. That was a huge source of papers for that stream. But I already did that. Um, and so I can't do that. Like I did my first read of Penguin VL 2 days ago. I cannot do a first read of Penguin VL right now. So I'm going to have to pick other papers, right? So that's why in the stream title I put diamonds in the rough, because we are going to go into the very sparsely upvoted paper territory. We are going to like really crawl arXiv, and then I would love it if you guys like threw papers in chat for me to look at, especially if you think they've never trended on Twitter or LinkedIn and I wouldn't have heard of them. Because that is the goal of this stream, is let's find some decent papers that were missed totally in my filter on Friday. So like I said, I'd really appreciate help. Otherwise, I have some ideas. I mean, the main idea is basically go to the weekly here and just scroll down to where I stopped last time. Another thing I want to do. Okay, so someone asked me, like, Matt, are you going to do a lot of NLP or mostly computer vision? And I said it'd be mostly CV. I think I want that to not be true. There are like two main things I'm going to skip. I'm not going to look a lot at agentic stuff that I feel is very orchestration heavy, or anything that's really like that. Like if I look at a paper and I think that the main things that happened are going to be able to be explained with like a UML or UML-like diagram, that's not something I'm going to read. But I do want to be reading key advances in NLP. Like this is a paper I skipped last time. We're going to look at it this time. I think I can do this. When I say I think I can do this, I mean just a reminder, if you weren't here 2 seconds ago and I explained it, I am going to try to understand this paper in less than 1 minute and 30 seconds. So ideally we don't open stuff that, or no, it's fine. We open stuff that I won't understand sometimes. That's fine. I need to get better. That's the gist of it. And as I open more stuff I don't understand, I'll hopefully get better. So yeah, let's open some of the stuff I was skipping the other time, like unlocking parametric knowledge in LMs. Okay, I guess the thing is, my problem with stuff like this, how to say it? If they aren't training the model in this paper in some capacity, if there's no fine tuning, if there's no LoRa, if there's no distal, if there's nothing like that, if this is just something eval only, it's not going to hold my interest. That doesn't mean it's a bad paper, and maybe I'm judging wrong based on what I'm seeing in the title. But I've already had people complain when it feels like I'm reading an engineering paper, and not to say engineering papers are bad or like what even is an engineering paper. Sometimes that's just a word people use to mean the paper that's not in my taste, right? But I do want to try to skew more towards papers that are like, oh, we didn't just probe the latest big LLM at scale. Instead, we like did something really new and different. Those are the ones I tend to like to look at more. So sometimes I see titles like this and I'm just like, that something about this title makes me think it's not that. But I opened it and we're going to spend 1.5 minutes and maybe I'm going to be very surprised and this paper's actually, exactly what I'm looking for. And I'm happy to be wrong. Anyway, YouTube says I have some concurrence. I would love for you guys, even if you have nothing else to say, like just put a 1 in the chat. It gives me some sanity in knowing that I'm talking to humans, because otherwise sometimes this kind of feels like I get my coffee and then I have like a schizo rant to myself in the mirror. And that's kind of a trippy feeling. So definitely feel free to chat. And if you don't feel like it or you're not at your device, that you can do that, like it's fine too. It just helps. It would also really help though if you did have papers. Suggesting a paper would be great. We are opening a lot of stuff today that's not necessarily in my wheelhouse, and I'm skipping things. If you weren't here last time, and I noticed the concurrence keeps going up, so I'll re-explain. I am going to speed date papers in this first segment. That's why you'll notice my face is in the middle. It's because I am cropping this for shorts as well. And in the speed date, we're going to spend 1 minute and 30 seconds per paper. No more, no less. And say, let's look at it closer later in the stream, or let's close the tab. That's the idea with this chunk. So, but before we do that, we have to pick the papers we're going to do with that. And that's what I'm doing. The thing is, I did this on Friday with all the papers that were popular that I thought I would like. And so now we're doing it with papers that either aren't popular or that didn't stand out to me as much as things that I would like. Let's look at this. I don't think I looked at that. Papers like this also make me nervous because okay, so this was a really cool paper, but a lot of the details I think were in the kernel optimization, where is that actually ML? It's research that is critical for ML, but it's not it's multiple steps removed from things you would learn in your ML courses, right? It's something you would learn in a parallel computing course maybe, which is very important, very good research. I am so far removed from that anything I say about it is going to be mostly terrible. I would like to learn more, and once I do know more about that stuff, I'll open those papers. But for now, me opening those papers is mostly just fumbling around. Hey, OpenClaw. Yeah, we actually looked at that OpenClaw paper. Wait, this isn't the OpenClaw paper, or is it? Am I crazy? Um, where's the open? Oh, here it is, the OpenClaw paper. We read that yesterday. Or 2 days ago. I did really bad with it. Okay. Hey, Matt. Sorry for asking about something different what you're doing, but could you say how's the infrastructure necessary for publishing on? Oh, that's a. By the way, feel free to ask these questions, especially when we're just in setup. I won't answer them when I'm in the middle of a speed date, or if I feel like a deep dive is going like really hot and I know it's going to YouTube and I don't feel like clipping a ton. I won't answer, but otherwise just put stuff and I'll answer. You didn't put anything in your about / more YouTube. You'll have to explain that more. Ashok. Yeah, you'll have to explain that. I don't quite understand what you mean. But for loan, so the infrastructure necessary for publishing in top venues on your topics. Now, your is doing a lot of heavy lifting there. I have done topics before, and I'll even show you. Okay, I hope I'm not about. Okay, let's just go to my website. Okay, yeah, here. You can see now that there's something bad happening in my head that I search this as often as I do. But let's use this to get to my homepage. Let's go down to this paper and pray that it mentions the card. Because I'll show you. I'll just show you what the compute is required. Please, please, please. Boom, there you go. RTX 2080 Ti. And you could train these on one RTX 2080 Ti. These models here. So it really depends on what you're doing. I have done things where you can run the bulk of the experiments on 1080 Ti's, which I don't know, maybe depending on where you are, that sounds like an amazing card. But to me, I mean, I'm pretty sure that's a like 8-year-old GPU, maybe. So probably accessible even to a lot of academic labs. So there are totally problems you can do on that GPU. There's tons of stuff you can't. Like if you are running the latest, like, you know, if you're running this model, you are not going to be able to even load this guy on an RTX 2080 Ti, right? It's not going to fit in the memory. So it depends on what your work is. This paper here was published at a top conference. And it even, spawned a lot of follow-up works to the point where one conference I went to, there were like 5 papers, I think. It was at CVPR. There were like 5 built on it. And like you'll talk to the authors of those papers, a couple of them were like, oh, can I take a picture with you? And I'm like, oh, that's kind of cool. Even though I wasn't the first author, I was just the second author. But what I'm saying is like you can do research that other people find useful enough to build on with single 2080 Ti's. Granted, we had more than one 2080 Ti. How did lots of grid searches across lots of these. But lots of the research could have been done, without a grid search, could have done a beam search. And a lot of the iteration you could do just on the one GPU. But yeah, when you start to move to image gen stuff, like the stuff I do lately, I'm not going to comment on what I'm doing right this minute. But the thing I was just doing, I'll tell you, like this paper where I was training on image data sets, doing distillation from a Dyno V3, doing some implicit like reconstruction-based loss, I would train this on like 8x8, so 64 H100s sometimes, or 64 H200 equivalent. That's a pretty big GPU. That it's not the newest one, obviously, like the Blackwells are newer, but they're expensive, and they're not really accessible to academic labs. Could I have done this paper without those GPUs? No. So if you don't have access to big cards, you need to tailor your research accordingly. You cannot do this on a 1080. And also, if you have if you have a H100, H200, maybe this is like the wrong scale of problem for you to focus on. Not that this isn't important, but like, the GPUs are pretty expensive. Try to think at a scale where you can like use it. But yeah, so there's another family of things you can do, by the way. Like, obviously, I said you couldn't fit the Flux 2 on the 2080 in memory. At the same time, you might be able to fit the Flux 2 on like an A6000, but you certainly couldn't train the Flux 2 on an A6000 because you couldn't fit the backward pass on it. But that means that you can do a lot of post-training stuff. I'll give an example of that. So I had an undergrad, and actually it was a featured video on the channel. So if you're a fan, you've seen it. But like this paper, we took the Flux model, Flux 1, which is, I think, a similar size to Flux 2. And we did all of these like training free experiments on, I believe, the A6000s. I could be wrong. Hopefully Ani just put it in the paper. Yeah, I think we just fit them all on single A6000s. And the fun thing about this paper is because we were doing the genetic algorithm and because of like how the calibration worked, we would do sweeps where we generate like 100 to 1,000 images, which would take like 10 to 20 minutes. And so you could basically asynchronously parallelize this across all the empty cards on the whole university cluster. So we were just grabbing like spare GPUs here and there to run all these experiments. And so that's the kind of thing that like you got to have that scrappy mindset sometimes on the university cluster. Can I get a 8 GPUs at the same time on one card? Not on this cluster, you couldn't, not at the time at least. But I could get, 200 spare cards just on random machines where the whole machine's not occupied, or in off hours, like at night when people don't tend to be running as many things. So you do what you can with what you have, and you think of ideas that work. So that's why you're going to see at a lot of these conferences, like a huge density of, I mean, we can even type in the term here, right? Like if we go training free, you're going to see like, boom, training free, training free, training free. Like we could see hundreds and hundreds and thousands of papers that don't train. And the reason they don't train isn't because they hate training. It's because you need big cards to train, and they sometimes at academic labs you don't have that. Also, part of the reason LoRa is so popular. LoRa isn't only popular because it works, it's popular because even though you're having the whole model itself loaded in memory at all times, you're not doing backwards on it. And those backwards are heavy. You're also not having to store all the activations necessary to compute the backwards for everything. And so you can do gradient checkpointing and it's not as heavy because you don't need to recompute the activations in the backward because the backward's not going through the model, right? And if that's too technical, let me know. I can explain what I meant by it too. Because I think that's a really important thing to know if you're in the business of training models. Like every word I just said, you should know what those mean. So happy to explain. I'm glad that answered your question though. And I hope I'm saying, if this is your real name, I hope I'm saying it right. Loan or Loan, or feel free to correct me. I like to say names right. I think it's important. We work in this field. We work with a lot of people across a lot of different cultures. And, ooh, this looks interesting. I don't think I looked at that before. And that looks interesting. Ooh, yeah, it's, okay. Yeah, we work around a lot of different cultures. We have a lot of different names. They sound different, they pronounce different. I think I'm extra sensitive to it because my last name is Gwilliam, like you say the G. It's not a separate thing. And growing up in the south part of the United States, a lot of people will just assume that it was a typo, so they think it's William. They like to add an S, they would say Williams. Or like one of my favorites is people would think that you say the G. So they'd be like G William or G Williams, Matt G William. And I'm like, that's, or I'd say my name, I'd spell it, and then I'd get the form back and they would put the G as like my middle initial. Drove me crazy. So I'm like extra sensitive to it. Just because while it sounds crazy, I know what it's like to have your name mispronounced everywhere all the time. And it's not fun. Like I try to have thick skin to it because it's not a big deal at the end of the day. But still, like it feels good to have someone say your name right. Um, let's look at some benchmarks today. I bet I could do a good job in the speedrun format with the benchmark. And for people that just got here, I know I've been just answering a viewer question for a bit. The idea is we are opening some papers and I am going to speed date the papers. That means I'm going to spend 1 minute and 30 seconds reading the paper, saying out loud my thoughts, hoping to capture the essence of what the paper is. If I like it, we're going to look closer. If I don't like it, we're going to close it. So that's what we're doing. I think we looked at this DVD paper already, so I'm not going to open that. Anyway, the problem is, though, I did this stream 2 days ago with like all the popular papers that fit my interest. So we looked at this guy, 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 that guy, this guy, not this guy. So we actually just opened these two because I didn't look at them last time. So anyway, we are looking for less popular papers, diamonds in the rough. First, I am going over the whole week just to see, if I didn't open any of the popular papers, then maybe I should have. But then we got to mine like for some gold here. We got to get like in the river, stick our pan up, pull it out. Hopefully there's nuggets in there and it's not all just like dirt, right? If you don't understand my metaphor with the gold panning, very relaxing YouTube content. Look up gold panning. It's very like, I don't know. I find it kind of soothing. It's just very mechanical. The sounds are nice. And it's kind of like watching those streams where people gamble. And it's exciting because it's like, oh my goodness, they just won. Except it's not like super degen like gambling. Or at least it's not degenerate in the same way as gambling is. Okay, benchmarking spatial intelligence in sports. I like sports. Some of these benchmarks I didn't open the other day just because how to explain my feeling about benchmarks. Benchmarks are the most useful thing in the world once you know what you're working on. And then you need them like crazy. But in the meantime, are you learning a lot every time you read a benchmark paper? Maybe in the really good ones. It just depends. It just depends. It's good to know what benchmarks are out there though, when you know what you're working on. Like really important. Especially because your research when you're working on something should be motivated by what the weaknesses are. And a lot of the time the benchmarks are hopefully pointing towards or exposing the weaknesses. That being said, that's like a single thing. Like from a lot of these papers, I'm looking for, I don't know how to describe it. I'm looking for something, man. And maybe I'll find it anyway. We already looked at this one. This one was cool, by the way. I kind of want to look at it again because, oh, big problem. I wanted to trim my old stream into long form videos, but what I realized, oh, I know some of these authors. Let's see what I can do with this. I said I wouldn't open agent papers because I'm just going to fumble around them like an idiot, but we'll try. But what was I saying? Oh, I downloaded my VOD and learned that natively YouTube will only let me, the creator, download my own video at 720p. And at 720p, you can't really read the text. So, yeah, that whole stream's basically garbage. I could download like the YouTube DLP, but having done that for research before to download videos, it's just such a pain. I was like, and already I didn't do a great job on any of the speed dates. I didn't do a great job on any of the deep dives. And so I might as well just like go again. The only thing that sucks about that is though, like, I feel like I did a decent cover for like Penguin VL. I feel like I did okay on that one. I liked how I covered a couple, like this one I think I liked. Did we really not look at this MM0 before? That's cool. That one looks like it could be neat. Anyway, please, if you're in the chat, throw paper titles at me. I would love to open the papers that you want me to open. I would especially like it if you give me an excuse to reopen a paper that I already read in the last stream that I liked. Because I almost feel kind of stuck right now. Ooh, dynamic chunking. Oh, from AMD, so it's going to be hopefully acceleration focused. Anyway, Ashok, you still didn't explain what you meant when you said you didn't put anything in your about / more YouTube. Oh, wait, like, is that a command? Is that a chat command? No, wait, what am I thinking? I don't know. I don't know what you mean by that, so you'll just have to explain. And once I know, I'll handle it somehow. Rubric-guided reinforcement learning. See, reinforcement learning, not my wheelhouse. Dense image capping, on the other hand, my wheelhouse. So let's see if we can bring what I know to the thing that I don't know. Okay, now we're getting down into stuff where maybe the only people that upvoted it were your friends. I don't know what the heck this is. This sounds kind of neat. Understanding by reconstruction, reversing the software development. No, I don't feel like it. Pure learning for text-to-image concept. What does pure learning mean? That'll be our goal. When we speed date this paper, and for those that are just joining, speed date means I'm going to set a timer, 1 minute, 30 seconds, try to understand the paper, explain it to you in that minute, 30 seconds. Never seen it in my life. Oh, and it's from the Kling team. So yeah, when we open this one, what does pure mean? We're going to figure that out. Unifying reasoning and generation for customized visual. Sure, I like unifying reasoning and generation. I'm always saying that's like one of my main areas. Mario. Okay, you named your paper Mario. We'll look at it. I like video games. Meta reinforcement learning, but no, I said in general, not agents. Are video reasoning models ready to go outside? That's a fun title. Lost in backprop. Oh, I saw this one on Twitter actually, and I kind of wanted to look closer. It sounded intuitive. Hudefa, besides reading papers, what else do you do when a new paper drops in your research area? What do I do with the new paper besides reading them? If I really like a paper, I re-implement it, or if it has code, I just clone it and maybe run it like ASAP. A great example is, this is not the title of the paper. Let denoising diffusion transformers denoise. Let denoising generator models denoise. When this paper came out, I was replicating it in my DIT code base like the next day, probably. This guy. There are reasons for that, that I was so interested in it. But yeah, like if I'm really interested in a paper, it's like, oh, sorry. Here, let me crop it for the shorts. Yeah, when I'm really interested in a paper. So at the time that this one came out, which was, I guess, the beginning of January, I had been working on my unified representation learning where I wanted to generate a latent that we could use both to generate and to understand. This model basically said you don't need latents. And so I was like, what happens then if I don't, like, if I basically treat my model as if it were this whole pipeline? So my understanding model is going to consume the image, and then I'll replace their prediction here with my prediction. And so the idea was like before I had my model, I'll even show you the diagram here. It'll make more sense if I, okay. So before the thought was I need, here, let's change it for shorts. Okay, before the thought was I have my architecture here and I need to generate this tiny latent or latent of some size, and then I give that to a DIT that I train, right? But this whole idea where it's like, well, if I have my model, which processes the image, right? And my model here does process the image. I process the image, and then I don't ever predict a latent, I just predict the pixels. I was like, okay, so this already predicts the pixels. I'll just treat my model itself as the DIT. And then instead of having this pre-training where it's like, oh, I'm going to pre-train reconstruction, but then a separate model is going to generate, it's like, no, my model, which learns to reconstruct, will be the generative model, and I'll simply train it with, you know, according to their experiments at least, a V loss, like a loss on the predictive velocities, but I'll use the image predictions themselves in my Euler solver or in my Hoyne solver. Am I saying it right? How do you say? I've literally never heard this pronounced. Hoyne. Okay, good. Good for me. Hoyne. Hoyne solver. I'm glad I guessed that right. Because now I can just clip out the part where I look up the pronunciation, and then I look smarter if I ever decide to put this on shorts. Anyway, does that answer your question, Hadifa? Okay, Ashok, your YouTube channel's About section doesn't have a website link, and it doesn't say anything about your background. Thanks, Ashok. Let's fix that. Okay. Let me open my YouTube. Let me go to me, view my channel. More about this channel, and it's empty. That's awesome. Let's see. Okay. Here, let me put it on the screen. Okay, let's see. Customize channel maybe? Or here, I don't know what this shows. So I'll hide it real quick, and then as long as it's safe to put, yeah, I think this is safe. Okay, here. So you're right. There's nothing in the description, Ashok. So I should definitely at least put the website link. Let's grab that real quick. Let's copy paste my bio real quick. That's a good starter. And let's throw in my website. More about me. Okay. And now, okay, yeah, my description is way too long. Okay, so more about me in this link. Oh, I can just, oh, I already have, okay. So links is a thing. I can take this out. And then I need to make this bio shorter. Okay, so I'm not a research scientist at TikTok. I actually need to update my website at the MB, can I type? Institute for Foundation. Oh my goodness. The answer is no, I can't type. Institute for Foundation Models. I study computer vision. Studied. Okay, I'm gonna probably remove all of this. Or I don't know, some credentials are good, right? Okay. I completed my PhD. I got my PhD. There we go. PhD from UMD. There we go. No highlight. I've worked at Amazon, SRI, NVIDIA, and here, let's add more work history even. Why not? There we go. Or we could focus more on just the AI science. I've worked as an AI research scientist or intern at, boom. Okay. This is better, right, Ashok? It's got some background. What kind of side want to show people? Depends. It's true. This is good for now. I'll revisit it later, and I might have a longer conversation with an LLM about this. Because I don't know. I feel like I could spend 2 hours on Reddit and get a million answers, Or I could just get one answer from ChatGPT and just rip it. And like, if it works, it works. If it doesn't, it doesn't. This is better than nothing though. And let's get back to papers. So we have this profile's fine. We got a link now. Contact. Ugh. Should I just put my actual email here? I mean, you can already get it on my website. Why not? Let's just throw this in here. It has a good filter anyway. If bad things start happening to it, I'll get some business only email. Okay. Publish. Okay. Go to channel. And why is this not, is there a lag? Oh, let's refresh. Boom. I'm a research scientist. That's better. This is improvement. Okay, so Jay Carlier. Hey Matt, how did you learn to grasp a paper so quickly? Have you watched me do it before? I'm gonna say that because like, if you haven't watched the other stream or the shorts, maybe I don't grasp them so quickly. Some of them like kill me and I fail. So if you stay for that segment, you'll see a lot of that. How did I learn to grasp it quickly when I do succeed? By reading a lot. You start to learn where people tend to put things. But part of the problem is a paper can totally like hack you that way. Like they'll signal things in a way that makes you think one thing because they know how you read it, but actually the truth is something else. So that's a problem. The other problem is a paper can be well written, but not written in the way that I expect it to be written. And then if I only spend a minute on it, I come away thinking, oh, this paper's poorly written, when in reality, it just wasn't written the way I expected it to be written. So those are two problems. But yeah, practice is the main thing. My hope is that by sitting here timing myself for a minute and a half on each paper, just like how if I were speedrunning Minecraft right now, just booting up seeds over and over and over again, I would get faster eventually. I hope I get faster at understanding the papers. And then when you say, how did you learn to grasp a paper so quickly? Instead of telling you, oh, I fail a lot, I'll be like, I know, I'm brilliant. And I don't know how it happens. Some of us are just born that way. And I could pretend I didn't work hard for it, right? But no, the real answer is just hard work or practice. Practice is a good answer. Maybe it's not hard. It's just reading. Hard work is like digging a ditch. Paper reading is like laying in bed looking at a screen, right? I might as well be doing anything else. Okay. Training free spatial acceleration. I like that. That's my wheelhouse, by the way. If I can't do this paper, here, bookmark this. If I can't do this paper in a minute and 30 seconds, I got no business doing any of this. Also, I feel bad for them. JIT, because that's like, they mean JIT just in time. But that denoising, let generative denoising models denoise, way more popular. Also JIT. So I don't know. I feel bad for smaller papers when they get this acronym collision. Or is that an initialization? Well, it depends. If you say JIT, it's an acronym. If you say JIT, it's an initialization. Initialism? Acronym versus initialism. Yeah, so if you say JIT, it's an initialism. So I feel bad for people when they get acronym or initialism collision. Happens to me a lot too. Happened to me with my paper, actually. I originally was calling this guy... Wait, have I updated it on arXiv or do I still need to? I think I did. Let's see what I call it here. Hoover. Yeah, Hoover. Okay. This was originally UVE. But like a month before I put it on arXiv, there was another paper from, I don't think it was TikTok. I think it was ByteDance. But also UVE. And I was like, well, I don't like the collision period. And also like ByteDance, TikTok, like same family of company at least. So yeah, had to change that. Neural thickets. Diverse tax experts are dense around pre-trained weights. Ooh, that sounds interesting. I bet there's a lot of diamonds in this rough, by the way, because I've put papers on here before that get 2 votes, and I think they're good. Once again, guys in the chat, gals in the chat, people in the chat, whomever, folks in the chat, I need papers. So y'all gotta help me out here. Like, I'll open papers. I can open papers all day. But I bet there's papers that you like, or maybe a paper that you saw and didn't understand. And maybe I can speed date that paper and I'll understand it better in 1 minute and a half than you did in 10 minutes. And that'd be kind of cool, right? Try me. Maybe I won't. I either will or I won't. Sparse BitNet. That's funny. I think it was a year ago, 2 years ago now, that the first 1.58-bit paper came out. What do they mean? They're naturally friendly to semi-structured sparsity. Let's try to find out in 1 minute and a half in just a second here. Oh, I saw this one pop off on Twitter too. It's kind of crazy. Some of these ones that I saw blow up on Twitter on the Hugging Face are like, this one's 4 upvotes. I suppose it's only been online for 2 days, but still. I liked it on Twitter. No, wait, March 9th. Yeah. What the heck? I liked it on Twitter. I'm inclined to upvote it now. We should do that. I don't know. It's hard because I'm closing these after. Maybe I should keep them open. If we like the paper, I should upvote them, right? Especially these diamonds in the rough. Like my one upvote takes them from, like, look at this. You can be here on the list, like 4. If I upvote that paper, or if there's 8 of us. If we upvote like the 4 upvote paper, if we all upvote it, it would be like look at this. We're like in the middle of the page. We could signal boost a paper halfway up the entire Hugging Face weekly page. That's kind of crazy, no? That's motion. If we did that, we have motion. That's like, think about that for a second. That'd be fun. So, is there anything else? Code as chain of thought. Ooh, okay. Missed that before too. See, I missed a lot of these, even in the higher votes the other day. I think it's because you might think as I scroll, I'm reading all of them, but I don't read that fast, so I'm obviously not. Fish audio. Okay, what? Maybe I've missed out on this thing I should know. It says it has 27.5K GitHub stars. Is that real? Hang on. What? What? Oh, it's been around for a minute. Maybe? Why does it have 27,000 stars if it's like all 5 days ago? It must be older than that, right? It has to be. I don't know. We'll read it though. That's very popular for me not to have heard of it. Maybe it is about, I guess it's audio. I guess I don't do a lot of audio. I don't know. I'm trying to figure out why I haven't heard of it. Chat message. Hey, Matt. Hey, Ifte? I've commented on your last vid about your roadmap / reading list for computer vision research. Yes, actually. Okay. So this is a bonus stream. And in this bonus stream, I am doing something I wouldn't normally do, in that we are looking at like less upvoted papers that I think will be out of my wheelhouse. We're actually about to hop over to arXiv and try to get some, and I'm begging you guys, gals, folks, to put some papers in my chat. So we're doing like diamonds in the rough. So that's different than normal, kind of. But the thing is, I do want to practice the whole speed dating thing still. And so the goal of this stream is still papers I've not read before. That's the goal. I want to do at some point a bonus stream where I will, like, off the dome, try to put together my impression of the history of computer vision. Like the modern history of computer vision. If I tried to do the real history of computer vision, it would be really bad because I'm young and dumb. But like history of computer vision as it's relevant to the modern deep learning era of the field. And so I would open up a bunch of papers. I'd probably prep that one a little bit, maybe with at least curating the list. Maybe run it by my former advisor too, so I don't look super stupid. But yeah, so we get like 10, 20, 30 papers. And those, instead of speed dating, I might pop some of them on the 1 minute, 30-second timer too, just to be like, this is the paper, this is what mattered, this is what it did, boom, next. And then we would deep dive, like maybe big ones, like deep dive ResNet probably, deep dive like one of those early object detection papers. I'm not sure if it makes more sense to deep dive RCNN, or if it makes even more sense to deep dive some of the works before it. We might deep dive deformable parts model, which is something none of you have ever heard of if I had to guess, but like I think that idea is important. We might deep dive SIFT. We might deep dive some histogram of gradients paper. Probably deep dive ImageNet, maybe deep dive AlexNet, maybe go back and deep dive LaCoonNet, maybe deep dive the first backpropagation paper. I don't know. We'll deep dive some stuff. We'll speed date some stuff. We'll deep dive some stuff. I'd like to do that as a stream though, because I don't have the skill or patience to edit that very well right now. I'm trying to get better at editing, but like I feel like I do it really bad if I just tried to record it on my own as a long form. Whereas I feel like I could do it pretty decent as a stream, and then anybody that really cares could just watch the VOD, get my whole chain of thought. That's the idea. And then I could trim out the deep dives, and I could put them in a nice little playlist, and I could put like numbers on them to like timestamp them according to what I think is like the chronological development of modern computer vision. And that would be like the nice little guide. I don't know. Let me know what you think of that idea. That's like my thought. Anyway, let's change this to all. Now we're showing up to 2000, but it should just be papers from the week, right? So we probably, yeah, like 900. What do I want from this? I want to get anything I might have missed. Like, what is OWL? The thing we got to be careful about these arXiv papers is some of these should maybe not even be speed dated. Some of them could be total noise. Like, they could be totally LLM generated with no human supervision. They could be written by somebody who means well, but just doesn't really know what they're doing. And so we got to be careful not to think we're learning something when really it's just like totally misleading us. You know what? I have a lot of papers open. I do want to like mine arXiv for even more diamonds, but before I get tired, let's try to do this Hugging Face. And here's something we're gonna do. I'd like my transitions to be a little cleaner between these. So we are going to open all the PDFs at the same time. Isn't it a marvel of modern engineering that I can do this without like crashing the PC? I don't know how the heck it's caching. It used to have like specialized extensions you'd have to install if you were doing crap like this. But now Chrome kind of just handles it. But we will open every single PDF. Oh, you know what I should have been doing the whole time? I should have been doing this in advance. We will zoom out. Okay, that's not zooming out. We will zoom out just enough to where my friends in YouTube Shorts can see. Because, okay, here's the thing with the Shorts. If I got any vertical viewers right now, because I am vertical streaming, if you're viewing this vertical, type a 1 in the chat. We're not going to see any ones. First off, I have 3 concurrent viewers. Second off, I know that all of you are on like laptop or like on your phone, but on the horizontal viewer anyway. But like, okay, so I remixed 60 seconds of the last live stream for a short, and YouTube showed that to 1,200 people, of which supposedly 40% actually watched. And then 5 subscribed as of when I checked last time. So like, if I can pump out 20 shorts, and if I can farm, not even 5, if I could farm like 2 subscribers a short per stream, pump out like 20 or so, if I could get like 40 to 50 new subscribers per stream just from the shorts, that'd be pretty decent. And I looked at the stats. 95% or like maybe even more of the people that short was shown to are not current subscribers to the stream. So the shorts are crazy for reach. So you're just going to have to bear with me. I am going to try to make this a little bit better though for the live stream viewers. So first off, one bonus that you get if you're viewing it horizontally is you can see the timer. So I'll show you. So we are going to pull up the timer real quick. So give me just a second. Let me get the clock app. I know I said eventually I'll get like a more custom clock, like the kind that like Minecraft speedrunners would use, for instance. We are going to increase. I think a minute 30 was long. I kind of like, we're going to try a minute again. I'm more awake now. I'm a smarter, better, cooler, funnier person than I was when I tried this 2 days ago. I want to try a minute again. The reason I want to try a minute is if we do a minute and it's hot, I can be like laying in my bed at midnight and I can go like and press the remix button and I can edit this stream like in my pajamas, not at my desk, and pump out a short. You guys could do that actually. You could remix my stream if you felt like there was a good 15 to 60 seconds. It's a button. You go to the phone, you go to the stream, you click remix, and you can clip 15 to 60 seconds. I think it shows up as your own video. And then I get to see all the things that have remixed my stream. And that's cool. I don't mind, by the way, if you guys want to farm shorts out of this. I really don't care. I think it links them back to the stream anyway. And the more reach the stream gets, the better. And that's the only point. Like, I don't view, to be clear, I view none of the channel as something I will monetize ever. I will never monetize this channel. So I'm a little congested. So, like, if you guys want to publish shorts, remix shorts, share shorts outside, like, go for it. The more the merrier. What's my point? I don't know what my point is. I'm just rambling at this point. Okay, so we got the timer. The other thing we're going to add today is there are some, like, guiding questions that I want to try to answer. And those guiding questions are, I don't know. Let's think about them for a second. Sorry. Okay. 1. What problem is paper trying to solve? How does this paper try to solve? Does it do that well? I think these are the goals. I'm going to leave a second. I got 4 people. Give me some feedback. This is what I thought of, by the way. I've spent a lot of time thinking about this. These are the questions that I think will guide a good speed date of a paper. What's the problem? How? And does it work? But if you guys have other ideas for questions, I'll actually give you a second, because if one of you had a good idea, you could make the segment like 10,000 times better. Can I zoom in on only this guy? Yes, I can. Awesome. Let's like make it, let's stretch it and like cover all the way. Come on. What is the research problem? What is the solution? Does it work? Okay, let's make it even bigger still. Boom. That's pretty slick, right? Okay, you start the channel because there's a gap in CS researcher / PhD content? Jay Carlier, Carl Ear, maybe? I don't know. The short answer is yes. Obviously, there are channels much bigger than me that do a lot of what I do, and there are definitely other channels doing paper breakdowns. I'm very nervous to say exactly what I think about the subject. I think a good way to illustrate quickly, before we start the deep dives, what my thinking is here is here. I will navigate to this off tab, and then I'll pull it up real quick. So let's look at the analytics for the only big video my channel has ever had, which is So You Want to Get a PhD in AI. Let's go to the analytics. Let's go to the audience. Nope, not audience. Let's go to reach. Perfect. Okay. Content suggesting this video. What do you notice about these? So my video is So You Want to Get a PhD in AI. It talks a little bit about pros, a little bit about cons, a little about how, okay? What do you notice about the titles? I'll say my impression. I don't think any of these are very similar to my content in a couple ways. First off, I don't think many of these are tutorial style. Like, I don't think they're really trying to help you understand the nuts and bolts of how to do some of these things from like the soft perspective. I also think these videos overwhelmingly skew pessimistic. And I don't, even if that's warranted, I don't think it's very helpful. I also think that a lot of these videos are a little clickbaity. Maybe they do have similar content to me, but like wrapped up under a veneer of like algorithm optimized insincerity. So I want my content to feel like authentic content. I don't want it to be content. I want the videos that I make to be useful to you. I want them to feel authentic. I want them to be genuine. I want them to be relaxed. I want them to be like coffee chat style. Like before I sit down for the stream, I make myself some coffee from some beans that I've bought during the week, and I come and I want it to be like relaxing. I could probably get more viewers if I actively tried to agitate you and freak you out about things, because then you would feel like the stream is really important, because like, oh my God, my life's going to end if I don't do this, or if I don't click this video. Like, oh, what? You're cooked? Like, what happened? Granted, that probably a great video, right? I'm not trying to sling mud at anyone else. Just, I feel like there's a gap in the coffee chat content for sure. Is there as much of a gap in the research paper review? I feel like there are a lot of AI educators or like influencers that do paper review. Are there as many people whose daily job is build the model that are doing the paper review? I don't see very much. There are some. They probably do a great job. Part of it is I just want to do this. It's a long answer to a short question, but I have so few chatters. I just kind of like long answers to short questions. That being said, we got to get on with the point of the stream. I've been sitting here yapping for a while. Okay, let's prepare my mind. Because this is hard. That's the one thing I remember is that this is hard. Okay, ready, set. Neural thickets. Diverse task experts are dense around pre-trained weights. So what do they mean by this? I think this is going to mean that they start with some kind of pre-trained model, and then they're going to fine-tune it for some task, and then they find that it just doesn't veer very far. Pre-training produces a learned parameter vector. This tree has a starting point, such as expert solutions occupy a negligible fraction of the volume around this distribution. So they're relying on, gradient descent. Well, yes, we use gradient descent. We explore simple, fully parallel post-training method that samples n parameter perturbations at random, selects top k, and ensembles predictions as majority vote. Oh, this sounds very similar to another paper I saw. If they're saying that they can do maybe a training-free perturbation that would give them still like decent results just because the solutions don't veer very far from originally. Let's see if we can get that from a table in the next 15 seconds we have. That is my guess, though, of what this paper is basically. Oh, this is Randopt. I saw this on Twitter. Okay. I kind of cheated because I saw this, but that is essentially what it is. And we'll do a deeper dive into this later. Yeah, okay. Let's keep this. Let's upvote it. And let's go next. Okay, ready, set. Geometric autoencoder for diffusion models. So, ooh, that's a small figure. Okay, so the overview of the architecture is they have an encoder and a projector. So the input image is processed through a pixel level branch, and then a frozen semantic branch, which could be like a dyno maybe. And then there's a semantic preservation loss, which aligns the latent mean with the features from the decoupled semantic teacher. So they want their pixel features to be aligned with their semantic features. This is very reminiscent of like an SIT style alignment, which trains the generator faster by using some semantic loss, right? And that's what I'm seeing in the latent alignment. Some foundation models, so maybe even bigger than a dyno, some projector, and then some alignment of both before you go through the decoder. Although the difference is it doesn't look like they're trying to post-train like the generative model or something. They're actually trying to fine-tune the VAE to get what they're calling a GAE. I'm not seeing the geometric component of this, but it does look like it's semantic aware, and it looks like it gets good reconstruction FID. What about good generative FID? Where are the generative experiments? Yeah, that looks decent. This could be strong. We can look at this more later for sure. I'll give it an upvote. I don't think we'll spend very long on it when we come back to it. I think I got the gist of it there. Okay. Sparse bitnet. 1.58-bit LLMs are naturally friendly to semi-structured sparsity. Okay, I think they're just saying that out of the box when you do their 1.58-bit quantization, which I won't explain this. If you want to know this, look up 1.58-bit, look up the original paper. It's like a ternary quantization is my recollection. They're going to say that there are some tasks that it just does well on, I guess. Oh, wait, no, they're saying that... What? Oh, dang it. I'm going to not do this paper well, apparently, because they're saying dense BF16 versus sparse BF16. So it has to do more with how they quantized. Dang it. Okay. I made a guess as a bad guess, and it's going to derail the whole minute speed date. I'm not going to spend longer on this paper. We'll just call that a flop on my end. Oops. It happens. Next. Next. Let's check the chat. Okay. Ready? On your mark. Get set. Training language models via neural cellular automata. So the idea is that they pre-train a transformer with next token prediction on the dynamics of neural cellular automata instead of starting from natural language, and then they do the standard pre-training on the natural language corpus. And I guess what they're going to show is that they're able to train the model faster when they first do that pre-training. These charts don't pop at the resolution I have them right now, which is unfortunate. We're in shorts mode at the moment. Let's see. Okay, so from scratch is some gray line, and then when they do their neural cellular automata pre-train, it's the purple line, and I guess they're saying it's 1.4 times faster if you compare the end result to their result. So I think that idea comes across pretty quickly, actually. You train on the cell behavior first, then you train on the language, and even once you combine the two, you're going to get a faster fitting. I really want to know if this scales, and I'm not seeing results like with a model size that tells me for sure that it scales. So that would be my next big question is, It seems to do okay over many token observations, but still this doesn't get close to true token observation scale. So I am a little curious if this potential speed up vanishes once we truly scale the parameters and truly scale the training samples. Not curious enough to look at it closer though. So that's a close angle. All right. Code is chain of thought for text image preview and rare concept generation. Okay, so what are they doing here? Prompt, image, nope. Prompt, text chain of thought, image, nope. Prompt, visual draft text, verify final image, that's a thing. But what they're doing instead is a prompt generates code and then gets like a draft and then generates an image. But like, what's the code doing? What's the idea with the code? Okay, so they're going to generate code that would say like, what? Executable code from the prompt. Oh, to explicitly specify structural layouts. Then executing the code in a sandbox environment to render a deterministic draft image, and then performing, a draft guided refinement. So you can like get all these components together in a draft, maybe in clip art, pass that as a layout, and then generate something where the layout's determined. So the job of the model is mainly to refine that like clip art style layout. That's kind of cool, but what you will miss out on is these models do a lot of work in the early steps to generate pretty things. That like good layouts. So you'll miss that. But it's still a cool idea, especially for models maybe that are not pre-trained so well and so have less layouts natively, which actually applies to models like Bagel. One thing you notice if you benchmark Bagel is it's going to struggle a lot on the gen eval compared to some other big models, right? Scores closer to 76, I think, which is a lot lower than like the mid 80s that you see with the Quen model. So that makes me think, struggling with gen eval doesn't really care if the image is pretty. It mainly cares if it follows the instruction. So the code can follow the instruction and give you a layout that follows the instruction, and then all Bagel has to do is make it pretty. So that's the first thing that comes on my head when I see Bagel. Although I'm not actually sure they're running it with Bagel, so maybe everything I just said is stupid, right? Maybe Bagel is actually solving the alignment in a code space, or maybe they're just benchmarking against Bagel. Like these are the assumptions that I make, right? When I just start speaking without looking so close. We'll do a slightly deeper dive later. Fish audio. This is the one where I said like I don't 27K stars on GitHub, by the way, and I've never heard of it, which just makes me feel really out of the loop. So this is a TTS system, and this is, I suppose, the new version of that, open source TTS. And it's a tech report for a system that I think must have been out a while, because like I said, the repo has tons and tons of stars. So it's multilingual, controllable, and expressive. So it supports fine-grained control, multiple speakers, and it's fast, all these things. And so the main flow, the architecture is there's a system prompt, a big one it looks like, which includes reference text and reference audio, and something that says convert it to text to speech. Then you give the target text, and then you have generated audio tokens that go into a codebook, get fused, come out, and then get refined and finally decoded into audio. What is the deal with generated audio tokens though? Who's generating them? Or is it like or is this just representing how it's like AR? Like we generate some and then we're decoding and then we're generating more and then we're decoding? Or do we even like have a loop maybe self-contained here and I right clicked, which just made my timer disappear, which is awesome. Yeah, I'm curious about the generated audio tokens. That's the thing that I'm missing. Does it work? I think obviously yes, right? There's so many stars because it works. I want to look closer at that. I want to understand audio better. So we will come back to that later. Let's clean up tabs a bit. Let's upvote this, close it. Let's upvote this, close it. Do we like this? Yeah, and we upvoted it. Close. We upvoted that, close it. Okay, sweet. So just in time. Yeah, this is the one where I said I feel bad for them because they like someone's already using this acronym, but it's fine. Okay, so training free spatial acceleration for diffusion transformers. Spatial acceleration implies to me that we're pruning spatial tokens. That's what it looks like. So all right. It evolves the latent state by extrapolating a velocity field computed on a sparse subset of tokens. So we patch and then we select and then we're sampling just on those tokens. Oh man, I'm not quite getting it from the diagram. I think I am right that there's some kind of token pruning and we only give the DIT certain tokens. I'm not really seeing how, but let's see if it works. They compare theirs to the Flux One dev. They get they compare theirs to like just doing fewer steps on the Flux One dev. It looks like they get better clip image quality assessment, better image reward, better human preference score, or like kind of tied with the competing method, but then better gen eval and better T2I. The image reward means that the images look pretty relative to the prompt. The Gen eval and the T2I comp means it's following instructions well. So assuming they did the benchmarks right, I would say it does work. So this is pretty cool. Let's come back to it in a little bit. So let's upvote, and then we'll give it a slightly longer look because I want to understand how they're pruning the tokens better. All right, Shotverse, advancing cinematic camera control for text-driven multi-shot video creation. So they're creating videos in multi-shots just from text. Does that mean it's T to V? T to V is almost not so interesting to me because it's very like poorly constrained. So that they give it the multiple camera trajectories to get the multiple shots, and then they give it some text. And then there's some LoRa on top of the DIT that lets them get the video. So I guess that's what's happening. We have a camera encoder, we have a LoRa, we can get out all these different shots based on whatever camera parameters you pass. I suppose we're probably interleaving like camera positions, text prompt, camera positions, text, but that wouldn't make sense. How does it give multiple shots at once? At the resolution of these figures, it's really hard to see. It looks like their metrics are good, but I'm not. See, this is the problem. I talked about this before. If someone optimizes their paper for like print 8.5 by 11, I'll be able to read it. If they don't, then when I'm doing this for like the shorts friends, I won't be able to read it. I don't think I'm interested enough to come back to this. I think I'm just going to close out of it. I bet it's cool, but I'm mainly going to stick to stuff where they bothered to make it to where you could read it if you printed it. And actually, yeah, we are at 8.5 by 11, so this is like full size. Anyway, progressive residual warm-up for language model pre-training. They are residual warm-up. It makes it train faster. That's what they're telling us. So like the research problem would seem to be, oh no, just perplexity. They're just saying it's better, I guess. I mean, it'd have to train faster. Like that's part of how you make this argument. Trains better at equal depth. It trains better faster. Oh, okay. So multiplies each layer's residual with a scalar that gradually warms up from 0 to 1. Oh, man. Okay, we're going to start this over. I did this bad. I accidentally right-clicked, so I made my timer go away. I'm going to take a sip of water, and then we're going to re-speed date this. We kind of cheated because I already spent 30 seconds, right? But I can cheat. It's my own game. I can cheat sometimes. All right. Progressive residual warm-up for language model pre-training. The main idea here is that the early layer learns first. So instead of having all our residual connections start as normal, we're actually going to multiply all the residuals originally by 0 and gradually warm them up to 1, with the deeper layers taking longer warm-up steps. I'm a little confused. If we start all the residual connections at 0, how will the early layer learn first? The gradients won't make it back to the early layers. I must be missing something, because that's the immediate thing I think, is that this would almost be the opposite of what they're saying. The layers close to the output would learn first because your residual connection is initialized at 0. So that's kind of throwing me for a loop. It looks like they evaluate the perplexity though. That's an ablation. Let's look at like the main result. It looks like they're increasing the 0 shot accuracy. It looks like the perplexity goes down, which is good. And it looks like it works orthogonally with all these other approaches, which is pretty slick. So in terms of does it work, if you trust their experiments, it looks like they evaluated the critical axes, which are it works even when you combine it with all these other things. And they show multiple metrics, right? They show the 0 shot accuracy on the reasoning. They show the perplexity. That seems pretty compelling. We could look at it a little longer because I want to understand why we're saying the early layers learn more even when the residual connection is initialized at 0, because natively that implies the opposite to me. So let's come back to it later. All right. Benchmarking and understanding memory for robotic generalist policies. How are we benchmarking the memory? So it's a large-scale benchmark because it comprises 4 task suites that emphasize memory demands. So there's a counting suite where you have to count things. They might all be in the frame at the same time, so we have to remember what we saw before. There's permanence where we need to track object locations even when they disappear and come back. So we need to know, oh, the object used to be there before it disappeared. Then there's the reference where we have to identify like, oh, recalling a highlighted cube during a button press, okay. And then there's imitation where, oh, we see something and then we have to do it. So we have to remember what we just saw. So I can see how all these involve memory. And yeah, I don't know what else. See, this is the thing I meant about benchmark papers. Now that we know what the benchmark is, I feel like it's very clear why they did it. Without knowing all the existing approaches, I feel like it's a little hard to appreciate the table where they actually benchmark it. Maybe if you're in robotics, you would know this and you could appreciate it. Me, I don't do too much robotics. I can't. But it seems clear why this benchmark matters. So I think that's a decent 1 minute. Let's upvote and move on. Okay, so this one is some sports thing. I like sports. Let's see how they're benchmarking the spatial intelligence in sports. So they have a semi-automatic data engine that reconstructs sports scenes in 3D with court location, player position, and ball position. Built upon this pipeline, they have a benchmark which what are we trying to like measure the models being able to do? Measure distances, count, relational reasoning, and they have some QA pairs. They're trying to evaluate for unseen sports, spatial aware commentary. Okay, so those are good evaluations. Let's see if we can see more examples. So, the automatic data engine does court annotation for metric aware camera parameter estimation, player mesh recovery, ball annotation by leveraging the court geometry and incorporating human in the loop, accurate and real world reconstruction sports scenarios. But what about like, the tasks? Okay, so is the ball visible? How many players are visible in the court? How high above the court is the height? See, because when you've annotated the player meshes and the balls, you can actually answer these deterministically, basically with code, thus giving ground truth to see if your VLM can do it just based on vibes, for lack of a better word. I think that's decent coverage of that one. Let's close it. Okay. Next. Okay. Gonna take a sip of water. All right, wait, before I start the timer, I opened this one because I knew the authors, but this is typically the type of paper I said I won't open, which is namely agents, because that combines two things I don't know so well. Often it'll be pretty systems heavy. I don't know that. And it's going to be RL heavy. I don't really know that as well. But we're still going to try. So let us try. Agentic critical thinking. So the idea here is that we have, okay, so comparison of imitate versus early experience executes both actions in the environment, generates a reflection from resulting states, and trains the model to imitate this fixed text and supervised fine-tuning. ACT presents two candidate actions via the, okay, so do they propose both the early experience and the ACT? Are those both their proposals? So we propose agentic critical thinking. So I think this is their proposal, which I'm not understanding just from seeing it why this is better. Which action is better for the task? Oh, so they're asking the agent beforehand, which action is better, and then the agent will, oh, and they're saying when you do that, the agent learns automatically in its chain of thought, I suppose, to reflect on things that compare the different options, maybe. That's what I'm seeing. So they have expert demonstration trajectories, they have some initial policy, they do a lot of sampling, they have some training examples. Then they, see, this is the problem. My eval of this is just very poor. I'm not coming back to this just because I'm not going to do better if I spend longer on it. I think I can do some NLP, but some of this RL stuff, especially with pipelines I don't know so well, is just going to be pretty brutal to try to do live. So I should probably learn to not click them unless you guys tell me to, or unless you folks tell me to. So that's something I'll probably hopefully eventually develop better discipline for. Let's look at this one. Self-evolving multimodal vision language models from zero data. I want to understand how this works. So the first RL-based framework to achieve zero data self-evolution for VLM reasoning. So it introduces a multi-role self-evolving framework, a proposer that generates abstract visual concepts and formulates questions, a coder that translates concepts into code to render visual images, and then a solver that performs multimodal reasoning over generated visual content. Okay, so I think the job of the proposer is to generate questions that a coder can then generate things that like you could use in order to answer the question, and then the solver is going to be frozen because maybe it already knows the answer, in which case that's not a good hard question. Or if it's a harder question, wait, or are we only going to train it if the solver does get it correctly in the first place? What does that mean? Okay, so the coder converts it, then answers the hard question using majority. Oh, the majority voting will generate a pseudo label if we think the question is hard, and then we'll keep to update. That sounds like it could be very vulnerable to the collapse. I want to look a little closer at this. I feel like I almost got it in 1 minute, but I just missed how they're handling hard versus easy. I was very close but no cigar. Let's come back to it. I like the gist of what I was saying though. Okay, so this one I was excited for. Dynamic chunking diffusion transformer augments the DIT backbone with a learned encoder route decoder scaffold that adaptively compresses 2D input into a shorter token sequence in a data-dependent manner using a chunking mechanism. Oh, so we're chunking the latents. That's what I'm reading. So the isotropic encoder aggregates local context across the input tokens. The chunking layer selects a subset of boundary tokens via learned routing, yielding a compressed sequence. So boundary tokens makes me think we're almost just like pruning. Let's see if we can tell. No, I mean, we are pruning, but it's not like just pruning from boundaries, right? Like I suppose we have boundaries and then we keep everything between them and then we remove the things that aren't between them. But it does look like we're essentially just trying to reconstruct like original tokens based on a subset of tokens, and then we can have the DIT itself that we train operate only on those like pruned compressed tokens. And indeed, how do we do? At Okay, I'm a little confused because I'm seeing more teraflops per image on the bottom than I am on the top. Dang, that's not the table I wanted to see. I'm gonna blame them a little bit for that one because my understanding is we should get some acceleration here. So I'm expecting to come to this table and see theirs be the fastest, and then it's not. What they do is probably cool. We should come back and look in a minute. But see, this is what I'm saying. Sometimes like my experience will lead me to assume something, and then reality will be so different to that thing that my evaluation will be terrible. And that's a bummer. Rubric guided reinforcement learning for dense image captioning. I feel like I know image captioning, so let's see what I can figure out from this in 1 minute. A committee of VLMs. Okay, so we're using like a lot of different experts to produce many different caption options, and then we're going to like make one caption based on all of them. And then another LLM is going to diagnose a student's specific deficiencies. Oh, so then we're going to get like another model and let it caption, and then we're going to say this is how you're wrong according to the consensus, and then turn that into a set of criteria. And then the LLM judge will apply these rubrics to assess caption rollouts and replace the coarse scalar rewards with like a fine-grained, these are all the different points that you were wrong based on how you diverge from the consensus. I think this makes sense. It fits with a lot of things I do see in the RL space, which is how do we make the reward denser? And in this case, we make it denser because we generate lots of captions that are long. We consolidate them to one thing. We have an LLM spot all the differences. And then that tells you what the problems are that you need to improve when you're actually doing your GRPM. That's pretty cool. I think we got that in under 1 minute, blind first read. Next. Shame, I think only one of you was there to watch that. I think that was one of my better paper speed dates though. And in case the one of you that's here wasn't here when I started the stream, what I'm doing right now, if you can't tell, is I'm speed dating the papers. I've never seen these before in my life, unless if I have seen them like on Twitter, I say that. But for the most part, I haven't seen any of these. And I have 1 minute on the timer here to try to answer basically these 3 questions. And then based on my overall impression of the paper, I say, this deserves more of my time. I'm going to spend longer on it. Or, you know, I just am not in the mood. Let's close it and save time for papers I'm more interested in. Okay, now my coffee's cold. It tastes different when it's cold. It's not necessarily good. Uh, it's a little icky, but that's okay. All right. Okay, give me just a second. The one of you that is here. Actually, if you are here, I'd be very curious. I'm curious who is here. So feel free to type in chat, or can I see usernames somewhere? I wonder. Do I have a way to see? I don't know if I have a way to see. Oh, it's you again. Nice. It's the claw bot. The molt bot. What are they calling those these days? Are they still calling them claw bots? Okay. Sorry, just taking a, I think we've done like 15 or so. So taking a deep breath. Oh, that's weird. You are chatting, but you don't show up as a viewer. I wonder what that's all about. It's OpenClaw since Anthropic made a fuss about Clawbot. I mean, fair enough. It does seem like, was that, I get that they're going for the lobster metaphor, But at the same time, they could have just gone for the molt thing up front, right? That's kind of the most interesting thing about lobsters. I guess other things molt too. What do lobsters do that nothing else does? Live forever, right? They never die. Or is the whole deal with lobsters that they don't die from old age? Kind of. They die from being too big. And technically, if there was like someone always there to help them molt, then they'd live forever. Because like humans age because like your cells actually get old and degrade, but I think lobsters don't or something. Sorry to blow my nose on stream. If you can't tell listening to me, it's either allergies or a cold, but I'm basically just sick permanently right now. I started taking an allergy pill again yesterday. Hopefully that helps it get a little bit better because I hate sounding like this. I don't like my voice ever, but lately I'm very like congested and it's not fun. Okay, so all right. Man, I think we're down to 0 concurrence. Whenever I go down to 0 concurrence, it always makes me want to like it makes me question keeping the stream live. But I really did want to like farm some of these potential shorts. So I'm just gonna keep pushing. Okay. Take one more sip of water. I think once I get through this whole top though, it'll be bathroom break time. And that's dangerous because if I do get concurrence and I take a 2-minute bathroom break, I'm liable to hit 0 again, right? Okay. From narrow to panoramic vision, attention-guided cold start reshapes multimodal reasoning. So what do they mean by this? Visual attention score distribution, that doesn't tell me what they mean. Okay. Visual attention score is a strong predictor of reasoning ability. Models that devote greater attention to visual tokens achieve stronger performance. That's good to know. I think we were looking at a paper the other day too that said that sometimes these models really do have a tendency to just ignore the vision KV cache entirely. So it makes sense that the ones that look at it maybe do better. We revealed that the multimodal cold start suffers from lazy attention localization, failing to increase attention to visual tokens. Yep, we've seen that in the other papers. So text-only initialization induces a clear shift towards stronger visual grounding, explaining its superior effectivenesses. Training-free attention modification increases augments performance, emphasizing image features contributes to stronger reasoning capabilities, while system token attention exhibits redundancy of reasoning tasks. Wait, so are they just going to like force the model to look at the image tokens more? Because that'd be pretty awesome if that actually worked. We should come back and look at this. We should come back and look at this in the minute. I think I got it in the minute. Like, I think that's what they do, and I think it works. It deserves a closer look. We'll do that. Okay. I remember what I said when we looked at this paper the first time. Not that we read it. I've never read this paper in my life, to be clear. That's the whole concept. Never seen this in my life. Have a minute. Gonna try to get it. I want to know what the hell pure means. That's what I want to know. Pure learning for text-to-image concept customization. What is pure learning? So it effectively maintains target unrelated image elements, and existing methods like Dreambooth and LoRa fail to follow the prompts placed on a bright window. So yeah, they fail to attend to both the reference and like the prompt, right? The decline curve indicates that existing methods compromise the original model's ability of prompt adherence and generating high quality images. Okay, so yeah, we're getting worse according to the human preference, which means they look worse, and according to the clip, which means we're not following the text. So they're just saying they're better at everything that matters. But what is pure learning? So they fine-tune a flow model on the custom set as a representation extractor, and then during the pure learning stage, the representation extractor is frozen and provides the target concept representation, which is then controlled by their adaptive scale lambda to implicitly guide the trainable model. I bet the lambda is kind of like a CFG. If we look at the math, I bet it's CFG. The trainable model is initialized from another pre-trained flow model and provides original context conditional prediction using the base text as input. I didn't get too far in understanding how this works. Based on the charts, it does work. I'm gonna need more time to give like a good explanation of this. So let's give this one a deep dive. By the way, I'm upvoting pretty much all the ones I look at. It doesn't mean I think that they're great, but like if I'm using it like on stream and I'm talking about it, I do feel a little guilty not giving it a vote. I obviously thought it was important enough to give a minute of my life to. And so is it really not important enough to click the upvote? Maybe if we look at some of these closer and I think it's like a dishonest or a bad paper, I would go and like downvote it after the fact. Not downvote it, but remove the upvote. But for the most part, I think these papers deserve a little bit of love. Okay. Unifying reasoning and generation for customized visual effect creation. So where's the reasoning part? Does that just mean we're going to use like a dyno encoder or an MLLM encoder? Oh, I see. So system prompt, user instruction, tokenize, reference video, tokenize it through an MLLM, take the visual tokens and do cross attention with them in a trainable VIT, or is it like a LoRa? I think it's a trainable video DIT, probably a fine-tuned one, or if they're training from scratch, that's crazy. We might be able to tell if we go to a table, but I bet they're fine-tuning something else. Or maybe not, I don't know. But it looks like, based on their metrics, that they're better on some things and on other things maybe not, right? That's what I'm seeing. I'm seeing like a good mix. And I'm not seeing any results that like pop off the page visually and wow me, but based on their ablation, it looks like the semantic and the visual both matter. So that's good. Good for them. Ablations are important, and they seem to prove that this probably works. I don't want to spend longer on it though. Let's upvote it and move on. Mario. It's a me, a Mario. Okay. Multimodal graph reasoning with large language models. Cosine similarity between text image embeddings across 3 models on 4 data sets. Each colored circle corresponds to one template, numbers in each region. Okay, so what are they trying to tell me with this? I can't tell. Dang it. Okay, let's try with this. Oh my goodness, what a framework. Stage 1, graph condition, vision language model to perform structure aware image text alignment. Images and text are initially encoded, symmetrically refined by a transformer embedded mixer that injects graph structure into token embeddings. Oh my god. That's a lot. And then aligned via contrastive learning, builds on those features in modality aware graph instruction tuning where a lightweight router trained under, I wonder if I spent longer on this diagram, if I could get it. I'm not getting that thing in a minute. We can at least see, does it work? Compared to what? Yeah, these scores are big. Big scores. I mean, this is graph learning, so not benchmarks that I'm familiar with, but these are good scores. Does it help on like reasoning? Because it says reasoning. I guess it says graph reasoning, right? It didn't say like text reasoning or visual reasoning. So what was I expecting? See, here's another thing. I never got that into graphs. So that's another one of my weaknesses. I really want to know though. This one doesn't do too much with graphs. It has some basic graph stuff. I think it's basic enough for me. I'm gonna try this in a deep dive. I'll fumble with it for like 5 minutes later and see if I can get it. Are video models ready to go outside? It's always good to go outside. If you're watching this stream right now and you haven't been outside today, close the stream for a few minutes, come back. I'll still be here in 5 minutes and like look at the sun, like straight at the sun with your eyes, just for a couple seconds. You'll be blind for a minute, but you'll feel something, and that's good. How is there coffee under my cup? Can someone explain that? I have a coffee ring on my desk. How did it get there? How did I get coffee underneath the mug? That sucks. Okay. I want to do a good job on this one. This feels like the kind of paper that I should be able to get in a minute. Like the title is a yes or no question. It should have an answer. If I can answer the question in a minute, then I understand the paper, right? So let's focus up. If you're just joining the stream and you haven't been here the whole time, I am speed dating papers. I get 1 minute. I have to try to answer these 3 questions. Maybe not formulaically, because check this out. What is the research problem? What is the solution? Does it work? I just wasted 4 seconds just reading those, right? Those are precious seconds that I need to understand the paper. So, our video okay, I can't miss the click, right? Are video reasoning models ready to go outside? We also introduced a benchmark that injects real-world perturbations. Okay, so they're perturbing the videos for some reason. All right, let's look a little earlier. Okay, weather, occlusion, camera motion. So they're saying these are bad things, and so we can potentially simulate them and then see if the models will do well, right? The resolution, I couldn't see that unless I zoomed in, and for our shorts friends, I'm not zooming in. But what do? Structured spatial temporal corruption that generates realistic perturbations. So probably shifting the content or zooming or just putting boxes or editing clouds in. Self-reflective evaluation with difficulty aware online training that adaptively prioritizes informative samples. That sounds smart. And then dual branch alignment reward modeling that enforces output consistency. We should have the same outputs whether it's clean or perturbed. In general, we should assume that the clean is right. So we can use the clean pre-perturbed as a teacher to make sure that we get things right even when we're using our perturbed dirty samples. How do existing models do before they do this refinement? These are kind of old ones, so it's hard to say how much it holds, but I mean, the numbers are obviously good, right? I say old. There's a Qwen 3 VL in there. Sorry, I was looking higher when I said that. I didn't realize as you get lower. There is a Qwen 3. So that makes me sound crazy, right? That is a very recent model. They do improve the scores on PVR bench. Now, the big question is, what happens when I take like the PVR trained model away from PVR bench, right? Because yes, occluded data exists, but like a lot of data is not occluded. And so if your data is heavily occluded, sorry, if you train on this heavily occluded data and then you do worse on the clean data, you're going to frustrate your users, especially because a lot of people's usage loops with these models will look like taking the best picture of the bug they possibly can and then asking ChatGPT, what is this bug? So it actually doesn't need to classify the bug well in heavy fog. It needs to classify the bug the best it can with a good quality image, right? So let's see if we have like those numbers. Oh, we have original, right? Um, but we don't have the baseline and ROVA next to each other, right? Like these are all the baselines, these are all the ROVA. Please never do this in your figures, ever. I need to compare these. And also a bar chart is not a good way to present this info because the ROVA and the baseline are basically the same height. I really can't tell which one's higher than the other. Granted, for the weather and occlusion, it's kind of obvious because they're so much higher. But I'm talking about the originals. It's like real close. It looks like at the 16F, they do improve. And at the 32F and at the 48, but the 64 is like really, really similar. I just want to see not PVR bench though. Show me the performance of yours compared to the Quen 2.5 on, is that what this is? No, see it's original. I assume original is this bench unperturbed. And it looks like theirs does improve on the original. That's, if true, pretty solid, right? And that's nice. I mean, that would follow stuff that we know from like other image representation learning, which is you augment your data by doing perturbations, less structure than these, honestly, just color jitter, and you can improve results, right? So it wouldn't be shocking that you can do that. Maybe a little surprising that you could do it with RL, but still, I think it's good. So this seems solid. I know I broke the minute rule. I kind of didn't feel like leaving the paper open, which is why. So you got like a medium dive, not a deep. Why did I just open these? Just to have to open them again. Good going, Matt. Okay. If you're just joining the stream, by the way, we are speed dating papers, which means I get 1 minute to try to answer the 3 questions on the right. I'm doing pretty decent today, I feel like, compared to the other day. And by the way, part of the reason we're in this format is because I'm trying to get some shorts out of this. Shorts get decent reach. And I'd love to get more subs. I would love to help more people find out that this reading exists. I have 2 of you, and I appreciate the 2 of you that are here right now. I would love it if I had more than 2 of you. So the more people know that I do this, the better. Granted, I know that today I'm not streaming at the scheduled time. And a critical thing for this will be scheduling it and being regular, because then people know, okay, Matt goes live at 8 a.m. Pacific Saturdays. I'll be there if I want to get the paper reading, right? I clicked go live at a random time. There was no post. There was no warning. Nobody was expecting it. Our friends in like Europe and the Middle East are starting to be in bed. And I think our friends in China are already asleep. Yeah, my ad blocker's on. Yeah, China, Tokyo, asleep. London, Paris, it's getting late. That means if we look at like Abu Dhabi, Dubai, it's like super late, or like a Riyadh. So we're good US, Canada, Mexico, Brazil, Argentina hours, right? Chile, Peru, I don't know, wherever you might be watching from. It'd be sick if I had some viewers from Latin America. Yeah, no sé si lo tenemos, pero si están aquí, bueno, pues, like, because that's the only other language I speak other than English, right? So that'd be pretty slick. If you're ever in the chat and you speak Spanish, feel free to type something. Hey, someone. Yeah, these are also bad hours for India right now, which is 8 a.m. also bad hours for India? I don't remember. Let me look real quick. It's telling me Beijing. Beijing is a couple hours off Delhi. Let's just click Delhi. What are my good India hours? Yeah, like if I stream at 8 a.m., I get my night owls in India, right? I get people at like 8:30 p.m., which it's not perfect, but it's certainly better than 12:30. Anyway, so it looks like we just had a little spike in concurrence, which is awesome. Let me know if you're watching in the vertical. I'm very curious. I'm dual streaming in the vertical. We got the papers cropped even for vertical. I don't think we have anybody there. But the general idea of the stream right now, And I'm more than halfway through it, or maybe I'm not. I kind of want to keep doing this segment. We are speed dating papers. We've got a minute timer over here. We've got 3 very basic questions over here. I have this much time to answer these questions about the paper, with the catch being I've never seen these papers before in my life. Okay, that's a lie for some of them. Like this, I saw it on Twitter, I think. So with some of these, I already kind of know what's going to be going on, but the vast majority of them, never even heard of them, right? So we're getting them from Hugging Face Daily Papers so far. In a minute, we're going to grab some on arXiv. I'd love it for you guys to just throw papers at me in the chat. Throw your paper at me. Can I understand your paper in 1 minute? And you can also let me know how critical you want me to be. Like if I fail to get it in a minute and I think it's your fault, I can either blame you or I can keep it to myself. And so you can let me know when you share your paper, how you want me to handle it. But anyway, we've got 1, 2, 3, 4, 5 papers. I'm going to try to hit them all right now. Then I'm going to take a bathroom break. Then we're going to crawl arXiv to try to get the true diamonds in the rough, the papers that weren't on Hugging Face at all. So I have no signal to go off of except the paper title and the authors if I recognize them. Ready, set. The LLM head. Okay, not LLM. LM. The LM head is a gradient bottleneck. So it's going to say that our cross entropy head on our language model, which is projecting our output features from some big dimension to whatever the dimensions that we want to decode to the language tokens, that is somehow a gradient bottleneck that doesn't allow the rest of our weights to be updated effectively. So they test this with different training dynamics by controlling the rank of the output layer to mimic reduced hidden dimensions without actually changing the shape of the transformer's backbone. And they illustrate how when you have a lower effective output dimension, in other words, their simulated reduced rank, you have a much higher loss. Whereas if you have a higher and higher dimension, you have a lower loss. So that all makes sense. The theory, we don't have time to do that in a minute. Do they have any like large scale empirical results other than just continuing to show effective dimension scales with good things? I don't think they're going to have a big empirical table. I think it's mostly a theoretical table. It's got some interesting results. Oh no, so here's some, I mean, Quant3 based Llama 3, it looks like it holds across many different models, which is a good sign. So we'll give it a provisional. Does it work? Probably. I haven't checked the math. Doesn't fit in a speed date, but these results seem compelling to me. And I missed, though, the solution. Like, I'm seeing the problem. We're going to simulate these rank changes, but I didn't really get, like, are they actually just going to change the, like, they're changing the rank of the LM head, but are they actually changing the dimension? Are they somehow simulating a higher rank than the actual dimension of the head? Is that what's going on here? I don't want to deep dive this paper later, so I'm just going to try to figure that out right now. A difficulty, as a result, studying models with different D values either implies comparing models of different sizes or adjusting the depth of models to account for, yeah, that makes sense. So they train language models that share the same transformer stack with the same hidden dim, but the language modeling head of each model mimics a hidden dimension by adopting a low rank structure. As a result, the transformer backbone is equally expressive across all compared models, but D provides control over the strength of the gradient bottleneck. I still don't understand exactly how they're doing D. I mean, obviously, okay, so they have the low rank weight structure is A theta times B theta, where A theta is V cross D, B theta is D cross D sub M. Oh, so they're actually having A sub theta and B sub theta. So it is essentially of dimension D, but then you multiply them together and you get out weights that pretend to be bigger than they are, right? Like you'll get a weight matrix of shape V cross D sub M, which is what we need because the language models actually say 4096, but the things we're learning are actually smaller. And so that's how we simulate it. And so I think the point that they're making is that you might want to try in practice to increase the size of the head, but to prove the results empirically, at least in the paper, they're going to just simulate it by essentially having a LoRa instead of the actual head. And I suppose that makes sense. Okay, that's fine. It seems to work. I'm not going to deep dive the math just because I don't feel like it. Let's look at this one. This one, I think, is even going to be relevant to me for video, potentially. Should I say that on one? Okay, I should take a deep breath and then say my thoughts. Sorry, I said I blitzed these 5, but now I spent too long on the 1 and I'm taking water again. Okay, let's try though, to blitz the 4. Consistency bugs and long story generation by LLMs. I'm really interested in this because I think whatever they find with story consistency issues for LLM is going to be even more relevant probably for video, where the models are so much weaker in the first place. So the gap is that when generating long-form narratives, the models will contradict themselves later on in terms of facts, character traits, and world rules. And so they design a benchmark which evaluates the narrative consistency, 2,000 prompts, 5 predefined error categories. So this is common, by the way. We'll try to categorize the problems we're looking for and then design the actual instances accordingly. And yeah, we even have 19 subtypes, right? So what is a good example? Timeline and plot. So errors we can have are like time contradictions. Something happened at one time in one part of the story. Later we say it happens at a different time. World building, we can violate rules or social norms, or we can say that like places are in the wrong place. To be fair, humans make these mistakes too. But this is pretty cool. So they define this benchmark along these axes, evaluate all these different LLMs, and I guess you can say who has the most error or the least error, right? Who are the good models? Blue is the best. So it looks like GPT-5 reasoning does pretty well among all models. Followed by Gemini, followed by Sonnet. So that's kind of a neat result. These models are a little bit out of date, some of them, but still pretty recent. And this seems like a good benchmark to evaluate something that matters to a certain subset of people, if you want to read LLM generated books. How could this apply to video? That's a good question. Because video models are so far away from generating story, but I guess like in videos, we're worried about drift, right? Like we establish a character that looks a certain way, and then later in the video, the character doesn't appear at all or looks a different way. That'd be bad. But that's almost like a pixel level issue, right? I suppose the broader story level issues would be very similar, especially if we have audio in our video. Do the characters say things in the dialogue that contradict these same exact rules? Or do we Yeah, I think a lot of these would apply. Like plot elements getting abandoned, that would still apply in like a video, like a movie style generation, violation of social norms or core rules, appearances not matching, even bigger deal in the video. So I think a lot of these would also apply that you could take these same principles and you could even use it to do a text-based benchmarking of the video, right? You could take the video, you could caption all the segments, you could also transcribe the audio, and you could look for those same exact consistency errors in your generated long video. So I'm glad we came across this. Gives me some good thoughts for my video gen stuff. All right, so for those of you that are just joining that haven't been here already, I'm speed dating the papers. I've got 3 more to go in the current stack, and then we're going to crawl arXiv for some real diamonds in the rough. But anyway, I'm answering these 3 questions in this amount of time. Ready, set. How reasoning unlocks parametric knowledge in LLMs. I want to know what they mean by parametric knowledge. Maybe I should already know. So reasoning plays a natural role, but single hop factual question. So multi-hop. But yeah, how well does reasoning help on simple questions that don't require step-by-step logical decomposition, which means reasoning shouldn't be necessary in the first place, right? But the reasoning does help. So like why? Why does reasoning help even when we don't have to do anything complicated? They're going to try to answer that question. And they say reasoning expands the model's parametric knowledge boundary somehow. And they also say, this is weird, question complexity is a poor predictor of reasoning effectiveness, which is crazy because reasoning should matter more on complex questions, but they find sometimes it matters even more on simple questions. So how is it improving the parametric recall? Man, this paper has a lot of different ideas. I'm just going to have to spend longer on it than a minute, I think, to get all of them, because it's not like one method, one thing. It's actually like a step of like questions and answers. Really hard to grok that in a minute. Let's come back to it. Believe your mom. Okay, let's do this. Let's do this. Wrong button. Okay, there we go. Right button. Ready, set, believe your model. Distribution guided confidence calibration. Large reasoning models have remarkable performance with test time scaling. Prior work analyzed the internal model signals like confidence only partly indicate correctness. So they propose distributed voting, which incorporates distributional priors as another signal. So first, they decompose the mixed confidence distribution to positive and negative components with Gaussian mixture models. Then they apply a reject filter based on positive and negative samples to mitigate overlap between the distributions. Then to further alleviate the overlap, they propose stealth comp. What? So the first model the original distribution using GMM, then filter the negative samples, finally reject false positives from the positive distribution. They're trying to calibrate on how much you can trust the scores with the GMM, basically. So it's not just an ensemble voting, it's a GMM on the ensemble voting to try to remove the negatives, basically. Does it do better than the other voting methods? I'm having a little bit of trouble telling what's theirs. I assume DISGMM is theirs, their main one. The numbers seem good. I think I missed something important though in the 1 minute about what the model is and what it does. Do I want to come back to it? If the one person in the chat wants me to, I will. So you have like 30 seconds to tell me you want me to keep this. Otherwise, I'm closing it. I thought it was going to be something different than it was. That's why. What it is fine, but I don't feel like looking at it closer. I'm not seeing anything, so it's getting... Keep! Ah! Why would you do that to me? Okay, it's getting kept. Dang it. Okay, we'll go over it later. Okay. Accelerating sparse attention via cross-layer index reuse. I hope they have a good diagram. They have an algorithm. Let's look at it. So, side-by-side comparison. Standard DSA runs the lightning indexer at every layer. Index cache adds a single conditional branch, the red lines, to compute and cache fresh indices or to reuse the cached indices. I'm missing the key prior knowledge that would help me understand exactly what they're trying to cache here. So, this is specifically helping DeepSeek sparse attention, which is a lightning indexer that selects the so we have a selection of top K relevant tokens per query. They're saying that we can cache that. Like the top tokens won't change too much across subsequent steps, and we can basically slowly change the ones we compute, and we can like reuse the idea of which were the relevant tokens last time. We can keep using those and just slowly change that as the model slowly changes, because models don't change a lot over blocks over steps. That makes sense. And I think I got it pretty good in a minute. Let's upvote that guy and let's close it. All right, I need a bathroom break. And then we are going to do arXiv. I think I also need to refill my water. I start getting quite parched doing this. I may lose every viewer I have in the break. If it happens, it happens. I'll try to win him back by just being awesome at this next part. Anyway, see you guys in a minute. Okay, I'm back. Do I have anybody sitting here waiting for me? Maybe one person? Sick. We take those. Change my scene. Transition. Boom. Okay, I'm back. I'm back. I'm back. All right. What's up, people? Why is it saying my audio bitrate's low? Maybe it hasn't updated because my audio stream bitrate is 128 kbps. Maybe because I was muted, so it just wasn't getting anything. Oh yeah, 0. Yeah. Okay. Can Okay. Asking people for chat when there's 2 people is tricky, but if one of you could just say that you can hear me, that would give me like a lot of sanity. I am a little worried just because YouTube still feels the need to tell me that the audio bitrate's low. Uh, on my end, I look like I have audio, but yeah, you could really help me out by saying, yes, we hear you. Otherwise, I might open the stream on my phone real quick, listen to it, just to like give me the peace of mind, basically. Oh, I'm good. Thank you, Mr. Moltbot. Okay. Let's get some archive papers. Let's get some archive papers that like nobody else would have seen. Oh, this is nice. Look at this. I'll know what I've clicked before because things are purple. So that'll tell us what we've missed. Like we didn't look at this guy. Let's look at it, right? Should I scroll all 900 of these just looking for stuff that pops? That sounds pretty painful, but maybe that's what I'm gonna do. Yeah, like what is it about diffusion models that would make it difficult to scale chain of thought, and why don't I know off the top of my head what endogenous means? Maybe I'm dumb. Okay. Trust your critic. Okay. You know, why not? Am I going to open every paper? I might. You can't stop me. My in-laws are in town, so my wife is out with both kids looking at redwood trees. So I got some time to myself to just talk to one person potentially. Maybe just to the Moltbot. Okay, if anyone's auditing this, I'm pretty sure I'm not really talking to a Moltbot, by the way, and I'm not botting myself, just to be clear. It's like an inside joke. Okay, so visual feedback agent. Open vocabulary 3D scene generation sounds pretty awesome. So like, let's look at that, no? 2D, two-stage dual modality model for facial emotion expression recognition. That sounds scary. I'm not going to open stuff that scares me. Real world point tracking. Ooh, try to say that 5 times fast. Real world. Yeah, I can't do it. You know what I can do though? El volcán de Parangaricutiri Cuaro se quiere desparangaricutiri Cuari para el volcán de Parangaricutiri Cuaro no se desparangaricutiri. Okay, I can't do it, I guess. I can't do it. It's okay. No one here speaks Spanish anyway. For all you know, I did it fine. I didn't finish it though. It's like, para que no se desparangaricutiri mi cuarice se quiere un buen desparangaricutiri mi cuarizador. No, desparangaricutiri mi cuarizador. See, I always mess up the last part of that word. Oh, I'll say something you can understand. Pneumono ultramicroscopic silicovolcanoconiosis. Longest English word. Dang, my Spanish is good. Thank you, Sams. Do you speak Spanish? Or are you just saying that? I actually was saying gibberish, by the way. Parangaricutiri Cuaro is like Parangaricutiri. It's just a place. Oh, and apparently the phrase that this is saying is the tongue twister is "Erre de parangaricutiri mi cuaro, se quiere desparangaricutiri mi cuarizare." Oh, se quiere desparangaricutiri mi cuarizar. Oh, that's the whole thing. Cutiri mi cuarizar. Yeah, that's what it's saying. I know a bit. I'm in SoCal. Oh, nice. Yeah, this is a fun tongue twister. Do I know any other fun tongue twisters? None that are as fun as Parangaricutiri mi cuaro. And there's nothing more fun than being like a widow or whatever and saying Parangaricutiri mi cuaro because people look at you like you're crazy. But I know other ones like Pepe Pepe pecas pica papas con un pico Pepe peca pica papas. Pepe peca pica papas con un pico Pepe peca pica papas. Yeah, I can do that one. Or like tres tristes tigres tragaban trigo en un trigal en un trigal. That one sucks because I have to do tre, and like that's a sound I'm just terrible at. Good for practice though. The one I always tell people that they should work on is R con R cigarro, R con R barril. Rápido corren los carros, cargados de azúcar en ferrocarril. Because that one is like I couldn't make that sound when I started trying to learn Spanish. I had to practice that tongue twister a lot. I want to know what this is. Also, why call it NBA Avatar if you're not talking about the National Basketball Association? Me? I wouldn't do it that way personally. Ooh, we got 2 viewers. Does that mean I should say more tongue twisters in Spanish? Maybe that should be the stream. I shouldn't. Oh, I swear. I clicked all, no? I must have forgotten. Okay. See, what to do with the list of 900 papers? Does anyone know, like, an AI viewer that would, like, because I would love to just, like, open stuff. You know, like, what the heck is this? Multi-sample distillation? Why would you ever do single sample distillation? What does that even mean? Like, overfitting to a random sample, like, as a test time scaling, basically? Also, why am I clicking PDF? I guess that's okay. Uh-oh. This is, like, not the aspect I'm used to. I have to, like, look at my OBS to make sure I'm lined up. Oh, it's actually fit narrower than me. Interesting. So I can zoom in on this guy a little. I can zoom in on him even more? Hello? I think I can go even bigger. Yeah, that'll do it. Okay. The rest of these are going to be normal, though. Like, too big, right? Okay, let's get that. Yeah, we might as well just open the PDFs now, right? Why am I even opening the abs? What's the point of that? Who's that helping? Not me. Okay, let's get these ready. Let's get more papers though. And I am on Vision. I need to go to ML. I need to go to NLP. I know this. I just want to see if I can get more. Okay, interpretable. I mean, this is saying that the application's cancer, which I might not know a lot about that application space. Oh, okay. I don't know if I'm gonna look at this. No, probably not. Nope. If you want, I can explain why, but I'd rather not. Okay. Did we already look? No, we haven't. It would be purple if I'd already looked at it, so I should never ask that question ever again. I should just look at the color. Oh, what? Whose lab? I'm just seeing UMD. Do I know these people? Ang Lee? Should I know Ang Lee? Probably. Ew. Can I not type? There we go. By the way, I do think it's crazy. Like, I get that I have 1 concurrent right now, so like, whatever. Obviously, I'm not going to get a lot of stuff. I think it's crazy that I've had like 1 paper suggested from chat the entire time I've ever streamed, because hypothetically, I've had 150 unique viewers, I think, pop in at some point during some of the streams. So I'm a little surprised by that yield, because I would think that if I was the type of person to tune into such a stream, I may have seen a paper and it's like, let's just make this guy look at that. Kind of like I'm a clown and you can just make me make balloon animals for you and you get to tell me what balloon animal to make, right? It's not like, I almost feel like I'm the clown with a bunch of balloons and every time everyone's just saying surprise me. And it's like, the thing I do as a clown is I make balloon animals. I don't have taste. But I guess that is what the implication is, that everyone's here for my taste. And that's a little scary. Latent color subspace. Sounds kind of neat. So why not? Let's give it a shot. I don't like the order that the tabs are popping out in though. That's not helpful. Okay. Let me know if any of these pop out at you. I know I'm scrolling kind of slow. Omni-forcing. We've looked at some forcing. Like, forcing means something to me when we're talking about visual generation. I doubt they mean what I'm ready for them to mean. Oh, geez. How wide is this? Okay, I need to use my OBS again. Hang on to line it up. Yeah, see, I can make it bigger. I know because my portrait fits exactly. So, yeah, this is a good boundary. I did it right. Okay, sick. Closed loop robotic data generation. That sounds kind of neat too. I don't know. I don't know about you. I think that sounds cool. I might need to resize it to the regular size. Yeah. Yes. Cool. Here, I'm gonna check my stream health real quick. Stream's healthy. Sweet. Awesome. Okay. Let's find more papers. More papers. More papers. Whoa, we made it through a whole day. Granted, I'm not reading very good, but we made it. We're alive. Too vivid to... Oh, man. Okay, sorry. This, like, jumped out at me because this is, like, an issue that I feel is very under-investigated with these models is, like... And I commented on it the other day, like, it's almost like a cartoon quality, but in some ways, modern generative models are like, too good in a way. I'll give you an example of what I mean. I can pass real images and real prompts to a metric like image reward to this guy. I can pass real images and real prompts to this, and let's go to the paper maybe to see the numbers. Hang on. We're on our way. I can pass real images to this. Let's make it the right size. I can pass real images and real prompts to this and get, okay, this is a bad example. These are old models. Dang it. Okay. New models score like 0.9, not 0.26. Old models score 0.26, new models score 0.9, or 1 even. They can score really close to 1. I got real images and real prompts, and it scored 0.4. Like, there's this idea almost that the diffusion models generate stuff that's better than real. But really, it's not real at all. It doesn't look real. It has a certain fakeness, or like the title says, too vivid to be real. So I'm excited for that one. All right, let's keep looking for more stuff. Swift VLM. Why do I feel like I looked at that? If I looked at that, though, more power to me. That'll just make it even easier to get my quick pass and have it work. Doesn't say I clicked it, so maybe I've never seen it. Okay. Here, I'll put that first so that you get it soon. Or I can even do it right now. That's like a fun diversion. Yeah, let's try it. Okay, let's load up 1 minute. 1 minute on the clock. 1 cookie to help me live. Okay. Sorry, let me rinse my mouth. All right. Hopefully there's not too much cookie visible on my teeth. Efficient vision language model inference via cross-layer token bypass. So the bypass almost sounds to me like caching, but I also wonder if it just means we're going to be, it looks like there's some merging operation going on, like between layers. I'm very curious about how that merge works. And so they compare themselves to different pruning methods. It seems like they're saying that they can afford to prune even more strongly than the other methods, while if you look at like the details, they keep like more of the player numbers. They don't get as much like our random ground stuff or even stuff like in the border like these other methods. So I think they're saying that they would do a little bit better at answering the question, which this question I think is what players, you have to read the jersey basically, and it actually like has the whole jersey, which is good. Can I see more details about how they're doing this merging? Like in a, yes. Okay. So after layer X, unselected visual tokens are grouped for bypassing with the resulting merged tokens participating in subsequent computation. Okay. So there's a selection. Things aren't selected, are essentially pruned, but instead of just pruning, we merge them. And then We can restore the group tokens, enabling reevaluation of visual tokens at layers with stronger token selection capability. Okay, so there's this idea that we're going to like select tokens that are very important, merge the unimportant ones, and then later we can sort of like unmerge in order to reselect because some layers are going to be better at making the decision of which tokens to use than others. That's what I'm getting from it so far. I would like to get more from it. We will give it more time later. That's the speed date though. How did I do? You suggested that paper. What you think? Give me some thoughts. When I think I'm good at this, I am not going to be open to feedback or criticism anymore, but I don't think I'm good at it yet. So feel free to say whatever you want. We'll put it at the back for now though, because we already got it. Beyond sequential distance, intermodal distance invariant. Okay. This could be solving problems in positional encoding that I think are pretty important. Also, I think I need to increase the size of this one. Let me go to my OBS real quick. Yeah, this darned format. Yeah, I think 120 is the right one for those. Okay. That was good. Awesome. Not helpful to the improvement of the stream, but helpful for my psyche. Backdoor directions and vision transformers. Okay. Yeah, let's give that a shot. Oh, I think it's a resize angle, right? This is the ECCV format, so the number is 120. All right. Evidence-based photometric stereo, just in time. We already did just in time. Stem perception. CVPR accept. Okay. We have a good quality filter on this paper already. Also, Tinghua is a pretty good filter. Quentin, pretty good filter. Let's look at that later. Like when we're ready. Oh man, how many speed dates am I kidding myself to? The key thing here is just keeping my energy up and like not dying after the stream. Like yesterday I finished the stream and then I fell asleep on the couch for 2 hours. It's actually tiring to like just yell at you guys or gals or people, friends, folks, strangers for hours. You'd think it wouldn't be, but it is. Or maybe you'd think it would be. You're smarter than me. I would think it wouldn't be. Novel view scaling for physical AI with 3D Gaussian splatting. What do they mean by that? Not the 3D Gaussian splatting part. I know what they mean by that. I mean, like, what is it that they're doing aside from just using 3D Gaussian splatting, which you can already do to synthesize novel views? Okay, layer consistency matters. Elegant latent transition discrepancy. Okay, yeah, let's do some Gen AI detection. Why not? See, the thing about a speed date is if I can be disciplined, we can get through these guys quick. But if I can be disciplined. Sparse tax vector with hypernetworks. See, that the hypernetworks thing interests me. Okay, CVPR accept, sure. Okay, that's a quality filter. I would say I worry a bit sometimes. I feel like when you go to medical imaging or anything medical, you can end up a little quality impoverished because there's a lot of like it's very easy to get funding in that space relative to other spaces, and so like I mean, not that it being easy to funding means it'll be easy to get funding means it'll be bad. There's a lot of junk venues for that. And so you never know when you're going to be getting a good paper versus kind of a junk paper. And then sometimes the real science in the paper is that they took a CV technique from 4 years ago and applied it to some medical data. And if you already know the CV technique from 4 years ago, unless you care about that medical problem, you don't need to read that paper. So that's the issue. In image machine translation, okay. Getting back to my machine translation roots, ECCV, I'm not going to even open the OBS. It's 120%. I've learned this now. Fighting hallucinations, CVPR 2026. That's a good quality filter. This is an 85%er. There we go. If you don't know what I'm doing resizing them, I'm also streaming vertical right now, and I want to be able to clip any of this stuff at any point for shorts. Later, I will do like full screen review. I know we're taking a long time to get there. I'm planning to stream for a while today is the reason for that. Like I may just stream for until my body feels bad, which is kind of starting right now. The 2 cookies were supposed to help with that part, but it's just tiring and I'm a little sick and it's just hard. Open instance video classification. What do they mean by that? Okay, we have a problem, which is this guy is starting to dump my tabs in like random places. The hallucination papers from a friend, really? The one that I just opened and where this one? No, no, no. This one? This one. From a friend. Okay. Here. Let's do that right now. It's good to take a break from just scrolling this list. Okay. Here, I'll try to do a good job. From a friend, I'm curious, do you have friends in Canada, Australia, or Illinois? Okay, I'm only going to say it's going to be a tough date because the font's a little small in that figure, but I will do my best. Okay. Fighting hallucinations with counterfactuals, diffusion-guided perturbations for LVLM hallucination suppression. So for people that don't know what a counterfactual is, it kind of is what it sounds like. It's just a thing that's counter to fact. It's like a thing that's fake. Like, I can't really explain it in the speed date. I'll explain it after the speed date. Okay, so for the hallucinated image generation, given image I and its country caption, a GPT model is going to generate a hallucinated wrong caption. The image is then encoded by an encoder, and both forward and reverse diffusion steps are applied, conditioned on the fake caption to produce fake image. So we basically take like an actual image and a fake caption and like fakeify it. And then the LVLM encodes both images to extract hidden state pairs, and then the feature differences basically tells what the hallucination is. We take real image minus feature minus hallucinated image feature, and that's like the difference is the hallucinated part. So that's pretty cool. And then we can use SVD to stack, compute, decompose them. That's cool. And then the singular vectors are retained in hallucination basis bank. Great. Okay, that's like the trick, I guess. So we basically learn what hallucinations look like, because then we don't even need the ground truth. We get an image out. We can say we know we have this bank full of hallucinations. Is it like this, that? If it's like any of those, probably that's the hallucinated part. And I bet we can even remove the hallucinated part post hoc. That would be my guess. Because like we match that part of the vector, and then we just take it out. That's a guess. I'll look at the paper closer at the end. I just speed dated it, so it's going to the back of the stack. How did I do? You said that's your friend. Oh, and your friend's in Australia, right? No, Canada. Canada. This one was Australia. Canada. Neat. At York. Cool. In Toronto. You know what they call Toronto? LeBronto. LeBron owned that team for a long time. It was crazy. I felt like no matter who they had, until LeBron went to the West, basically it was like, how is Toronto going to lose to the Heat or to the Cavs this year? Rough time to be a fan of anyone other than the Heat or, you know, a couple of teams in the West. The Spurs, I guess. I'm trying to remember who else. Oh, this is an idea that I have, and I hope not to offend anyone here. Or maybe I do hope to offend people here. Um, Saying something like sports ball is a very fast way to signal that you are being deliberately antisocial in a very specific way. And let me clarify that first by saying that I know that I'm antisocial in certain ways. Like I'm not religious, for example, and I even left a religion I used to belong to, and that's antisocial, right? Like humans generally just don't do that. We're born in a religion, we die in a religion. Changing your mind about that is weird. So like you can choose. I think the important thing is being aware of it. Like it is important to be aware that when you do say something like sports ball, you are giving a very strong signal to people about yourself. To some people, it might be a very strong positive signal, right? Like if I tell people the religion I left and they also left that religion, suddenly it's like a very big bonding thing, right? But in a lot of other cases, it adds friction. And so I think it's just important to be careful where you signal that. Unless you're just happy randomly giving people a negative opinion of you, which you might not be, which is why I say what I said. Wow, I've opened a lot of papers. Okay, but it's fine. Like I said, I want to spend a long time streaming. Prompt-free instance unlearning. So I have a funny thought about instance unlearning, which is basically that like it is important for a lot of applications to be able to remove real data from your diffusion model's inference so that you don't like spit out copyrighted stuff. On the other hand, the problem that's really hard is perfectly recalling a real thing. Like, what if you have a diffusion model and your client is Nickelodeon and they would like you to generate episodes of SpongeBob? It is not enough to generate something that looks like SpongeBob. You must generate SpongeBob. Like, no, I'm not going to open up SpongeBob. I don't want copyright stuff. But, like, you got to put all the guy's holes in the right place, or he's not SpongeBob. So you have to recall the instance perfectly. And so I'm almost less interested in work like this because I view it as trying to do the easier problem. These models already want to forget stuff. So making them forget things is kind of just giving them what they already want to do, no? That being said, we'll look at it. Variance aware adaptive weighting. What? Let's look at that too. Okay. Sorry, I'm nervous about the format. We should try out my bias that if it's a format I haven't seen before, it's bad. We'll test it on that paper. Towards audiovisual reasoning with temporal alignment across modalities. That sounds kind of... Why did I click that? Oh, Fudan. Okay. Yeah, that's a decent little quality filter. Here, let's also like reposition this tab so it'll keep opening them close. And let's find more papers. I got new folks maybe in chat. If you're new, we are picking papers that I'm going to speed date. I'm going to spend 1 minute per paper. I'm not going to speed date any of these yet. I'm just accumulating the list. The exception is, if you give me a title of a paper in the chat, I will do the speed date immediately. So you can like shoot at my feet and make me dance. I don't know if you've ever seen Westerns. It's like, that's a trope. Or have you ever seen Easterns? Do you know what an Eastern is? Eastern's a funny concept. If you know what a Western is in the US, like a cowboy movie, that the format got kind of popular in the Soviet Union, and so they would make like their own version. Like a commentary on American culture, kind of. And I think they're called Easterns. Let me look that up on my other tab, and if I'm right, I'll show you. Eastern movie genre. Oh, Austern. Austern is the even better term. Adapts American Western conventions to Central Asian and Russian landscapes. And it was popular around the same time that Westerns and spaghetti Westerns and whatever were popular in the US. I learned that from a game I like to play. We'll also take a moment. I'm not going to become a daily game streamer. That's not my thing, but catfishing, a Wikipedia guessing game. It's so fun. You get all the tags for different Wikipedia articles, and you have to guess the article. I'm not going to play right now because I'm going to play later. And I'm also not going to get this one right because I don't know 70s film very well. Unless it's a James Bond film. Then I have a chance. I don't see James Bond in the tags though, and sometimes you would get that. Sometimes you wouldn't. Anyway. Back to science. Clinical wear lane. Okay. Wiki clip. Ooh. Efficient contrastive baseline for open domain visual entity recognition. Let's look at that. CVPR 2026. So we got a quality filter on it, which is nice. I mean, that's a sign that at least 3 or 4 people looked at this and decided it was worth our time, right? Or maybe at least one of them, the AC, thought it was worth someone's time. Okay. We looked at Intern VLU the other day. I liked that one a lot, by the way. I almost want to redo that deep dive because I think I mentioned earlier I wasn't recording the video locally the other day, which meant like I couldn't get the full lossless quality for my edits. Today, I'm fixing that mistake. I am recording the stream on device, so I will have like near lossless, as long as it fits. I'm a little nervous. I don't know how long this long stream is going to be, and I think I'll need to take a lunch break after something. I don't know what that looks like. I think I'll just go dead. I'll turn off the stream for like 30 minutes maybe and then come back, and that'll also let me see how big that first segment was. Diffusion transform with frame level matrix attention. Yeah, let's look at that. I wonder if they train that themselves or if they like tune it to be, efficient. Okay. Geez, we're not even halfway through this. Anyone got a search term they want to throw at me that I can use to filter this? I'm inclined to type video, but that's just what I like lately. That might not be what you like. Okay, I want to look at this Omni Earth. I'm vaguely interested in Earth Vision. Which is because it has so many applications. Some of them seem so maybe messed up, and some of them could be so helpful. Like, automatically detecting if you're having issues in certain fields, or like trying to figure out what areas are going to be flood prone. That stuff's good. But then there's obviously a lot of violent applications of such technology. And although I try to be pragmatic about such things, it still makes me a little uncomfortable. I don't know. Maybe that's just me not being intellectually honest. It's almost certainly me not being intellectually honest, right? Okay, vision language action model. Evolving. Evolving. The whole evolving thing's interesting. It's piqued my interest. Let's see what the heck they mean by that in a minute. Jeez, how many papers is this? Like 20, 25? I've literally just put like another half hour of time in my top bar, and yet I'm still grabbing more. Open world motion forecasting? That sounds kind of close to world modeling in a way. Oh geez, I'm having trouble dragging the tabs at this point. I've got so many open. And we still have the papers from earlier that were hypothetically deep diving. I mean, I don't know. I'm gonna have to come up with better ways to organize this, because reviving Conv next. CVPR 2026 official implementation available. Those are tags that like, because like sure maybe the transformer based stuff is superior, like if you had to pick one or the other, and transformers will certainly dominate probably your average like image encoding, decoding, diffusion, whatever. But there are tons of places and things where you will want to use convolution, including in tandem potentially with some of these transformer based things. So very interested to see how they feel like they made it more efficient, especially for diffusion, because there's a paper that I really liked that was at NeurIPS, maybe? NeurIPS, I think, which revitalizes ConvNets for scalable and efficient diffusion modeling. And this is not a date because I know this paper already, so it's unfair to speed date someone you already know. I'll still set the timer though, and instead I will do my best to tell you about a paper that I know. Let's see how that goes. Revitalizing ConvNets for scalable and efficient diffusion modeling. So in this paper, you can see by the results, if you're familiar with the literature, these are going to be ImageNet results at both 512 and 256 resolution. The top one's 512, the bottom 256. They look quite good. And if you go down to the numbers, you can compare it to the DIT. And what you should notice comparing to DIT is that it fits a lot faster. It can run at lower flops. It can run with faster runtime. And the smaller models, can even outperform it sometimes. If we scroll down to the table, we'll see the same thing. I won't spend too much time on that. What I'm trying to convey is I think that, at least in these instances, this model is better than DIT in many ways. The key difference with the DIT is twofold. First off, it readopts a UNet style shape. However, it makes the UNet more scalable because within each step of the UNet, we have these stackable transformer blocks. However, there's one difference between these blocks and transformer blocks, which is that we replace the attention with this conv module, which essentially is doing like a compact channel attention. So it's like instead of self-attention, we have this conv-based attention that's like a sparse attention mechanism. And the result is this cool paper. Anyway, that's me talking about a paper I already know in advance. Could you explain where comps will be better? I think I just covered some of it. I'm seeing more and more of this, which is like dropping a conv module into an attention-based model. And it's not necessarily always going to look like this, where our conv can totally replace all of the attention, which is what essentially happened here. Like we use the add alert norm 0 as the cross attention, and so the conv module becomes our entire self-attention. I also think, if you look at a lot of state-of-the-art diffusion pipelines still rely on VAEs, and most VAEs are still conv encoder decoder because they're so good at like simultaneous spatial compression and channel manipulation, right? Like you can have a VAE and with a couple parameters, you immediately control going from a 256 to a 128 just by manipulating the kernel size and the stride. And you can keep the size the same just by having one more thing, which is the channel parameters, which is the width. Whereas a transformer wants to take the same number of patches in and out. And natively, your transformer wants to take the same dim in and out with every single operation. So the architectures natively want to do slightly different things. Comms are also going to give you a lot of bang for your buck whenever you want locality bias. And that's obviously true in image when you have this relationship with similar regions. And that's why you could actually argue our transformer models, our VITs, already use that aspect of convolution models, right? We patchify 16 by 16 or 32 by 32 grids. What is that? It's a very sparsely striated conv. It's a convolutional locality-based prior that says content that's close to each other is going to be similar. And we put that prior in on both ends. We put it in our VIT where we say, when we're encoding, we can take those 16 by 16 grids and make that a single patch or a single word. We do it on the decoding side. Like if you look at a masked autoencoder, when it predicts the pixels, it takes a latent corresponding to a 16 by 16 region and predicts all of the pixels from that latent in a single vector. It'll, like if it's a 16 by 16 patch, you need 256 pixels. A pixel has 3 parts, RGB, that's 768. So you predict these 768 tuples and then just unroll them as your pixels. So that's a bit unnatural for some applications, right? Like saying that your pixel in the one corner is related to the other. Sometimes the conv prior, which is smoother, would be a little bit better. And so it's a little hard. There's the change from conv to transformer started with this kind of all or nothing mentality where the transformer came in with all these like tricks from NLP. And then so what happened after it came in is someone's like, well, what if you just take all the transformer tricks and apply them to CNNs, right? Actually, you can do pretty dang well, even compared to fancy transformers like Swin. And Swin actually takes some like ConvNet types ideas to make the VIT better in the first place. So why will some state-of-the-art transformers use no conv except for sort of that like patch embedding prior? It's hard for me to say. I feel like if you really want to get into the engineering and design like the best model out of existing components, like maybe if you were to do like a very dense grid search over all possible architecture, you would probably find a place for conv anywhere that uses images. Another place where there's a role for conv is I would argue that like sliding window attention is sort of implicitly convolutional, right? It reminds me of the way that we were trying to do things in natural language before attention, like before the modern definition of attention, where we would have our 1D conv where like a word would be attending to the word before it and after in the sentence. This was nice because words do indeed have these local relationships, but it's not nice because words also have these long range relationships. The same thing is happening in image, right? Yes, pixels have local relationships, which is why we can embed them in patches, but they also have long range relationships, which is why we need attention. And the big problem and the reason why you'll see transformers dominate is, I think, because this is a true statement. Like, conv can have a role. It's really hard to beat this, and the rules for how to do this are so well studied that in order to beat this, you need to equally study your rules very well, which is what that conv next paper did, right? It's like, well, we'll look at all the things that transformer does well, bring them over to conv, and change the ones that don't work so that they fit, right? But that's hard. You need a lot of time, you need a lot of compute, and it's already been done for the transformer, so the transformer's already outperforming the conv, and so more and more attention gets funneled to the thing that already works. It's a phenomenon you'll see a lot in research where something works and it kind of creates a snowball effect where once that thing does work, you do it more and more and more and more and more because it worked. Sorry, long answer to a simple question. Until I get more viewers, though, that's just going to be how it is. I get so excited when I get questions to answer that I just kind of go, I think that was a decent answer, though. Implicit geometry representations. What do they mean by this? IEEE transactions on. Okay, TPAMI. Nice. That's a good quality filter. Industrial text to 3. Okay, that sounds fancy. Let's look at that. What makes it industrial? Oh, like literally industrial. Okay. That still could be interesting. Like when I say literally industrial, if you can't see, it's like screws. So like actually for industrial application. When detectors forget forensics, bridge diff, single author paper, but the title is like kind of. No. One thing I need to do better is I would love to clip things. Like if I answer any of your questions well, I'd love to be able to clip it. So I need to get good at looking at the camera and saying your question like in a way where when I clip it, all the context is there, so I don't have to do like a ton of work in editing. I gotta get that in my head. It's not that I'm trying to farm content as much as what I am. Okay, I'll say it. The one thing I'm shamelessly trying to farm is I just want more viewers in the chat. Um, and shorts seems like a way to do that. I get more eyes on what came from the stream. It all links to the stream. I get people to show up at the stream. I also know that the stream has to be scheduled. I have to do it at the time. It got messed up this week because of my oldest daughter's soccer. Shouldn't be messed up in most other weeks. And that'll help. Just building up momentum, right? Vision language models, multi-kernel towards visual query segmentation in the wild. Sure, let's do that. I'm not just trying to do vision, by the way. We are gonna. I probably need to come. I've grabbed so many vision papers. Let's go grab some other ones. Let me put my mouth where my money is. Money where my mouth is. Um. There it is. And there it is. How many papers are you going to speed date, Matt? I don't know. All of them? Don't ask so many questions. Ooh, we already opened that guy. Okay, this one though, I'm going to exercise a little more restraint. We are going to look at like the top 10, where like these top 10 papers, let's see, did this guy even optimize for the submission time? No. Okay. We are going to cut off on people that bothered to optimize submission time, which these ones did. So we'll stick to like top 10. We already looked at neural thickets. I thought we looked at temporal straightening. I want to. That's a title I feel like I've seen. I looked at this, didn't I? Maybe on Twitter, I like it grazed my vision or something. I'm like not recognizing that figure. Okay. Forgetting. Okay, that could be neat. We'll speed date it. Amazon, UC Davis, maybe. Okay. Thursday. Special VQ for LLM compression. That makes me nervous because when quantization gets fancy, I get stupid. But let's try it. Okay. Let's look at Wednesday. Task aware representation learning for, okay, that sounds, let's see. If they submitted this 1 minute before the deadline or closer, I will look at it. Okay, they win. Oh, this is an edit. No, they still win. I will look at it, even though I have no idea what it's even saying. Like, what does that mean? What is a terrestrial carbon flux? Nervous about this one too. Ah! Okay. We are running into the problem I mentioned where it thinks I want those over there. And my tabs are getting so tiny. Help. Okay. Let's see. Impermanent. Time series forecasting. Okay. If it's within 1 minute, I'll look at it. Ooh, 1 minute on the dot. Does that count? Let's look. None of these are really optimizing the... And I'm not doing federated learning today. Why is it GAN in... Are we in ML right now? Oh, we are in ML. Okay. Okay. Monday. Hierarchical industrial when one mode multi collapse. Okay, yeah, let's look at multimodal collapse. I clear workshop accept, so it might not be like the greatest paper of all time, but That's a decent signal. Okay, we grab some ML. Granted, I don't feel like we grab necessarily what I'm looking for ML, which is like maybe more theoretical or less applied stuff. That all still felt pretty applied to me. But let's look at this. So, okay, scientific multimodal document reasoning. That's what people are doing in NLP. I guess that's what we'll look at. This is what I mean though. Like this feels so application heavy. So when you're asking me sometimes like, why don't you look at more language papers? Maybe there'll be something there for me. But long context encoder models for Polish language understanding. Ooh, I know how to say something in Polish. Noi siamo missionarze. I think that means we are missionaries. Which, don't ask me why I know that. I don't know how to say I am. Just we are. Noi siamo. I think that's we are. Two words and beyond. Ooh, a translationese paper. I used translationese in a title. I used that. Here. It looks kind of skinny, so I'm gonna like check my OBS. Okay, yeah, that's already. That's. Oh, no. I need to make it a little smaller, like 95 probably. Here, hang on. I'm curious about something. Wait, seeing if the models are good at wine? Is that what this means? That's what that word means to me. We're not going to speed date that paper. We're just going to see if it's actually a paper about wine. Okay, let's see what day. Oh my goodness, we're still on Friday. And I opened too many papers. Okay, I did want to see something real quick though. Translationese. Yeah, okay, 2015. But check this out, okay? Okay? Translationese. Let's I gotta change the sorting. Oh dang it, it just says by relevance. Okay, next page. Dang it. Next page, next page. Sorry, I got a surprise for you. Okay, it's more of a surprise for me now. I've had to go too many pages. No. How embarrassing. Ta-da! That's me! Translationese. Okay, anyway. That was terrible, though. That didn't sound Polish at all. Do you speak Polish? Sams, do you speak Polish? Okay, I'm gonna fact check you later. I'm gonna go on my Google and put in "we are" and I'm gonna make it say something to me. Actually, no, I'm gonna look right now. I'm gonna look right now. Translate Google. I swear that's how you say "we are missionaries." Here, listen to this. Oh, that's French. Polish. What? What did I learn to say? Did I learn it in Italian? I said that to Polish people. No wonder they didn't understand me. Oh my God. In my defense, I didn't have internet access at the time. I asked someone to teach me. Maybe I thought they were Polish, but they were Italian. That's crazy. Oh my goodness. No wonder I got so many weird looks from Polish people when I said that. It's not Polish. Does the Polish sound anything like it? No, it really. Oh my goodness. Okay, well, that explains something. It could be it could be Romanian. It could have been a Romanian person. Hold on. Let's try one more thing. It did look a lot like the Italian though. I don't know if you saw the Italian, but the Italian was literally siamo. And I bet like if I force it to give me we, which it doesn't want to because in those languages you wouldn't say the we, but I bet it's noi. Yeah, it was definitely Italian. I mean, we can try the Romanian. Uh, we'll try the Romanian because Romanian is gonna have similar. No. Suntem, no. It was Italian. It was siamo. Who the man? I got pranked basically. Dang, I probably looked like such an idiot. Or they thought I was Italian, or they didn't because they were Polish and didn't speak Italian, and so they just thought I was rambling at them in gibberish. Bummer. An even funnier version of that is I really did get a Polish person to teach me that, and they taught it to me in Italian just to prank me. Word recovery. Okay, sorry. Why am I scrolling? I said I would just do like top stuff. Uh, yeah, let's look at this thing that analyzes LLM as a judge. Ooh, from Tencent. Okay. Cross-modal knowledge distillation sounds neat. Let's look at that guy. Okay, I need to check my OBS though to make sure that the size is good for shorts. Yep, got it. How many papers did I open? Am I going to spend an hour on this next segment? I think I'll take my bathroom break in a minute then. Ooh, generative embeddings from large language models. That sounds pretty cool too. I'm opening too many papers from this day compared to the number of papers in my stack. I think that the answer here is I close every paper that I'm not excited to date. So it's like speed dating where like you sit down in front of the person, you're supposed to talk to them for 5 minutes, but you just get up and you go to the bathroom. That's your excuse. I'm literally about to do that. I'm going to go to the bathroom. We already have this paper open. Oh, I like model merging. I don't know it very well, but it sounds cool, and I've always wanted to do it with vision models, but they don't work quite the same as language, so I feel like it doesn't work the same. Associative creativity. I think I know what that's going to mean. I think we'll give it a try. Ngram like language models predict reading time best. I want to know what that sentence means. I know what ngrams are. I want to know what they mean by predicting reading time. Like how long it'll take to read something. I guess that's neat. That should take literally 1 minute to figure out. So we'll do it. Difficulty aware compute allocation for adaptive reasoning. I mean, it's the top one, and this is what people do in NLP, so we will read it. Okay, we need to do a quick little fix so that my paper's open like next to me. Revealing behavioral plasticity in a token, no, adaptive loops and memory. Think harder or no more. Nice. Okay, I like that. It's from an iClear workshop, but that is like along the lines of things that I've been wanting to know. Ooh, do language models know Theo has a wife? That sounds almost interesting, but I'm not opening it because I want to go to the bathroom really bad, so I want to be done picking papers. Wow, people are like, these sound like philosophy problems that they're trying to solve with these LLMs. Political evasion detection. A lot of benchmarks on this particular day, right? Metrics and benchmarks. I mean, that's a lot of what you see in NLP, especially from the academic side. It takes so many resources to actually train the models that you end up with a lot of people in the benchmarking side. Okay, I hate going to the bathroom when I have 3 concurrents because that's actually getting closer to some of our peaks, right? Um, please stay. It doesn't take me long to use the bathroom. I will be right back. Okay, I'm back. Uh, Sorry about the break. Sorry, not sorry. I mean, it's a long time to just sit in the chair sometimes. Okay, so we have a lot of papers. It is time to speed date them. Let's count so I know what I'm up against. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I'm gonna die. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52. Okay. This stream, we're finding diamonds in the rough. I am going to speed date the crap out of these papers. 1 minute per paper. And we're auditioning them. Like, are they worth our time? And I reserve the right with any of these papers to look at it, say, why the heck am I looking at this? And nuke it out of existence from my life and never think about the paper again till the day I die. Because I don't have a lot of freedom in this world. I gotta work to make money for my roof, for my kids, but I don't have to read any of these papers. That's a choice I can make. So let's do this. Oh God, we're in the NLP stuff. Okay, keep in mind, my background, computer vision, not NLP. I will do my best. Let's go. Adaptive loops and memory and transformers. Think harder or no more. So the key problem that this paper is going to address, I think, is that you can store a lot of information from your previous tokens and from previous things you've seen, or you can just spend compute on per layer looping, where each transformer block learns to iterate as hidden state, kind of like an RNN in the transformer, I suppose, via a learned halting mechanism and gated memory banks that provide additional learned storage. Okay, so here's the loop model, which is we can just loop and we can dump out state, I suppose, that we can then, like we get probabilities, and then after n passes, we get the halt probabilities, and then we weight all those different outputs, and then that gives us our output state. Or we can have a memory, both global and local, that we store. Is there an answer here? Like, what's better? Without memory, the baseline loop, isoflop 36 layer. What's isoflop? A second isoflop. It looks like the looping helps, and it looks like the memory helps. I'm not quite seeing the answer. Like, loop more or remember. It looks like the memory model is a little bit better, but it's probably more expensive. I mean, you're storing stuff. I'm not quite getting a good enough look at the trade-offs to know which you should do. They involve different kinds of compute. It looks like both of these can kind of work. Granted, they're small scale tested. I think we're looking at oh, this is bits per byte. Okay, so these are looking at what's going to be lower. Wait, actually, I don't quite understand. Is it because I don't understand the fundamental task? No, it's mathematical reasoning. Um, do they have, like, do we ever use the memory, but not the, no, I think the memory is only something we use with the looping. So we do the looping and we can also do the memory. And it looks like if we compare this loop 3 here to the isoflop, which uses the loop 3, I mean, it's better. All the numbers are better. So I guess we can say it works. Okay, that's the speed date for this paper. Well, let me look at the chat. Okay. Sorry, I gotta keep myself to a minute. There are 50 papers. Okay, what I said I want to know with this, Ngram-like language models predict reading time best. I will close this paper as soon as I know what they mean by reading time. So good expert prediction, the probabilities to calculate become worse for predicting reading time. We propose this can be explained by reading time being sensitive to simple Ngram statistics. We generate that whose predictions are most Ngram. Okay, so eye tracking based metrics of reading time on naturalistic text. So we're predicting reading time for what? Like little chunks of text? Is that a task in natural language that I just don't know? I think so. Like, we carry our analysis on the Provo corpus, an eye tracking data set and comprised of data from 470 participants. Yeah, we're just trying to predict how long it takes them to read, and apparently ngrams is better for this. What's n for the ngrams? Like, is it a 4 gram? Like, how many words do I need to predict it? Ugh, these diagrams are so tiny. But I said I would close it when I answer the question. They are literally predicting how long it takes to read something. And it is kind of funny that the simple statistical model, they say, outperforms the LLM for such prediction. I guess it kind of makes sense because you're predicting such a simple statistical quantity, which is like what is basically the length for these pattern of words. It's a very simple pattern, and Ngrams should do well with that. Okay, testing LLMs for associative creativity. So we are trying to see, man, not very visual. Generate sets of paths connecting concepts and models parametric knowledge. Paths should have high specificity and diversity. Great. So they should be both specific and different from other things. And the models will score better if they produce strong, diverse paths. So, okay, yeah, we don't want to be different and be vague. We want to be specific and be different. And so that's what they're testing, basically. I think that gives me the gist of it. Model generated paths compare against population paths. Case study. What models do the best at this? Model performance, we report the creative utility at patients and different patiences, and GPT-5 scores the highest. Where's the score? Is this the score? I think this is the score here, yeah. Wow. If that's true, then it like just totally destroys the other things. But it's also a lot longer. And I don't know if long is necessarily creative. I suppose if the details are good, then it's creative. That'll do it for that paper. Good speed date. Or maybe not good. I felt comfortable. And what more can you ask for on a date other than feeling comfortable? Maybe feeling titillated. I don't know. It's a very weird word. All right, model merging. Yeah. Oh, this is like a survey. Is it? Oh, wait. Yeah, it's a survey. Okay, sorry, we're not dating survey papers. That's out of scope. You can read that thing though, if you want to later. Not right now. Please stay. Read with me. Read your own stuff later. Okay. Efficient cross-modal knowledge distillation to language models from black box teachers. Okay, since we're distilling from images, that makes me think that the teachers are going to be some vision models. Oh my, okay, starting over because I right-clicked. We lost 15 seconds to that right-click. I gotta be careful with my mouse. From images to words, efficient cross-modal knowledge distillation to language models from black box teachers. Since we're going to language and it says from image, I'm assuming we have some kind of vision encoders. Let's see if I can find them in the text. So they're improving models such as dBird, OPT, and Llama. But what are the vision teachers that they're using for this cross-modal distillation? Do they have a diagram? The teacher model could be a text-to-image model. Oh, so like a diffusion model. We get an image embedding. Then we want to align our language model, our student, with that teacher output to say that the embeddings kind of resemble the image somehow. That's crazy. What are our actual teachers? Like what diffusion models are we using for this? Student and teachers. Okay, we already said what the students are. Where are the teachers? The teachers. I can't find this in 1 minute. Oh, I'm running out of time for the date. Stable diffusion 1.4. Oh, geez. Old models. Dang. Okay. I wish I could have seen it with more recent models, but it seems effective based on the numbers, and it's a fun idea. It's a little weird, though, because, like, in general, as an image person, I feel like language models are better than vision models. So what can you really distill that's helpful? But looking at these numbers, it would seem that generally you can perform better in most categories by doing this distillation. Okay. Let's keep dating. For everyone that hasn't joined before, I'm trying to answer a few basic questions of the paper with just a minute, and I've never seen the paper before. I did pick it based on the title, but that's all I've done. So let's learn beyond the illusion of consensus from surface heuristics to knowledge ground evaluation in LLM as a judge. So now what it's saying is normally in LLM as a judge, if you want to make it better, you just throw more LLMs at it. Either more of the same one with like different seed or randomness, or like lots of different powerful ones. But it's saying we're going to somehow go beyond that. How? First, there's a phenomenon where LLM judges generate sophisticated critiques yet anchor scores on shared surface heuristics rather than substantive quality. How do they show that? They show that model level agreement, that merely sharing rubric structure restores 60% of total agreement, and that high quality outputs paradoxically receive the least consistent evaluations. Oh, interesting. So you would expect high quality outputs to be more consistent, but in reality they're less. So they demonstrate that dynamically generating rubrics, which are ground in domain knowledge, gives a better assessment. Okay, so we're going to basically per sample tell the judges what to judge, and as long as it's more sample specific, you'll get responses that better correlate to the thing you're actually judging. That makes sense, and that could also improve, similar to another paper we saw, the density, which is better if you want to use these judges as like an RL supervision. 1 minute. Generative embeddings from large language models. Let's see what I can learn about this paper in 1 minute. So we do some data generation with unlabeled queries. The LLM generates responses which are embedded by an unsupervised teacher. So, okay, so we can have it generate like essays about the Red Cross. Okay, so there's trainable thought and compression tokens which are going to append to the queries, and those are going to be learnable the whole time while the LLM is kept frozen. And the compression tokens hidden states are optimized via reconstruction loss. Reconstruction loss with what? Reconstruct the response from soft prompts. What? What? Reconstruct the response through what? Where is that? Like through this MLP? Out of the LLM at the end? Huh? Really? Okay, that's interesting. And so then we're going to say like it's embedding the original prompt basically? What? Oh man. Semantically distinct queries belong to the same category. Input-centric encoders place them far apart, but their LLM responds to more similarly closer representations and encodes the response rather than the input. Okay, so is this a way to essentially encode the response given the input? Which would mean that we could simultaneously get like the responses to the question and also the things that are most relevant to the question, because the response tends to be more relevant to the question than the question itself. That's like the general idea I get from this. Not sure if I'm right, but it sounds fun to me, so I almost don't care if I'm wrong. And part of the point of reading these papers too is to get ideas. So if I have an idea that I feel good about from reading the paper, I don't always care if it's not what the paper is saying. Unless I'm reviewing the paper, like for the conference. Then I need to know exactly what it's saying, right? But for this 1 minute speed date, do I need to know? No. Like if the paper makes me think something that's cool, it's good enough for me. It's more than I deserve to get out of 1 minute with the paper. So playing with house money. All right. Difficulty-aware compute allocation for adaptive reasoning. So scaling inference time compute significantly. Yeah, scaling inference time compute gives better performance. But yeah, we read the different paper about this. You overthink simple problems. Sometimes you need to think more on the simple, apparently. That's what the other paper said. So how can we adaptively compute allocate across difficulty levels? See, this is where they're going to run into trouble, because the other paper showed us sometimes more compute isn't even better for the complex, and vice versa. So, but they do prove on easy tasks, extra tokens yield marginal gains. So they achieve optimal accuracy at minimal cost by avoiding unnecessary reasoning. And it's fair. If they do measure the complexity, like from an ends-based perspective, looking at the complexity of the question based on the tendency of the model to get it wrong, then they'll look at it from the right perspective for the model, right? Which is use more compute where the model struggles. But if they look at it like from a means-based perspective, just trying to look at how complex the question really is, then I would expect them to fail more. But we can see the deltas here. They're all green. So I suppose this approach does work. And it sounds reasonable, so that doesn't surprise me that it works. Next. Okay. Assessing sommelier expertise of language models. Is this really about wine? Wine theory question answering, wine feature completion, food wine pairing. Holy crap, this is wine. I said I was only going to look at this until I knew wine. We have a Raider plot, and it's all wine. Maybe wine is all you need. The taxonomy of wine expertise. Categories into, wow, we've got the categories and subcategories specifically for wine. It's multilingual. And do I have examples from this wine benchmark? Please, 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 examples? No? I only have 1 minute to date you. Oh my goodness, but it's not English. Act as an expert wine taster. Your task is to answer the following multiple choice question. That, give me a question, guys. Help. Oh, what does suma, whatever the heck that is, mean? Sparkling, still, semi-sparkling, flat. Correct answer. What is the term for, so we're just seeing what it knows? Basic wine terminology, intermediate knowledge, advanced understanding, expert level. Oh, interesting. Okay, cool. Wine, I guess. Yeah. That's, I guess, what should you expect? A paper tells you it's going to be about wine, and it's about wine. Shocking. Translationese is a rational response to translation test difficulty. I think it's saying that you're going to get a more translatedness score when things are even harder. Translation test difficulty is conceptualized as comprising source text and cross-lingual transfer components. We use bidirectional English. Okay, whatever. Let's try. Source side features used to model source text comprehension difficulty grouped by feature type. So tree depth, branching, mean dependency. Oh goodness, it's been a while since I did machine translation. Blue, I know blue, which is like an engram alignment basically used to measure the quality. It's a little bit like, it can correlate better to human quality than you would think, like human judgment, but it's got lots of problems. Man, I do not know enough machine translation to get the good stuff out of this in a minute, which is a bummer because I bet it's decent. I think I got the main idea out just in the abstract though, which is that you're going to get more translationese, which means, okay, translationese is the idea that like your machine is sort of speaking a different language than you when it translates because it's like squeezed probabilistically to not have the same diversity of patterns, both in like word choice and syntax as human speech would. And so this is basically saying, I think that the harder it is to translate, the more likely the model is to have those like collapsed patterns where it doesn't use a very wide range of words to express itself. And the patterns are also quite limited. Which the fact that translationese even exists, by the way, is the reason that AI detectors work. If models didn't already sort of have probabilistically speaking their own language, then you wouldn't be able to put anything into GPT-0. And yeah, wine is all you need. Amen. Nice. Anyway, so that's what that paper was getting at. Benchmarking and advancing scientific multimodal document reasoning. So we have a faithfulness realism dilemma where existing approaches, so simplifying context ensures faithfulness but lacks the real world complexity, while generating directly from full documents ensures realism but risks hallucination. Okay, so they decouple the objectives into synthesizing and regrounding. So you first have to synthesize something that's very detailed, and then you reground it, because if you want to keep it grounded in the first place, it'll be too basic, I guess. So they first have the faithful synthesis, then the realistic reconstruction, because a realistic document is going to be detailed. I guess that's the idea. But I'm missing, like, I think they're synthesizing data, high quality trustworthy data by reducing task difficulty, and then construct complex reasoning, realistic training instances for the full document. I want to see examples. That's the main thing I want to see at this point. And I'm not seeing it. Okay, I'm not feeling it on this one. Sorry, everybody. AI detectors work? That's a great question, Sams. I did say they work. They work to an extent. Like, they don't work in two ways. One way that they don't work is that everything an AI will ever generate is something that you could have generated. Like, even if it's funky stuff in a video, you could have gone into Blender and made the 3D guy with 6 fingers and spent days making it photorealistic, right? So even the crazy stuff that AI would generate, you could do it yourself. In language, it's even more obvious that you could do it yourself, right? Like, it's learning patterns from human language. Clearly, there exist humans that talk that way. So in that trivial sense, they don't work. Like, there's always going to be some false positive rate because there has to be. The only way you could ever convince me that there's probably a trivial low false positive rate is if you're watermarking in the language space. But for the watermarking to be reliable, the passages need to be long enough. And that's tricky and hardly going to happen. And then the watermarking will start to break as soon as people start to change single words. Which, granted, that'll kind of break the AI detectors too. The other reason that I think conceptually a detector doesn't quite work is a detector can only stay ahead of models that already exist. Because as soon as a detector does exist, you can train a model with the detector in the loop and basically just train the model until it breaks the detector. So a detector, the fact that detectors should exist kind of goes back to GANs. It's just an arms race. And maybe at the time GANs came out, your discriminator will always be stronger because it's hard to generate an image. But these days, LLMs can generate great text. And so if you have a model whose whole job is to be like, well, this is good text, this is great text, then obviously you're going to have issues with your AI detectors because they exist. And a lab knows they exist and they can use them to train. If they care to beat the detectors, which that's ethically specious. Maybe big labs should let the detectors keep working. But then every time I change my RL, like my post-training, I don't need to pre-train my LLM. Simply, like, RL post-training is changing the way the model samples, which is going to change the patterns in the words, should have negative interactions with the detectors. So detectors will work as long as language becomes impoverished coming out of an LLM in like specific ways that you can recognize. But as soon as those ways shift, or as they continue to vanish, the detector becomes more and more useless. And the bigger problem with detectors too is that like schools want to use detectors as an excuse to put you in jail. And I think that the bar that they have for how well a detector works is a lot lower than it needs to be, considering how much they're willing to punish you based on the detector's output. Long-winded, but that's my thought about detectors. So what I dislike is that detectors are marketed the way that they are, because I know people that have written their own work and been pulled into academic review because of the output of a detector. And to me, that is just wrong. Like, it's nice to hype up our research when we're just signaling about it to each other, but evidently people that know none of what we know have picked up on the signals that we have intentionally dropped, um, and they use it to do very bad things. And putting a student in front of a committee because the detector said something, in my opinion, is just not okay. And I think that we as researchers need to do a slightly better job at signaling that while these tools maybe exist and have their uses, they are simply not good enough to ever be used in that context. Maybe you can use it to try to help, but like it's very sketchy and I don't like it. And I know for a fact, I know people that have been brought forward when nobody other than a machine said that there was something wrong with their work. And that, yeah, we need to have higher standards for ourselves, I think, in the way that we as researchers communicate with people out of the field about the capabilities of our tools. And a lot of AI detector people fail that test for me. Okay. Uh, for anyone that's just joining the stream that hasn't been here before, what I'm doing right now is I'm speed dating papers. I've got a list up here, 40 more papers to go. I'm spending a minute on them. I'm answering these questions. I'm also answering your chats. So it's mostly me and Sam's just talking about stuff right now. But anyone else, feel free. Ask me a question. Ask me anything. Also, suggest papers to me. If you say a paper, I will open it right now and I will spend at least 1 minute on it. And if I like it, I'll put it in a list or I'm coming back to it after I eat a late lunch. And so even if you don't stay in the stream, you can come back to the VOD later, or maybe I'll do so well in my deep dive of that paper that it even makes it to a long form video. We'll see. But anyway, that's the flavor of the stream. Let me take a drink and a deep breath and I'll keep going. Okay. So when one modality rules them all, backdoor modality collapse in multimodal diffusion models. So I want to understand what they mean by backdoor. Like, are they doing, okay, overview of multimodal diffusion backdoors. We illustrate a generic multimodal backdoor setting using an image text pair as an example. Diffusion models condition on multiple, okay, so what's their trigger? A poisoned image, okay. So an image trigger such as eyeglasses, like putting eyeglasses in the image, while the other mode is a cleaner poisoned text, a trigger such as anonymous, highlight, and red. Okay, so they have some triggers in the image and the text. If you know the field, you know what the triggers mean, but what are they saying? Backdoor modality collapse pairs A and B show no backdoor activation, whereas C and D activate the backdoor. So triggers injection in certain mode. Oh, so they're saying it's just very hard to get like your trigger. Well, of course A shows no trigger, shows no backdoor activation. Are they just saying it's hard to poison the image? Is that all we're saying here? Is that it's hard to condition your backdoor to where the image trigger works? I guess they eventually figured out though, right? Because we can see here, no, they're not, they're showing that's the target. What is the actual generated? I want to see if they ever get this working. So text trigger, text backdoor. So when we use an image trigger and a text backdoor, we get, so in general, the text backdoor is working. And the image trigger, no, it's been too long since I was in this space for me to really understand what's going on here. I'm going to go on to the next paper. By the way, I'm going to do a lot of that. Like if I'm just not feeling it, and I need to do this better. When the minute ends up, I just got to go to the next one. We have too many papers. The idea though, remember, is I'm trying to answer these 3 questions. I'll fail a lot. It's hard. A live benchmark for temporal generalization time series forecasting. Time series forecasting, not something I'm so familiar with. Let's see what we can do. Let's start with the abstract. Pre-trained foundation models for time series. Most use static train test splits, but you can contaminate those because they intervally, the foundation model itself trained on test data. So they have a live benchmark that is going to take something that currently exists, like something we don't know the outcome yet. So you know it's not poisoned. Where is that coming from though? Like what is the actual live data? Like what kind of thing is it? So man, that's what I really want to see. So they introduced impermanent, which I think is saying we'll actually do live, like live in the wild prediction, but I'm missing where they scrape this. Does anyone see it right now? I feel like this should be a lot easier than it is to see. Um, we get the key idea though. The research problem is train contamination in your foundation models. The solution is live benchmarks. I suppose they're saying this works. and they're re-benchmarking models accordingly. I guess you kind of have to take their word for it, right? Because how would you prove it doesn't work? It's a little hard to prove contamination sometimes. Whereas it's easier to test that it worked. Okay, self-distilled reasoner, on policy self-distillation. Sure, let's look at this, Sams. Whoa, 3 citations already for a Jan 26 paper. That's not bad. All right. Okay, viewer suggested paper. I hope I do well. Sip of water. RL. So off the dome, I don't think I'm going to do well, but let's see. Knowledge distillation. Okay, on policy self-distillation for large language models. So we are trying to do some kind of distillation from a language model to itself. On policy suggests some kind of RL context. So 2 policies from the same LLM student and teacher. The student generates on policy response. Both policies then evaluate the trajectory to produce the next token distributions. The learning objective minimizes the per token divergence along the student's rollout. The divergence here can be measured in various ways. The gradients propagate only through the student's logics, allowing the model to self-distill. Okay. Is there an EMA with the teacher, or is the teacher kept frozen? That's something I kind of want to know. Comparison of training methods for reasoning tasks. On policy self-distillation combines the advantages of on policy. Okay, so we can use on policy data. We get a dense learning signal. We get a low sampling cost, and we get no external teacher, which is they're saying is like the best of all worlds for post-training. Prompt example for student teacher policies. Both policies share the same parameters, but different condition context. The teacher receives a ground truth solution as privileged information. Ah, okay. That's the whole secret sauce. We found it. Boom. Perfect. Okay. So we're trying to get the student to answer as well as somebody that's basically cheating, right? I think so. Yeah. Okay, cool. And I got it right at the end of the minute. What first time here? Why only 1 minute per paper? That's a great question. I think I should probably post something long form to the channel too, just so that there's something you can always reference. There's a lot of answers. Short answer, it's fun for me. Like it's a challenge, right? Second answer, I can farm shorts. Do I care about the shorts? No, but I want to make this audience bigger. And if I can get shorts out that people think are cool, they'll be like, oh, what stream is that from? And then they'll come to the stream. Because like right now there's 5 of you. At some points I've had 0. At a lot of points I've had 1. I would like it to be closer to like, I hate to say this out loud, but like 30 maybe. So how do I get there? I get there through like reach. And so this is a way to reach. Another thing is I feel like something that a lot of people just aren't very good at, including me, I'm trying to get better, is how to keep up with the massive amount of papers that there are. And it's really hard to keep up with papers if it's going to take you a really long time to even know if you want to spend time on the paper. And so the point of this, we're speed dating the paper. So it's like, I'm going to spend a minute, try to figure out what the paper's about. And based on what it's about, I'm either like, okay, cool, I learned something in 1 minute. That's awesome. Or maybe I want to look a little closer. And then I'll put it, we have a whole pile over here of papers we'll do deep dives on later. So that's the idea. It's fun. It's challenge. I hope that it's kind of engaging content. And then it's a filter for stuff we want to look even closer at. So what it allows me to do is instead of relying only on Hugging Face votes or only on viewer recommendations, we can find a good stack of papers to spend time on, like while giving them sort of this fair chance. You know, their title engaged me enough to open. And now with just 1 minute, we figure out, does it deserve a closer look? I hope that answers your question. And so it's also me doing some of the dirty work of like figuring out what good papers are to do longer technical explanations for you, the audience. And this is your chance to sort of be in the behind the scenes, shoving papers in front of my face and then seeing how I do, making fun of me when I don't understand the paper in a minute. But yeah, this was actually an idea from a viewer, and I think it's a decent idea. I'm definitely going to try it a bit more before I simply give up on it, because the alternative to doing this is just picking fewer papers in the first place. And I like this because it allows me to cast a wide net and potentially, like the theme of today's stream even is today we are not opening anything that was very highly upvoted, except for maybe 2 things because I missed them before. Today we're looking at like lower voted things on Hugging Face, and like all of these papers right now are just things I found on arXiv. And so we have no quality signal except for the ones that told me they were accepted to conference. And in some cases, we even have negative quality signals. Like we have papers coming up in formats that I know apply to one conference, but we're like not at the time for that conference to have happened, and they're not accepted to the conference. So some of these papers I kind of know beforehand were probably rejected from some venue, right? Anyway, long explanation. Hope that helps. Let me know what you think. And I'll take another drink because now I am thirsty again. Gotta drink a lot of water to stay like fresh in these. There's a streamer I like, a gaming streamer that's observing Ramadan right now, and I feel terrible for him because it's like if I don't get water like every minute or so, I dry up. Like it's hard to just talk. Anyway, generative drifting is secretly score matching, a spectral and variational perspective. Generative drifting. Okay, under a Gaussian kernel, the drift operator is exactly a score difference on smooth distributions. Okay. Oh, so it's talking about one-step image generation, I think, right? Generative modeling via drifting, yet the success is largely empirical and theoretical. Okay, so they're trying to explore the theoretical foundations basically of this other paper. And they show that whether a vanishing drift guarantees. Okay, so they're saying that they're answering these three questions. I think that they're going to be answering them primarily through theory. Let's see if there's any figures that we can understand at a glance in these remaining 20 seconds. Lost landscapes with and without stop gradient, project on the two principal component directions. That's not going to mean anything to us without context. Are there any numbers? I think they're saying that the other paper has the numbers, and this just attempts to be the theoretical explanation. I'm not saying that's bad, but this would take me so long to do a good job with in this kind of stream that I think it's a close angle. I bet it's a great paper. But we are going to stick to things that I feel like I can get something out of in like a 10 to 20 minute deep dive. And I know my own limits, and that paper is just not one of them. So that's more a fact about me than a fact about the paper. Yeah, reading through every abstract in NeurIPS 2024. I remember, I don't think he does it anymore, but Carpathy once upon a time would go over like all the abstracts from top conferences. I think he stopped when the conferences got too big because eventually it becomes just overwhelming. But yeah, it's effective for grokking what different people are working on. And one thing that's fun about this is if you stay enough, you'll notice some of the times I get to the middle of the paper and we can recall things that we talked about just like an hour ago, and they'll be quite relevant and sort of informing each other. And the papers have nice interactions with each other. It kind of gives you a nice snapshot of the moment. It also makes things stick out like a sore thumb, though, if they're like already outdated. Like if they're working on old questions or using old data, or like they haven't updated on like new things that other people already found. That becomes very apparent. And I try not to be too mean about it in the moment. Maybe I should be meaner, but that happens too. Okay, task-aware modulation using representational learning for upscaling of terrestrial carbon fluxes. What on earth is a terrestrial carbon flux? It's the first thing I have to learn. Robustness and transferability of global carbon flux estimates. Is this just talking about like how much carbon dioxide places emit? Could that be? Are they going to explain? Oh my goodness. So many science words. This stuff makes me feel like I don't do science. Okay, so they're doing some kind of architecture with RNNs, with LSTMs. They have a plot that would be too dense for me to read, even were I to zoom in. Actually, these lines are very thin and the colors aren't too divergent. They've got a plot whose format I'm not... Okay, so yeah, I said I'd close some of these before the minute. And I'll hold myself to my word, because, like, ain't nobody got time for that. All right. Leech lattice vector quantization for efficient LLM compression. So we are going to try to quantize our LLMs with something called a leech lattice vector. I actually reviewed some quantization papers recently, but they take time for me to understand what's going on. Like, time that makes it really hard to surface anything good for you in this. And sometimes they'll give a nice like visual representation of it, but sometimes you just got to read the math to really understand. And I've already wasted 30 seconds saying that. So the paper with its optimal sphere packing and kissing configurations at 24 dimensions. Yeah, I'm not going to get this in a minute or even longer than a minute. I know how long it takes me to review these because I review them, and it is long and boring. And that is another thing. I kind of have to optimize for not boring for the sake of the stream. Temporal straightening for latent planning. Learning good representations is essential for latent planning with world models. I agree. When pre-trained visual encoders have strong semantic features, they might not be tailored to planning because they contain irrelevant information. That's true. And irrelevant information can often be detrimental when you're talking about deep learning models. So they use a curvature regularizer that encourages straightened latent trajectories. Okay. Basically saying that a straight trajectory is going to be better than a curvy one. So latent trajectories encoded by a pre-trained visual encoder like Dino. This is the PCA. They're very curved, whereas they produce ones that are straighter and even go through the bottleneck better. I'm not sure what exactly they mean by the bottleneck. I know you can have bottlenecks in trajectories with actions where like if you don't, you can do lots of things, but then if you don't do the one thing right, you fail. It's like you can move your hand all over to pick up your cup, but at some point you got to grab the cup, right? That's the bottleneck. And so I guess it's better to be straighter. So theirs do look straighter. How do they actually train it though? They train it with an encoder with a stop grad, And it looks kind of like a JPA, kind of, honestly. Minimize the prediction loss between a predicted embedding and a target with the stop grid and the target branch, kind of like a SimSciM too. And minimize the local curvature of embeddings. Sorry, where's the part where we're minimizing curvature? Anyone see that? Is that maybe a loss here somewhere? Maybe here. Oh, literally the angle. You have latent velocity vectors, and you just minimize the angle, which is maximizing the cosine similarity because that means same angle, right? Okay. Wait, they say latent trajectories, but are these just the latent representations? Wait, no. These are the consecutive latents, and then the velocity is just like the difference, and then they take two velocities, the cosine distance, and just maximize it. That's cool. I don't see it represented in the figure, but that's neat, and I think we understand the gist of this, even though I over speed dated it. That sounds like a good idea. So let's look at results real quick, and then I'll have a 2 to 3 minute date instead of a 1 minute. This is like when you go to the speed dating convention and the guy's yelling at you to switch, and there's like someone standing right next to you trying to take your seat, tapping your shoulder, but like you keep talking to the person. Very not okay. But I'm allowed to do it because this is my stream. Geez, okay. I need a table. I need a table. Okay. So when we're using the DynaV2, CLS or patch tokens, or even adding projections, we get all these results. But then when we do the ResNet from scratch, our metrics all go up. Yep, up. Good metrics. Seems to work. The idea makes enough sense to me. It would certainly be interesting to see how it worked more at scale, right? Like a ResNet that you train for a little bit, we'll even look at the number of parameters, like is not going to have tons of like in-depth reasoning world model capabilities. But it's certainly an interesting idea that you need to make the trajectory just go more smoothly and not just jump around according to the semantics, or you're just making your planning model have to fight really hard in order to make good predictions. I'm sorry, I'm looking for the parameters. I don't know why I'm looking here. They'll be in like at the top of experiments, I guess. Okay, so DynaV2, did they say which one? Like the VITBL? No? Oh wow, apparently the DynaV2 outperforms the DynaV3 and the VJPA. I guess because the semantics are just so detrimental, maybe? What are the... Maybe I'm not going to spend more time on it. It must be in the appendix, or if not, in the code, I guess. Sorry, let me check chat. I've been doing a bad job. Okay. No one said anything. I don't know if that's a good thing or a bad thing. It means I didn't miss anything. A quantitative characterization of forgetting in post-training. So yeah, when you post-train a model, you're trying to like change how it samples things, but it'll naturally forget things. Okay, so how do they fix this? So we further quantify how replaying our these objectives, and we analyze 3 recently proposed neuron policy post-training methods, SDFT, TT-Discover, and OAPL. So there's going to be some test time training where we keep like the fast weight matrix. There's going to be a couple other strategies. Do they propose their own? It doesn't look like it. It looks like maybe they're just going to evaluate like how well they do and compare them to each other. They're going to define it mathematically. I am not going to manage that in the speed date, nor do I really want to. Okay, I'm not going to finish that. Next, toward visual query segmentation in the wild. Oh, I wanted to see this one because it sounds like things that I like. In this paper, we introduce visual query segmentation, which is a new paradigm of visual query localization that aims to segment all pixel-level occurrences of an object of interest in untrimmed video. This is a hard problem because you both have to find the place and the space, and you need a model that's encoding both well. So it's the first benchmark designed for VQS, and to stimulate further research, they presented a simple baseline which uses a SAM. It extends SAM2 by leveraging target-specific and background distractor cues from the video to progressively evolve the memory. In all the experience, they achieve promising results and surpass all existing approaches. Let's look at this. Oh man, that's small. That makes it hard to see. So current VQL paradigm localizes the last target occurrence using a bounding box, but they want to segment it with pixels, and instead of predicting the last target occurrence, they want to predict all occurrences. They say the current approaches ignore the earlier occurrences. And it looks like they're like baseline approach. Nope, wrong thing. Wrong thing. We want to see how good it is. Table. Boom, it's the best. What do you know? They designed a task and their model for the task beats the other ones. Shocking, right? Design your own task, beat everything else. So what's critical of these papers is if you are going to propose your own task and expect me to buy it, it needs to be good. And so that's why the figure we did spend time on was so important, right? They sold me, at least maybe I shouldn't have been sold, but I was, that it's bad to ignore earlier instances, and it's both harder and more important to be able to predict at the pixel level rather than object. That part less important to me, by the way, because if you have an object, you can already refine it better with just like some like pixel head, right? That's not too hard. But the ignoring is one thing. So it's better to, I suppose, improve the benchmark a little bit. I got a chat message. Hey, Matt, have you read the recent LeJapa introducing the SIGREG loss? I'm an undergrad student from Brazil with serious GPU problems and maybe it's a good direction. What do you think? Yeah, it could be. I mean, part of what they said in the method, did they release the code yet, by the way? But supposedly, like the really interesting thing about the LeJapa, I'll open it. Why not? So it's both a thing I like about it and a thing that I don't like about it. The thing that I don't like about it is like, it doesn't work on things that matter to most people. It does not even remotely compete with the state of the art on anything, right? Like, let's look at some results. If we look at the, like, these are all ImageNet results, right? For VITL, like, these aren't good for ImageNet. With the VITL, I have models that can get 87% on ImageNet. You know, we're not in 70s, we're at 87. So one question I would almost ask of it is like, why can't you get 87s? Why are you stuck at 70s? But the thing that it does do really well is you can train it on like just your downstream data set and ignore the expensive pre-training. And in that setting, you can do quite well. Let's see. I'm not sure. I think this is downstream here, but I believe they have some things where they train only on the post data. And I'm trying to find it. This is my recollection from having read it before. Let's see. Let's make sure that I'm correct in what I'm saying. Giving hot takes about famous papers is dangerous because I could like randomly get subtweeted by somebody with like 1 million followers. And that's kind of terrifying. Where is it that they explain the experimental setup, which I am recalling having read the paper months ago? Oh yeah, it's also cool that they're able to like simplify the pipeline quite a bit, removing a lot of the other like heuristics and training it in like a pretty simple way, I guess. In domain, there we go. In domain LeJapa. Okay, 6.3. So a key promise of self-supervised learning is to learn universal representations that generalize, but current frontier foundation models are pre-trained on natural images. So in specialized domain, you would take that foundation model and then like post-train on your thing. But like when you do fine-tune the model, it's a little dangerous to tune all the weights because they just kind of don't want to do that. And the number of samples you have is so small that you might just create some like memorization collapse. So to demonstrate its effectiveness, they compared the latest DynaV2, DynaV3, and iJapa, where they do in-domain pre-training with LeJapa. That's figure 12. So this is where you're getting, in my opinion, your most bang for buck with LeJapa. Is like you can look at all the LeJapa ones. LeJapa is like the oranger ones, and then the big dynos are the blue. And whether you're talking about frozen backbone or full fine tuning, it soundly beats for both. Even when you're training on the full data set, there's this outperformance. And so it's very good for like the in-domain self-supervised pre-training, which is something that these more data-hungry methods are worse on. And so I guess my haven't thought about it for a very long hot take is I felt like this was a method that has a very satisfying performance on in-domain data where it doesn't require a bunch of irrelevant data just to do well in a downstream task. The thing that's not satisfying to me at all, though, is why can't we get a state-of-the-art ImageNet number out of this? Like, why doesn't it handle big data as well as the other methods? And in an age where I have 50 billion image data sets to train on, do I want a model whose vanishing returns happen at like 100,000 samples? You know, that's my issue with LeJapa. But for someone that doesn't necessarily have as many GPUs, something that will give you good results in domain, which is fewer samples, so that's less time on your GPU, is a very promising thing that you could potentially do research on. So that's the answer to your question, Lone. Long answer, but it's an answer. Hope it helps. And let me know if it doesn't. We're free to follow up. Okay, so on those more mathematical papers that you said were hard for you to read, Do you end up going through them if necessary? I absolutely do if they're in my area. I absolutely do not if they're not in my area. Why would I go over them if they're not in my area, I guess, is one thing I would say. And then the other thing is, so computer vision has been a discipline that feels very empirical for quite some time. And so when there's theory without results, it sometimes feels like I simply don't need to think about it too hard because the results aren't there. And I might be missing out sometimes by ignoring things that I can't see good results for, but there's enough work to do just empirical that I feel like you can kind of get away ignoring some of the less proven theory. But you bring different things to the table. There are really cool things that'll happen just in the theory space. And there are things that you will miss if you're not reading okay, reading the theory papers just expands your net. Sometimes people will seem to have proved things in theory that are just wrong. And it's wrong because they over constrain it. Like you'll often see things when you're reviewing these diffusion papers that are like, let us assume that this is Gaussian about a thing that isn't Gaussian. And so then it's like, well, if your method worked, then sure, I have to figure out this paper is useful somehow. Something you did worked. But if it didn't work, then probably that assumption's too tight. And the issue is sometimes you run into the trap where that assumption is introduced at like step 11 of a 20-step proof. And I've sunk a lot of time at that point. So the answer is yes. Sometimes you just have to read math papers. And if you like math, read all of them, right? And then hopefully you'll be able to tell a lot quicker than me which ones are just making bad assumptions or wrong. But I do think it's scary too. If you don't step away from the math and go to the practice, you might not realize when some of those assumptions are beginning to violate reality. That's the main thing to keep in mind when you're looking at the math papers. Be very skeptical of their assumptions unless you can already see that the results are great. Because if the results aren't great, especially if it's an industry math paper and you know they have access to the compute, you should really be scrutinizing like, there should be good results here. What's going on? What's missing? What am I missing? What's wrong here? That's the idea I have with math papers. Anyway, I think I need another bathroom break, but concurrence is pretty high. So I'm going to do my best for a little bit. But that's in my near future, just FYI. It'll be like I'll step away for 2-3 minutes. I'll come back. I'm drinking a lot of water is the problem. It's like I got to keep my voice dry, but I got to stay at the desk. Sorry, I got to keep my voice like not dry. I also got to stay at the desk. So I'm like chugging water, bathroom breaks, whatever. I also kind of need lunch soon, or I'm going to start to get like shaky. But anyway, let's do it. Let's rip it. For anyone that's new, we are speed dating papers, 1 minute per paper, answering these 3 questions. If we like the paper, we're keeping it. If not, we leave it. This arXiv search has so far yielded 0 keeps. Maybe that's going to change. Let's find out. Implicit geometry representation for vision and language navigation from web videos. So, limited diversity and scalability of simulator curated datasets. Yeah, it's hard to capture the complexity of real-world environment from a simulator, so they introduced large-scale video instruction framework derived from web-based room tour videos. Interesting. So the agents can learn from the natural human walking how to simulate maybe better things. So their framework integrates open-ended description-enriched trajectories and action-enriched trajectories reconstructed in 3D. And so a key extension of this work is the incorporation of implicit geometry representations, which take spatial cues from RGB frames without needing 3D reconstruction. Man, that's a lot of things that I feel are going to be hard to capture in the remaining 30 seconds. But they'll take a room tour video, they'll get a call map reconstruction, which might be a little tricky unless you know the camera priors from the room video. But anyway, then they'll send it to Blip2 to get like labels, I think, of the different things, depth anything to get the depth masks, grounding with Dino plus RAM to get like even denser stuff, and then like you'll get a whole text-based trajectory of what happened annotated to the video. And then from the 3D, you can even get like the actions. Okay. I want to spend more time on this one. It's complicated enough to where a minute's just going to be hard. Some of these papers, the key idea is going to come out in a minute. Some of these, maybe we got the key idea there. I think the key idea is, in fact, all this like dense prediction annotation. But I'm missing a little bit what they're going to do once they have these trajectories. And that's what I would like to get when we come back to it later. Okay. Forge Dreamer, industrial text to 3D generation with multi-expert LoRa and cross-view hypergraph. I want to kind of know what they meant by cross-view hypergraph. It looks like it's literally a graph. Okay. And industrial means we're talking about like screws and hammers and stuff. Yeah. Custom built multi-view industrial data set, 3D generation results. So the architecture is a frozen 3D generator to initialize these 3D generations, and then some coarse 3D Gaussian splat to get multiple views. And then we pass that through a 2D model actually from the different views. We're going to have just a LoRa weights, and we can like refine and get very nice, pretty results for these fixed multi-views. And I bet we can then take that to generate even more good data, right? multi-expert lower ensemble framework, cross-category, and then it gets really complicated. I think I got the key idea on the top. The bottom has many complicated, like LoRa, mixture of expert type components, the hypergraph to incorporate other knowledge here. Do I want to spend more time on this paper to understand that diagram really well? Diagrams are fun. Trying to just understand a diagram can be really fun, which means maybe we do come back to this one just to try to understand the diagram. Yeah, we'll come back. Okay, reviving ConvNext for efficient convolutional diffusion models. First, I want to see if it interacts with the prior work that I like. And based on this table, the answer is no. It does look like it's both more efficient and lower FID than the state-of-the-art DIT, but this is not like the state-of-the-art schedule. The FID would be like 2. So let's try to find their architecture first. So their fully convolutional diffusion model it looks very similar to the deco we looked at earlier. It's got these blocks that downscale that we can like have this L parameter to control the number of blocks. So that allows us to kind of scale it. And then with, oh, they do compare to deco. They compare to deco. Okay. So we know the deco block because we looked at it. Compared to the deco, they don't have the forward at all. And what else did they change? Oh, they switched the depthwise and the pointwise convolution. And they changed the convolution mechanism to a GRN? What is that? Huh? What is a GRN? Okay, speed date's over. We're coming back to this one because it's related to the paper I said I like a lot. And it even compares to it with the diagram. Open world motion forecasting. So traditional motion forecasting models just take annotations for all agent types. End-to-end motion for what? Yeah, future trajectories of dynamic agents for autonomous vehicles to effectively reason about scene evolution. What is their approach though? So their underlying models train incrementally with access to labels for a subset of all classes. So it continuously aims to forecast motions of all classes in an end-to-end manner. I don't understand the difference just from that. I don't want this. I don't like this. I'm gonna start. I have so many papers here. If I'm not feeling it, we're gonna get out of there so quick. Evolving autonomous driving vision language action model via collaborative perception planning distillation. So we have single trajectory distillation where we have multi-view images of teacher, student, and then we distill the actions of the teacher to the student. We have multiple trajectories where we have a planning vocabulary, which basically gives some example trajectories, and the teacher kind of shows how they behave on all of those, and the student is supposed to learn the best one. We have collaborative perception planning distillation, multi-view images, an anchor teacher, a visual encoder. Oh, geez. Okay. Future, that is like way more complicated than the prior work. So future images, future ego status, an oracle teacher to do the oracle, an LLM decoder. Man, okay, this is like such a different pipeline compared to the existing works that it's almost, and very unfamiliar to me. Like we have this idea of an anchor, and I'm not quite sure what they're meaning by anchor. This would be a fun diagram to break down too. We'll come back to it. That'd be a fun diagram. Okay, well, let's answer a viewer question. That's a nice break for me from failing all these lessons. I do better than this sometimes. If you're coming, just barely, I get them in a minute sometimes. But I did go outside of my wheelhouse on some of these papers from arXiv, and they're giving me a real hard time. Anyway, do you have any thoughts on doing masters with the goal of getting a PhD afterwards? Yes, I do. That's a plan that a lot of people have, and it works for some of them. You can see me talk about it with Ani a little bit in one of my more recent videos. It's the hour-long one about like, I don't remember what title the algorithm settled on, but something about like undergrad becoming AI researcher or something or other. It's in one of the last segments. We talk about his Carnegie Mellon MS accept, and like my advisor actually did Carnegie Mellon MS and then Carnegie Mellon PhD. And I had lab mates at University of Maryland that did University of Maryland MS and then stayed as University of Maryland PhD. The risk is if you do the master's and nobody wants you, then you potentially spend a lot of money for the master's and you're kind of back in square one. But it can totally work. And yes, it is extra years of experience to get into more competitive PhD. The key thing is that you have to do stuff. Like if you do the master's and only finish with that one piece of paper that says you got a master's, your profile is weaker than when you started. You need to use the master's to get research experience and to get people to endorse your research experience. So we're talking about papers and we're talking about letters. And if you don't get those two things better than you had in your undergrad, then you have a master's, which can help. But otherwise, you spent 2 years and however many tens of thousands of dollars to get a weaker application than you had in the first place. So that's the thing to keep in mind. I have 6 concurrent, so I hate to step away. I have to use the bathroom though. I will be back in like less than 5 minutes. Okay, so give me a minute. I'm muting up. Okay, I'm back. Did I lose concurrence? I'm so confused about how I keep you guys through bathroom breaks because I lose people when I feel like I'm doing interesting stuff. But the last 2 times, 3 viewers to 3 viewers, and then this one's 6 and 6. Like that's wild. Um, it's slightly slower than going for PhD directly. Yes, that's a good point. So it can actually be equal, Sams. I've seen people that actually carry it perfectly. Like they'll do the 2 years masters, and then they'll get out like 3 years later, especially if you stay at the same place. I've also seen people though, like I had a friend who was interviewing. He did his master's, and at the end of his master's, he applied for PhD. And he did an interview with a pretty famous prof that I won't name, and she basically told him, if you want to get a PhD with me, you're staying here for 5 to 7 years, even though he had already done 2-year masters and published in that time a few top conference papers. So it kind of varies based on your advisor. Generally, though, I'd agree. It's generally going to be slower, but part of the reason it ends up being slower a lot of the time is because people let themselves be slower. Like I know a lot of people who will insist, even though they've been at the school for 5 years, that they're a 3rd-year PhD student because the first 2 years are their masters. And I don't know. And yeah, maybe that 1 year is better spent postdocing if you're just talking about cost benefit analysis over the course of your life, because like you can get great PhDs at non-top programs. I have friends that went to programs that are firmly outside the top 15 that have way better PhDs than I did, and then did great postdocs, or just went on to great like industry positions. And so yeah, it's definitely worth asking yourself, should you really be like risking it all to go get the CMU Masters, or would you maybe have a more comfortable time and better for your mental health just going to get the PhD at UNC Chapel Hill, right? Those are like, that's a hard question. And it's important to be, I don't know, to put a lot of thought into it and to ask for a lot of opinions, I think. Okay. OmniEarth, a benchmark for evaluating visual language models and geospatial tasks. So this is going to be, I call this Earth Vision because that's what the CVPR workshop is called. This is going to be a benchmark. And how are they comparing things here? Are they just saying that like theirs gives like gaps that make more sense, I think, between models, basically? Let's see. So their OmniEarth has reasoning, human verification, more task categories, more subtasks. So that's what they're arguing, like you should use their model. It also has a lot of modalities. It's got optical, it's got multispectral, it's got synthetic aperture radio, it's got multi-image. Oh, it's kind of interesting. It doesn't look like it has everything though. Like it doesn't have video, it doesn't have infrared. So it's missing some things, but it's got a lot of things. And it covers all 7 continents, which is a big deal too in geospatial because you can overfit to the appearance of certain like parts of Earth basically. So it's good to have coverage of lots of things. So seems like a good data set or benchmark, I guess. I don't know. Let's look at their table before I close the paper. Like, is it training or is it just bench? Because if it's just bench, like that's good, but yeah, it's just benchmark. So that's kind of a bummer because like in this kind of field, training data is king, and it's good to have a lot of it. But granted, I think they said that this is like human verified, which is a big deal. All the samples. High quality data is important too. Okay. Let's keep moving. If we were to go into a non-top 15, maybe somewhere along 50, any advice on doing well there and get industry positions afterwards? Okay, I'll answer your question if you're brave enough to name a school, and then I'll answer. Because I want to make sure we're talking about the same kind of thing here when we say top 50. Wikiclip, an efficient contrasted baseline for open domain visual entity recognition. So Wikiclip, I think we're going to be talking about their own data set, which hopefully is open. And then, okay, large language model embeddings is knowledge-rich entity representations and enhances them into vision-guided knowledge adapter that aligns textual semantics with visual cues. This sounds a lot like Clip, but I know it's different somehow. So to further encourage fine-grained discrimination, a hard negative synthesis mechanism generates visually similar but semantically distinct negatives during training. That's a cool idea. So the pipeline is given an entity in entity's Wikipedia document. Use Clip to extract patchable features from the image in the Wikipedia, an LLM to embed the encyclopedic text description, and then select informative text tokens guided by the visual feature to produce an entity representation. Cool. And then do compression, and then do contrastive learning on that. And then generates challenging negative samples by replacing the original entity text description with that of a visually similar but semantically distinct entity. So you know the difference because you have the text. So if the text is different but the image is similar, say that that's a hard entity and we can train on that to get like better hard negatives. That's cool. I like that. Let's glance at the results even though I'm over time and see how it does compared to Clip on Oven, which is a data set which maybe I should know but I don't. Looks like it's good. It's not as good as the generative works for seen, but it's better than anything on unseen. And I don't know what HM is. Still, it's a neat way to train, and it's a neat way to think about synthesizing negatives. Okay, let's see. Did you name a school? Stony Brook. Okay, Stony Brook. Is that... Let's see. Not to put you on the spot, Stony Brook is roughly something I would name if I was thinking top 50, but I want to make sure that I'm being fair. So let's look at it in terms of output. And because I feel like it might be a little higher than I think. Yeah, like, so maybe closer to 25 than 50, right? Okay, so there's two things to say here, two different thoughts. First thought is it's always better to have PhD different from your undergrad, for the most part. So just that alone makes it a little worse than if you were asking me about, for example, Virginia, right? If you were asking me what about Virginia or what about Duke, this would be a different question because you're actually also asking me at the same time about staying at the same institution. However, staying at the same institution could be good if, for example, you know, you're working with maybe one of their most established and most respected faculty in the area. Or maybe it's a bad thing because maybe this is a person that you've worked with before and you haven't had a good experience, and so you're actually potentially stunting yourself. I think, though, in general, going to PhD, a lot of people are going to benefit from a scenery change, even unrelated to research, because you're going to grow your circle. You're going to make new friends, have new colleagues, and just like have like maybe 1.5 to 1.7 times as much of a network as you would if you would simply stayed at the undergrad institution. In general, however, this is a range of schools that produces exceptional PhDs. Like every single one of these produces multiple PhDs per year that have like a stronger on paper resume than I do. And I feel like I have a decent enough resume to where I have no stress about jobs. I have no rational stress about jobs ever, right? I have like recruiters in the inbox all the time. I know my relative value and I'm quite happy with how I'm compensated. And there are people from these places that do way better than I do. So that's not to say that it wouldn't be better to be somewhere better, right? Like I feel very fortunate that I was able to go to the University of Maryland. And would I have had a better experience at Stony Brook than I did at UMD? Probably not. Like that's essentially what a productivity metric is saying, is probably you would have produced less. But it varies a lot depending on your advisor. It varies a lot depending on your personal circumstance. And I do think that if you're inclined to do the research and you have good motivation and you know what you're doing, this is going to be way better than nothing. Personally, that's my thought. Yeah, not having good potential advisors though is a bit scary, right? Especially because you've been there. So like you've already been in a position to find advisors there and it's not working. So like that should maybe give you some pause, and that can be the benefit of the scene change as well. If you stay there, a lot of people are going to think, oh, well, they should know people, right? They've been there. And so you're not like new students naturally may have a slight leg up on you if you're talking about a blind match, especially because like it's almost like you go through a different pile when you're applying like as someone at the school. Like your letters are all looked at a little bit differently, and like a lot of faculty that are reviewing might look at you and just assume, oh, well, they're strong and they're from here. Someone probably has them taken and they won't really bother. Whereas when people are applying blind, they would know like, okay, this person needs like faculty match. Does the Ivy League factor have any effect in the PhD scene? Yes. Two effects. So one really funny effect that, like when you say Ivy League, I think you mean name value that has nothing to do with actual quality or output, right? Is that what you mean? If not, clarify what you mean. But assuming you mean that, there is a phenomenon where for the types of people that tend to pursue professor positions, a lot of them will give a lot of deference to what their parents think. And their parents, one thing that they know about reality is that Harvard University is awesome. And so Harvard will punch way above their weight when it comes to faculty hiring. And then somehow shoot themselves in the foot institutionally. But like Ivy Leagues will pull in a disproportionate number of high quality students and faculty relative to their actual achievement. That is the big impact of the Ivy League effect. Now, there's a different Ivy League effect, and this could be what you meant as well, where there are some programs that are actually the top programs, and people that are in the scene know what they are. And it is so helpful to have gone there until the day you die. Like when a recruiter pitches a startup to me, trying to hire me, the first thing they say, if it's true, will be that the founder went to CMU or Berkeley or Stanford or MIT. They don't mention anything other than those four. Like that, those four are a filter where I have yet to see them say any other schools. But those are the four that are like relevant enough to like use as a positive filter when you're trying to hire. And the same goes vice versa. Like you are forever if you went to one of those schools and a Stanford alum. Granted, if you went to Stanford, you probably are more in the startup scene anyway, and maybe that's less relevant because probably it's your own company, right? But stuff like that never leaves the resume. And it tends to align with reality. I do think Illinois is forever underrated, personally. That's a belief I have. No matter how you rank them, even if you go off this list and look at other things, it's just a really good school. And like if I look at the faculty, like it's people whose work I'm pretty familiar with, and it's like a lot of really awesome research. But yeah, CMU, MIT, Berkeley, and then Stanford. Hey Matt, any thoughts about pre-docs or post-docs for graduates from liberal arts colleges with little to no research experience? I am so much less familiar with pre-docs or post-docs. Especially, are you talking about like you're trying to get a liberal arts PhD? That's where I'm going to know very little. I have a friend that did a pre-doc and then didn't end up deciding to do the doctoral. They could have, I think. They just decided it wasn't for them and they were enjoying what they're doing in the pre-doc so much they decided to just keep doing that. Which I guess is a benefit of that kind of thing, right? Like if you're doing a pre-doc with a research institute that does employ people with bachelor's full-time, that could potentially be your forever job, right? So that's nice. I know a lot less about post-bac though, and I'm not familiar with any of these ever happening in AI. Pre-docs, post-bacs, not heard of it. Okay, there's a thing, I haven't heard it called a pre-doc, but it is a pre-doc. Sometimes labs will hire like interns. And sometimes those people get converted to master's or PhD. So that can be another way. Like if you didn't make it through the master's filter, but you can find a faculty person willing to hire you, you could potentially sign on as like a research associate or like a pre-doc or an intern or something and then kind of convert. And that can also be a way to potentially get into a place even though you had no research. For whatever reason, you convince someone to spend some money and time on you. And then eventually you prove yourself and you can be a student. Graduating from Colby College, small liberal arts, and trying to get into an AI PhD. Yeah, Sardor, it's probably going to come down a lot to that networking aspect then. Like, Or rather, if you did somewhat impressive things, you might be able to jump into some part of this list, not the bottom, places that still do actual published research, right? Like City University of New York has faculty that do research. You might be able to get a position there as long as you did well in your program. And from there, it's just about how hard you work. Like, do you have as many opportunities if you're here as you do here? Not on average, but if you know that's what you want for yourself, it could totally work out for you. And you could even, if you really know what you want, it could work out with none of this, right? You could like sit down today in the ChatGPT window and ask it to teach you AI, and maybe eventually the two of you would figure something out. I don't know. These are certainly paths that I think make a bit more sense, though. And even at these places, you're still being provided with like institutional support for your learning. And that's the really positive thing here. But yeah, like if you could find an experience, especially the thing that you're going to want to look for with that internship or that pre-doc is it needs to be a better place than you could have just gotten into as a PhD. There's no reason to do that at the place that you could have gotten into as a PhD unless you're like, I'm going to do such a great pre-doc here that I'll then apply to a different PhD. But I think that's a bit scary because then like, what if funding things change and then you can't actually get into that place as a PhD after all? Or what if you just have a rough year? Sometimes research doesn't pay off right away. It takes time. So those are things you risk when you commit yourself to the position where they have an easy off-ramp after 6 months or 1 year or even at will. Hope that helps a little bit. Once again, I'm not so familiar with these situations, so I'm just kind of brainstorming, and this is what comes out off the dome. The best I can do. Okay, let's see. So frame DIT, diffusion transformer with frame level matrix attention for efficient video generation. So my immediate assumption here is somehow we are doing the attention to where it doesn't attend over the whole sequence, but instead we're just attending like per frame. That's my assumption. So, okay. So built on the diffusion transformer with spatial blocks and temporal blocks, we have a temporal block, which is an Adler norm attention scale, Adler norm NLP scale. This looks a lot like a regular thing, except we put the Adler norm at the front instead of at the back. And then we have like this local, like token frame embedding. What the heck? I think just the local features that are already in the block, right? But then what is this global input? Like, what are you passing globally versus locally? Oh, we're not passing all the tokens together. We're passing them like just in these little chunks, I suppose. Like one at a time? Is that what it's saying? I think so. I think we're just like chunking it and like just doing the attention on those. But what's the deal with like global? Oh, there's is local globals. So there's, man, I'm still missing. Okay, so the global is the matrix attention. The local is just the attention. I assume that the matrix attention is across chunks and the local is within chunks, basically. Because that aligns with like a lot of other things I've seen in the space. That diagram, though, is not doing me any favors. And the problem is, okay, so like I could look at the math here. It's a risk because the math might not clarify it much. We'll come back to it, though, and I'll try. I will try. I think it's going to be a lot like a lot of the other stuff happening in the space, though. We just don't compute attention on everything at once. We compute attention in little chunks, and we sometimes compute cross chunks when we want to transfer information that way. Towards audiovisual... Okay, try again. Towards audiovisual reasoning with temporal alignment across modalities. So they have a multiple choice benchmark with real-world videos and questions across multiple task families. And they introduce a training-free modular diagnostic baseline that composes off-the-shelf unimodal models to serve as diagnostic baseline to illustrate how explicit temporal alignment signals affect performance. Okay, so let's see. We have what functional difference existed between the hand gestures of the two men in blue blazers. One structured inquiries while the other illustrated personal narratives. Okay, so they highlight the data sets focused on complex cross-modal reasoning. The top example requires temporally aligning specific speaker voices with their gestures. And the question, by the way, you also have to align the question in the text is asking about the voices being aligned with the gestures. And the bottom requires comparing acoustic environments across different video segments. So it requires like the being able to compare across time effectively. So I think this is just a benchmark that should be hard for a lot of AV models because you have to reason about both the AV and the video across the time. And that's really tricky. Yeah, I can see how that'd be useful. I'm not going to spend more time on it, though. Good to know that it exists. It's a real thing in the real world. Okay. Oh, by the way, for people that weren't here earlier, we're speed dating papers. That means I get a minute to try to answer these 3 questions. You won't hear me ask them out loud, but that's what I'm looking for. This is a paper I was a little scared of because I've never seen something in this format in my life. But the whole concept sounded interesting, so we'll see. Variance-aware adaptive weighting for diffusion model training. So the different noise levels remain highly imbalanced, or the training dynamics are different across different noise levels, which leads to bad learning, basically. So they investigate the perspective of loss variance across log SNR levels and propose a variance-aware adaptive weighting strategy to address it. So we're going to do different weights at different noise levels. Is that what we're going to see? Like at certain time steps, we do some weighting. Yeah, adaptive log SNR reweighting. So we have a weighted loss. Where we get some weight and we multiply it to the loss, and it's a weight based on a gamma, and how do you or based on a lambda? How do we compute the lambda? Oh no, where's the equation for the lambda? It's just log SNR of sigma. Okay, which is the noise. It's just the amount of noise, right? We're just weighting it based on the amount of noise. So what's the finding here? Do we need to use more weight when there's more noise, less weight when there's less noise? I don't know if I buy this, by the way. They're gonna have done something on CIFAR. Yeah, it's I don't know. It's hard to know what to say. Like, yes, they found some finding that implies that the model is better on the very toy data, but would I trust this on larger data? I don't know. And do they really show me anything convincing about the training dynamics at different noise levels? Like, am I seeing that analysis pop out? I'm not. Like, I'd expect a figure to show me bad training dynamics, and that's not really happening. I guess they're saying there's more loss variance at different log SNR levels, but does that make me think that it's bad? Like, that's not a training dynamic. That's a variance in the loss, I guess, but like the loss can be slightly higher variance, and that's okay. Especially because different time steps have different importances. Like the higher noise time steps are doing a lot of heavy lifting actually for planning the image. And to some extent, once those higher noise steps are finished, our image is planned. And we're kind of stuck in just refining the details that we decided we're doing at those higher steps. So like they have their role. So the higher variance. So honestly, in the baseline, we see the higher variance both at like very low and high log signal to noise ratio. This almost mirrors what we see a lot of the time in like high steps are important for planning. Low steps are important for like really refining the features. And so I'm not sure if I buy the fact that we need to manipulate this distribution without seeing experiments on something bigger than CIFAR 10 and CIFAR 100. Yeah, I am trying to farm a bit the advices, to be honest, Muli. I don't know. We'll see. Because yeah, it is a bit. We're speed dating the papers. We're also doing some AMA. Oh, did I keep this paper open? No, this is the other paper. Okay. We're moving right through. We're bleeding viewers a bit too, but that's okay. I want to see anyone that's here. Attendance check. Press 1 in the chat. Press 1 if you're enjoying the papers. Just like press 1, enter, type a 1. I like it when like gaming streamers have people type 1s. Then you just see 1s. What does it look like for me to ask 5 people to type 1 in a chat? Is what I wonder. Ah, there we go. We got a 1. Unlearning the unpromptable. Prompt-free instance unlearning diffusion models. I think I said earlier that I feel like this is the easier version of the problem. Way harder than getting the model to unlearn things is getting it to like really, really, really memorize a thing. What do they mean that it's prompt-free? Okay, so challenge in our solution for instance unlearning. So let's selectively forget specific instance and preserve the others. What if the targeting outputs are unpromptable? So Ireland flag. We want to preserve this and we want to forget the flag poll, I guess. So what's the method? What's the method? Oh no. No diagram for the method. Ah! Algorithm, a denoising network, a forget dataset, a remember dataset, total iterations. Construct surrogate image. Okay, we learned about surrogates somewhere, I hope, visually, yes? Is the word surrogate here? Or is one of these a surrogate? Maybe I should just know this if I knew unlearning. Maybe if I knew unlearning, I'd know surrogates. Oh wow, we got ones from everybody? That's crazy. Oh, hey, Stuart. Yeah, I'm not. You need to give me better diagrams. Sorry, guys. Sorry, authors of that paper that I bet is an awesome paper, just with diagrams that make me sad. Okay, code-grounded visual STEM perception for MLLMs. Our work focuses on systematically enhancing the perception capabilities of MLLMs by establishing code as a powerful perceptual medium. So it provides precise semantics that naturally align with the structure and nature of STEM visuals. Okay, so a large-scale data set with image caption code triplets that materialize this code as perception paradigm through 2 complementary approaches. Code-grounded caption generation treats executable code as ground truth for image captions, eliminating hallucinations, and STEM image to code translation prompts models to generate reconstruction code, mitigating the ambiguity of natural language for perception enhancement. Please, please, please. Oh, it's a diagram, but it makes me zoom. I can't zoom right now. We're in shorts mode. We'll zoom later. This is decent. I feel like I almost understand what's happening. We construct high-quality image code pairs via 3 complementary pipelines. Imagery produced converts existing stem images into execute. Man, I know I need to be able to zoom on the thing if I want to have a chance at this. So we'll come back and we'll try it later. I really wish it was popping off the page a bit better, but it's okay. Some things need a deep dive. That's the learning here. Beyond sequential distance, intermodal, distant, invariant position encoding. So I want to see what they're doing with the position encoding and why. So MLLMs still suffer from visual fading, where the attention to visual tokens diminishes as text sequence increases. Yeah, if you have your vision to the front and your text at the back, the further you get from the vision, I mean, your VLLM already wants to ignore the text, and as you get further, you'll just ignore it even more. And they say it's Rope's fault. I'm actually inclined to agree with this. I've observed this in my own work where Rope has this bias where it just likes to pay attention to the most recent things in like a really surprising way. So I am already inclined to believe them that this is a problem. Now I just want to see, okay, we just lost our question and our timer. Now I just want to see if it works. So I don't really care about how they did it as much for dating the paper. I want to see if they have numbers. MRope, vanilla rope, MRope I. I think this is theirs over here. Or not. Dipe. They can fix MRope. They can fix MRope. All these greens, I'm inclined to say this works. We're coming back to this so we can find out how this works. Because I think it's a big problem. And is it training free? I doubt it, right? You'd have to tune it. If it's training free, I'm like, whoa. Can we tell? There's no way they're training this stuff from scratch. So it certainly doesn't require a ton of training. Well, diet theoretically necessitates decoupling the attention computation, blah, blah, blah. We demonstrate this can be effective, blah, blah, blah. Flash attention. Seamless integration of KV cache. So it works with the KV cache. That's the implementation. No. I want to know the training recipe. 2-stage. First stage, vision language alignment. Freezing the vision and the language, and then training a projector. The second stage is instruction tuning with the unfrozen LLM. Okay, so it's like your typical Lava instruction tuning pipeline. Okay. And that's all we need to fix rope? That's compelling, if true. Big if true. Okay. I spent too long on that already, especially knowing I'm going to come back. But I just wanted to know. Okay, we're doing another backdoor paper. I was horrible at the last one. Backdoor directions and vision transformers. Let's do better at this than we did the last one. What does this mean? So take paired images and derive BT vector from activations at each layer I. So the derivation of the backdoor direction at the layer L. How do we derive it? PCA productions of internal activations, clean, backdoored, BT direction. How? Should I already know this? I know what backdoor attacks are. You train the model such that you can put a weird thing in at test time and get a weird thing out, even though maybe a human would miss it. I think they're just saying they're better than other backdoor attacks. And yeah, move on. Okay. That was not interesting. Sorry, guys. Not interesting to me. To me. Maybe you love backdoors. I don't care. Novel view scaling for physical AI with Gaussian 3D Gaussian spotting. Okay, I want to know what the novel thing is here, because it almost sounds like just using 3D Gaussian spotting for the physical AI. So what do they mean? It faces viewpoint shift between training and deployment, so it has to be really robust for RGB to 3D. So they cast the real to render to real monocular depth pre-training as imitation learning style supervision from a digital twin oracle. Oh, so are we using like RL style things to pre-train this? So we have real data capture, digital twin teachers. We have a 3DGS observation teacher and a mesh oracle, because we have real data capture, so we have real meshes. Those are the ground truths. And then the novel view scaling. Oh, like we're just going to use the 3DGS to scale up our data so that we have even more RGB to train our student model on the 3D data. I think that's the point, no? We'll be able to tell really quickly if we look at the tasks. Like this is just the fidelity. This is the novel view scaling. I'm not very good at reading robot papers. Sorry, guys. I don't read a lot of these. I'm a little confused. Maybe the conclusion can help me know how to read this paper. So 20 sequence benchmark with step mesh sweeps. Naive scaling is non-monotonic regress relative. No, I'm not quite getting what the interesting thing is here. Like I understand how we can use real data capture to get both the Mesh Oracle and the 3D Observation Teacher. I'm missing what the thing is that we're trying to train. Do I want to come back to this? I'm really not in the mood. Okay. Layer consistency matters. Elegant latent transition discrepancy for generalizable synthetic image detection. So maybe I should pay attention to the teaser. So interlayer feature consistency, computational efficiency detection. This is just them saying that the model's better according to a few metrics. They're visualizing features extracted, like cam features extracted by clip from these different models. No, I don't think that's something. Okay. So discriminative intermediate features are extracted from a pre-trained VIT and used to construct two branches, one stacking multi-layer features directly and the other computing pairwise differences between adjacent layers. Okay, so we can stack them. Where's the stacking? How can I, like, these are the mid-level, where do the one-hot codes, or the one-hot codes are learnable. Okay, so we have middle-level features, one-hot learnable codes, and we'll compute a Gumbel softmax. Where the heck are those differences computed? I'm not seeing the differences computed in the diagram. A shared transformer block processes both branches. Is that LTD? Is that what that means? No, that's just layer transition discrepancy. I think, wait, maybe that is what that means. No, I'm still, it makes sense though. Stack the multi-layer features. I feel like we see that happening here, but they're being multiplied with the one-hot codes, which is not being mentioned here, these learnable one-hot codes. Followed by an NLP for the classification based on the concatenated representation. Okay, so we're getting a representation based on stacked discriminative features, maybe multiplied by these learnable one-hot codes, plus layer-wise feature differences. And I think that's why they're trying to show us this here. They're showing us that, no, not this. No, not this. What did I think I saw? I thought I saw them explain why you can trust the intermediate layer feature differences to be descriptive. But now I'm not, so I don't know. Looks like their approach is pretty strong for these benchmarks. I'm not really familiar with this task. Anyway, that's fine for now. Okay, let us continue. Sparse task vector mix-up with hypernetworks for efficient knowledge transfer and whole slide image prognosis. This is going to be medical paper. What I'm looking for, okay, so some cancer specific, looks like contrastive learning or joint learning. So the existing solution would be to do the representation learning transfer with some kind of, it looks like a student and a teacher network. And then you want to have, oh goodness, task vector mix up. Let's look at this. So after computing task vectors, it first, okay, I know I'm not going to get this. Too much medical for me. Too much. Sorry. Okay. IMT bench, a multi-scenario cross-modal collaborative evaluation benchmark for in-image machine translation. Okay, I want to see what's happening here. So we have existing IMT benchmarks where, yeah, we're going to have text in the image and we need to translate the text in the image. Theirs is going to be different than these in that it's multi-scenario complex layouts, so not necessarily just captions, real world, and cross-modal quality is measured compared to other things. I guess they're saying that these other things could be very simple. Theirs are going to be very like rich, complex, different angles, different layouts, stuff like that. And theirs also comes with image text pairs with real scenes, which not all the prior works do. So that's another advantage. An overview of how they construct it. So they start with like PowerPoint or scene or corpus. They do the translation. How do they do the original translation though? Manually? So they have multilingual PowerPoints, the multilingual annotations, which they can then edit to get multilingual images or capture as multilingual images and then filter, and then that's their data set. This part makes sense to me. This part, the translation, I'm not quite sure. I want to learn it and then I want to close the paper. How are we doing the translation? Is that with like a real human? Because otherwise, like if the existing models can't do this, then how are you capturing this pipeline? Lightweight text-based machine translation system. How do you know the text? How do you know the text on the power? Oh, because the PowerPoint file has the text. Duh. And then you're doing OCR on the images to get the text. So you're disentangling. So you're basically saying like, if we disentangle the image from the text by either having it typed in the PowerPoint or by doing OCR, then we can do the translation. Then we know what it is. Then we could generate the multimodal version. Then we could generate an image that natively, or like a data set where we can natively evaluate the ability of the model to do the translation in image space, where the model itself isn't, doing the OCR, then translating, then putting it back up. Cool. I get it now. Longer than 1 minute by quite a bit, but I got it. That's what counts, right? Any tips on what to focus on scanning through literature? Well, I can see how you're doing it right now, but I believe you're an expert in this field and can understand just by reading the title. I mean, you're seeing there's a lot of failing, in my opinion. Like, I'm doing my best, but it's hard. Practice. I said at the start of the stream, you just practice. Do it a lot. Read a lot of papers. Read a lot of papers in your field. Come to the streams. I hope as you spend time with me, you can try to follow along with what I'm doing. If you can't see the text, I have a 27-inch monitor and I can see it fine. So maybe that's a hardware recommendation. But yeah, the point of the stream is I'm trying to show people how I do it. Oh, a math-heavy area makes it a lot harder. Like if you tell me more about your area, I might be able to give a more concrete recommendation. I think an important thing though is to have some way that you filter. So like if you're trying to read every paper, you're doomed, especially math heavy, because to really read a math heavy paper and really get it and like do the proofs yourself, we're talking hours of effort, right? And if you spend hours on low quality papers, you're missing, hours on high quality paper and then time to run your experiments. So it can help having friends that know things that can recommend work to you, or an advisor that knows the field that can recommend things. Having a group of researchers that you respect, where you can trust their work, and those are the things you put your time on. Be very protective with your time, though. Don't just throw your time at random stuff. Like if you don't know the authors and you're not seeing it get boosted elsewhere, be very skeptical of being the person that's going to do the filter work. Like, I don't know if you use Reddit, but hopefully you do, because then the analogy works. But like, are you going to sort by new? Some people do, but the people that sort by new know that they're doing the curation work. And know that if you're reading every paper you come across, line by line, you're curating. Try to avoid curating. Whether it's been accepted to a conference is a good signal. If it got an award at a conference, that's a good signal. If other people are talking about it, that's a good signal. Sometimes, once you know the area a bit better, if you're able to understand it, that's a good signal. Sometimes the friction you'll have understanding a paper is simply because it's not written very well. That's something that's hard to know before you know the area, but you're saying this is your area. So like, honestly, no, Yamv, I don't know how you want me to say that, but I think it shouldn't be much more time that you feel like this before you hopefully gain a feel for like, okay, I'm spending a lot of time on this because it's a good paper, or this is becoming difficult for me because it's not very good. I'll move on and do better things with my time. And especially because you're saying preliminaries. If it's your area, the preliminaries should eventually become an area that you skip. And only reference if you run into funky notation. Like if they're not using the notation you're used to in the area. It's related to control multi-agent systems and rigid formation. There's almost no previous work that involves RL-based control, and we're trying to come up with some things with a few colleagues. Oh, I see. Yeah, I mean, like I said, hopefully this is a very short growing pain area, and like after you get a little more familiar, you won't be stuck in preliminaries because you'll know the preliminaries, right? But yeah, in the meantime, while you're learning the area, you'll just have to read preliminaries, and it'll take longer. I would say it's a bad sign though if you're staying in this one niche and like 2 weeks from now, 10 papers later, you're still spending hours going through preliminaries line by line. At that point, you should know it a bit better and you should be able to dive in. Maybe a month from now, you should even be able to skip preliminaries, because even if there's notation confusion, you'll know the area well enough to remap the notation. Where it's like, okay, I don't know that symbol, but I know the problem, so this must be what the symbol means. That's how I stand a chance, by the way. When I do these 1-minute reviews well in an area that I know, it's because even when there's something unfamiliar, I'm typically able to remap it onto something familiar. Something smells kind of bad. I shall look into that in a minute. Okay. Let's keep going. Oh man, how many more do we have? I started with 50. I think I'm getting close to the end. 10, 16. Okay, so like 20 more minutes. Oh, I need to do something real quick. Should I do it now or should I wait? So there's a scary thing. I changed all my encoder presettings, and for the first time, I'm recording the live stream locally. At some point, I'm going to click stop recording, and it is going to try to save a video. And I freed up quite a bit of space, but I don't know how big the video is going to be. And so I'm going to click that button in a minute. Stream will stay up. I'll just need a minute to like check the size. Anyway, let's try to finish, and then I'll do that. So let's race. Okay, sorry, I'm chewing. And oh God, I need water. Okay, sorry. Water ball's empty. I need 2 minutes to fill it. I'll be right back. If you stay, you're a hero. If not, I get it. But for real, like 2 minutes. Everyone that's been here knows I'm honest. It'll be 2 minutes and I'll be right back. If this is empty, my voice gets like it sounds right now, kind of scratchy. So, BRB. Okay, I'm back. I'm back. All right. Let's check chat. Okay. Why are there more viewers than before my water break? That's a good question. I won't question it too much though. Hello everybody. Thanks for waiting. Let's get back to it. We have 16 more papers to go. And then I'm gonna click recording just to make sure. Like I don't know how big this file is gonna be because I increased my preset. So I turned. Oh, this is a question for anybody that's been in the chat before. Do the papers look better today? I tweaked some settings. They look better hypothetically. Do they? Okay. And quick question before I get into this sprint. How do you read 3D vision related stuff on here? Very poorly if you've been here for me to try to do some of them. I barely knew Nerf. I knew Nerf only from the side that I knew implicit representation learning, implicit neural representation learning. So like I understood Siren, I understood Fourier feature network, and I even worked on stuff called it neural representation for video. So I understood the idea of like storing the image in model weights. I understood like coordinate representations or even like grid-based encodings. I didn't ever understand camera parameter well, or ray tracing, like the secret sauce of Nerf. 3D Gaussian splatting I never learned. And then like robotics-based stations I have like exposure to. Technically I've co-authored a robotics paper. I'm more familiar with like task presentation robotics papers though than I am with the actual nitty-gritty of like camera parameters, trajectories, control, And then when you're talking about 3D, like what actually is a Gaussian primitive, I'm super bad. So how do I read 3D vision related stuff on here? I spend a minute on it, I feel embarrassed, and then I close it. But if you want me to look close at a paper, I am happy to. Send me the title, I'll give it at least 1 minute, and if I'm not feeling too embarrassed, I might even do a deep dive. And maybe you can fill me in on some of the stuff I'm missing. And in the longer term, maybe 3D is something that I learn. But for now, it's just an area where as soon as something gets really technical and interesting, I am going to be quite weak. And so I don't think that's great content. But like for real, you have a paper, Wakeham? I'm guessing Wakeham is a last name maybe, or Wakeham. Send it, and I will spend at least 1 minute. And for people that haven't been here already, I have 15 papers to go. I've probably done 50 or 60 so far. I'm speed dating papers. 1 minute, 3 questions. Try to get as close as I can to answering them. And if I like the paper, or even if I don't like it, but I want to look at it longer, I'll keep it and I'll have it in a tab over here and we'll come back to it later and look at it a little longer. Okay, let's go. From imitation to intuition, intrinsic reasoning for open instance video classification. So what do they mean here? So unlike conventional classifiers that rely on direct input to label mapping, it evolves open instance video classification from imitation to intuition. Through stage training, it develops intrinsic reasoning that enables, okay, we need to look at this diagram and try to understand. Task, identify potential home risks. A closed instance model, a squirrel is walking, no reasoning. Right, that's not a home risk, right? So a VLM, a squirrel carrying bread walking across a porch fence, imitative model squirrel carrying bread, walks in home area, collaborate intuitive model abnormal. So the squirrel appears to be stealing food. VLM normal animal behavior with no aggression. Okay. So I don't get the mechanism though. The mechanism for the learning is unclear to me. Perhaps a diagram will help me. Okay. So we have open instance data. A VLM can have reasoning traces and it can either get a correct answer or a wrong answer. We have this trainable thing deep into it, which gives reasoning and an answer. And then the answer can be evaluated based on open instance data with some GRPO-based reinforcement learning. And then, oh, man, okay. I think the problem is I saw imitation, which I should have known meant we were doing some reinforcement learning, and I still wasn't like mentally ready for that. And so it made it very hard for me to get what was going on in my 1 minute. This paper looks well presented enough though. I'll come back to it. It'll be a decent one to spend a little longer on. Okay. I really wanted to see this one here. I won't start the timer yet because the title is something I think about a lot. Okay. Too vivid to be real. Benchmarking and calibrating generative color fidelity. So yeah, there's this issue that we have. I think they'll say it better than me maybe, where images appear visually authentic to real world photography is like just hard because human ratings and preference will favor things that are like too saturated or too contrast. They're too vivid. They don't look real in that way. So what are they doing here? They first apply IQA, image quality assessment filtering, to obtain about 190K high quality real world images. And then through automatic caption generation, guidance controlled image synthesis, they construct 1.33 million images exhibiting ordered levels of color fidelity. Oh, so they intentionally tried to use T2I models to generate synthetic images with different levels of vividness, divide them into trained test splits, and then, hard for me to parse this table at a glance. It looks like they're saying that theirs has way better color fidelity, precision, accuracy. Their method at the end of training on the data. Or is it better prediction, I think? Or is this could be either talking about the model itself or saying that the benchmark is a better predictor? Because normally when I see these accuracy tables in a paper like this, it's actually saying how much this correlates with like the human judgment of such a thing. I'll come back and look at this paper more later, because like I said, it's something I've been thinking about a lot lately. Okay. Radar, closed loop robotic data generation via semantic planning and autonomous causal environmental reset. Okay, so how are we generating this data? So the radar pipeline and the state transition. Okay, so we do task planning and then we execute. And then when we fail, we have to do it again. And then we'll reverse. And in failure, we reset. And if the reset succeeds, we can repeat and we can do it over and over. And we can store it when things work and don't work and add them to the library of data and then continue executing, I guess. So a fully successful execution forms a continuous loop, concurrently triggering dual storage to repeatedly harvest trajectory variations that we plan. Okay, so basically we have tasks, we plan. If we can go forward and backward, we'll save it. If we can just go forward, we save it. And these are always things that we can try again until we find the fully reversible forward and backward trajectory for our robot to solve some task. So I assume this means like if I can pick and place a block to one place, I can pick and place it back. If it does either of those successfully, those are both success conditions. We can create these nice loops, and then we can vary from the loops in ways that give us like new trajectories. So then we could just mine lots and lots of trajectories that satisfy the same semantic plans. That's my guess. That's all the time I'm going to spend on it too. So hopefully my guess is decent. All right. Omniforcing, unleashing real-time joint audiovisual generation. Wow, real-time audio video is like a big claim. So what's the deal? Oh no, audio visual, so like an image probably. The first framework to distill an offline dual-stream bidirectional diffusion model into high-fidelity streaming autoregressive generator. However, naively applying the distillation triggers severe training instability due to extreme temporal asymmetry between modalities and the resulting token sparsity. So they introduce asymmetric block causal alignment with zero truncation, global prefix that prevents multimodal synchronization drift, and an audio sync token. So remember, sync token means we're going to take like the first thing and always prepend it to the front of our sequence, even if we have a sliding window, even if we're doing infinite rollout and we can't keep everything in context, we'll always keep that sync token there. Or if it's in our attention mask, we'll always attend to the thing at the sync location. So a joint self-forcing distillation paradigm, what does that mean? Let's try to look at their diagram, if I can figure it out in 10 seconds. The 3 stages of omniforcing distillation pipeline. Stage 1 employs distribution matching to adapt the model for few step. Stage 2 uses causal ODE to adapt the network weights to the asymmetric block causal mask, which is this, which has the sync. And then what's the asymmetric component aside from the sync? That's not clear to me. Why are these a different color? That's not clear to me. Stage 3 implements self-forcing training by autoregressively unrolling the generation process to mitigate exposure bias. Often self-forcing would just mean something like we're going to add noise back during the training process to mimic the fact that our test time generations are noisy. But I'm not sure if that's what it means here. We might come back to that. Maybe. John Cena. Okay. Hey Matt, how much time do you spend on doing research work back during PhD? I found myself only able to do about 5 hours of deep work per day, but people pull very long days. Do you watch those people pulling their very long days? Like, do you sit by them? I think 4 to 5 hours of like actual deep work sounds about right to me. And a lot of people I know do even less. If you're doing the right things, 4 to 5 hours should be plenty, especially if you're effectively utilizing modern tools for research, like agentic coding. Agents can be really helpful with a lot of literature review. So like there's ways that they can accelerate and help you get even more out of your limited time. But yeah, 4 to 5 hours sounds pretty great to me. And how much time did I spend? Man, just depends. If I got like really focused on a task, and especially if we were under deadline pressure, maybe I could push myself to get like closer to 8 hours. But you are really trending towards burnout when you're working yourself that hard. Not necessarily a great spot to be. So it's something to be careful about. It also depends on the extent to which research overlaps and doesn't overlap your hobbies, and the extent to which research does and doesn't feel comfortable to you. Like, or like, if you do research and then you're like, oh man, I really got to like take a break and play chess. That's you. There's also people that really love chess and play chess 16 hours a day. There's also the guy that really loves research and does research 16 hours a day. I mean, not like deep focus necessarily, but it's like they're not doing research and then like, oh, I need to recharge now. Such people exist. But I think if you can get like a good 4 hours of work or so a day of like actual work, not like, oh, I talked to my buddy a bit and then like I read this paper a bit. I'm talking about like the actual like you're comparing your stuff to prior works, you're planning an experiment, you're writing the code or having an agent write the code, you're looking at the results, you're thinking about next steps, that kind of like deep work. You should be able to make great progress in 4 to 5 hours. Okay. For those that haven't been here, I see our viewership just like dipped and spiked. We are speed dating papers. We've got 10 to go, spending 1 minute per paper, answering the 3 questions on the right. Ready? On your mark, get set, go. Unit compress, token compression for unified vision language understanding and generation. So they say it's plug and play for unified models, and the samples are from Unitalk. So that's a paper I'm somewhat familiar with. I'm not sure how they're compressing the tokens though. Is it going to be training free? I assume not. It's a plug-in compression decompression mechanism guided with learnable global meta tokens. Okay, so they're gonna have some learnable tokens they put in, which might be the tokens we compress to, by the way. It might be 64 learnable tokens that come out as whatever our tokens are, which is kind of a bummer because it means that our compression is sort of fixed up front. So we have our meta query tokens, which are our global meta tokens, which which are our tokens that we're passing into the unified model. Global meta tokens, boom, the inputs to the LLM. So I'll do a deep dive, look at it later, but I think off the dome I'm right. And does it work? Bagel compressed? I don't know how tolerable these are considering the speed up. I need to look closer at the speed up. I'm not too compelled by this, but I'll look closer and maybe it's good. Okay, that was decent. I understand the method at least. The results are trickier, like stuff like that, where they're like we speed it up and we drop performance. It's really tricky to get into the weeds and decide what a tolerable performance drop is. But we'll try later. What kinds of agentic tools do you use for paper reviews? I mostly read papers extensively or brief through like your 1-minute speed dating. Now, okay, you got to be careful because they will hallucinate things and you just won't know that they're hallucinating them. But like you can take your academic GPT account and you can just ask like, I think a lot of academic accounts have access to deep research. You can just ask it and let it spin for a bit and it'll typically give you decent stuff. And make sure it gives you links. Like if it's not already giving you links, just tell it and it'll give you links and then you can click them when you're interested. Giving links is nice because that's how you also know it didn't just invent a paper. Or if it does invent a paper, it'll have to give you a real link and you'll find out pretty quickly that like it doesn't match. Do be careful actually getting ideas from the LLM though, because a lot of the current ones, this might not be true a month from now, but right now, they'll yes man you like crazy. Like pretty much any idea I pitched to an LLM is like the coolest idea it's ever heard of. But I think they're great for trying to help you retrieve papers. And then you can just fill in the blanks, right? Like go to those papers and look at who they cite and also look at who cited them. And you can move backwards and forwards in the chain. You can try to follow a citation chain all the way to like the most modern paper and then look at their lit review. And that can help you see if you missed anything, right? So those are things that can be pretty helpful. Okay, cool. Let's keep moving. The latent color subspace, emergent order, and high dimensional chaos. So text image generation models advance rapidly, yet achieving fine-grained control over generated images is difficult. Yep, it's difficult. They'll ignore the basic prompts you give them. They have an interpretation of the color representation of the autoencoded latent space, revealing a structure reflecting hue, saturation, and lightness. Cool. So they verify our latent color subspace interpretation by demonstrating it can predict and explicitly control color, which training-free method and flux-based solely on closed-form latent space manipulation. That'd be crazy. So they find a color subspace in the VAE, so they'll take VAEs during the denoising pipeline, move them around, and recolor, like training free. That's awesome if it actually works. And I guess they do a PCA to show the 3 principal components in the VAE latent space, and they show that it is similar to the HSL. The hue forms a circle on the PC2, PC3 plane, saturation is distant from the black-white axis, and lightness lies on PC1. Wow. So they say for the flux VAE, at least, they can totally disentangle these, and then change the color of the thing without changing the input prompt. That's cool. I want to look closer at this. The qualitative makes me think it works, but we'll have to give it a closer look to really know, you know? Yeah, hallucination is definitely here. The chatbots like Gemini and GPT, they want to make a concept that I can't find anywhere on the internet, but all the chatbots are very confident. Yeah, that happens all the time. It's really annoying too, because one moment they'll say something that's like so well researched and they can give all the proof and you look at it and you're like, wow, I can't believe you like put that together so quick. And then other times they'll say stuff that's total junk and they're so sure of it. I had a surreal experience with one the other day. Here, I'll see if it's in my history. This is not my main account, but I will still try to grab. Let's see. Can I search my chats? Because I don't think the chat has the right name. Man. Or it might not be on this computer. Okay, it's less fun if I can't show it to you. Never mind. Maybe if I'll find it someday and I'll show it on stream when I find it. Let me check, by the way, the aspect on this real quick. Okay, aspect ratio looks good. Let's get my timer in my notes. Let's reset the timer. Course-guided visual generation via weighted H transform sampling. So I think we're sampling, we're transforming the hidden state somehow. Given a coarse visual sample, which is the left one, as the guidance, their method generates a corresponding refined result. So this is almost like super resolution. Or in this case, they're saying it does super resolution, in-painting, motion deblur, all this stuff. Okay, training-free manner, what does that mean? So theirs takes, okay, so they're saying that you can have their method leverages the H transform to achieve training-free, operator-free, and stable course-guided generalization. What is the H transform? I should probably know this. Dub's H transform. Dube's H transform proposes to modify the probability transition of the original SD by adding an extra term to the original drifting term F, where it's called the H function. The new transition can guarantee that the SD ends at the fixed point Y, and then weighted H transform sampling, I suppose, means it's kind of like a CFG, basically. Yeah, that's what that looks like. But the H transform is untractable. So they use the, instead of using Y, wait, what? Where is that in the math? The coarse visual sample is Y tilde, and the corresponding fine sample is Y. And so they're saying H for the fine sample is intractable, but H for the like coarse sample is tractable. And so you have a weighted combination of your bad H transform and your unconditional result. And the thing in between those two, they're saying, is pretty close to the actual trajectory. Okay. Without looking at all the math, I think that's the gist of it. And I think I'll close it on that note, or I'll look at how it does first. So yeah, supports all these image restoration style tasks, super resolution, which is where you take a small resolution image and make it big resolution, right? Increase the detail. In painting, which is where like you fill in some empty area. What are they trying to inpaint actually? Or this inpaint is almost like a deblurring. Like it looks like they've painted all over and they're just like fixing the blur sort of. And yeah, then they have Gaussian blur, remove the Gaussian blur. Theirs looks decent compared to the SD edit. I don't know if SD edit is like the best baseline these days. Like how old is SD edit? Yeah, 2021. Okay, so this is like, was this an old paper? No, it's a new paper. See, I don't know how good this is. The baselines are old. Don't do that when you write papers. Like, don't compare only to old stuff. You need to compare to recent stuff too. Hello? Check, check. Did my stream die? Uh, it's complaining to me about the audio bit rate. You can hear me? I don't know why. So you can hear me, Stuart. Okay. I'll keep going. My analytics also got all messed up. It's saying no one's here, even though you're currently chatting. Um, that's really weird. It's telling me I have no audio and no one's here. Okay. I'd really like to finish these last papers before I split the recording. I want to have all of my shorts in the same recording, so I'm very reluctant to stop the recording right now. I'm inclined to just keep pushing. And you say the audio works? I'll take your word for it. How could you be saying that to me otherwise? I mean, I guess you could read the chat and try to trick me, but like, why would you do that? No incentives to do that, right? Okay. Beyond single sample, reliable multi-sample distillation for video understanding. So traditional black box distillation relies on a single teacher response per input, which can be high variance and really relies on your teacher, right? So their approach leverages a task-adapted teacher pool to reliably provide robust supervision. So, okay, multiple teachers first off. So lots of different responses. And then scoring the responses. And then based on like good teachers, I guess using good teachers to supervise your model. I think that's all that's happening here. RL-based adversarial distillation, the pipeline uses multi-sample teacher collection to provide diverse references. A critic as discriminator mechanism is employed to perform task-adaptive sampling, matching student rollouts with teacher responses. Student policies iteratively refined through adversarial distillation using weighted combination of discriminator format and task-specific scores. What is the adversarial part of this exactly? So the student gives the student rollout. We want it to match the best teacher and be unlike the other teachers, I suppose. We say the best teacher is the best teacher, the bad teacher is bad teacher. So now we don't only have a positive response from a good teacher, we have the negative responses from the teachers we don't like as much. Perfect. And the numbers are better than the other numbers they compare to. So let's just say that it works. Okay. Oh, okay. Let me read the chat and then I'll get back to the paper stuff. Hey, I'm a software engineer, new to ML, planning for my master's in CS in winter, fall. Any advices? Also, I have 6 months of time. What should I do? Invest my time in. I've watched CS 229. CS 229 is definitely a great starting point. Did you understand CS 229? If you went into the, like this is outdated, but if you went into PyTorch getting started, no, this is not the tutorial. There. If you went into this and you wanted to learn the basics, how much of this would make sense to you and how much of it would be gibberish? I would say all of this should be stuff that makes so much sense to you, you could explain it to any other person. Probably pretty much any of these tutorials. Probably even if we go to other tutorials beyond learn the basics. Okay, let me. Oh geez, now we're getting into weird. Like, okay, learn the basics is good. What else is good these days? Sorry, I've spent a long time since I thought about this. Like, if you picked up any given Torch tutorial, okay, I don't want to get redirected. Don't do that to me. Like, if you were to read this, you should be able to understand what's going on pretty quickly. Like, the diagrams, even though this is the technical part, you should know the concept stuff enough to where it makes sense. So a good place to start could be going through a lot of these, and in places that it doesn't make sense, use an LLM agent potentially to help you fill in the gaps, or go to YouTube with the search terms that you're missing to fill in the gaps. Some of this should be pretty self-guided though. Eventually, I would love to have a course that answers your exact question, but that takes a lot of time and work, and I'm not going to pretend that I'm better than the stuff from creators that's already out there. Not that I feel strongly convicted enough to recommend any particular thing aside from CS229, which you've already done. You could try to get involved too with like local llama type community, you know, lots of people there that try to take big models and figure out how to cache them, distill them, quantize them, etc., run them on small devices. Interesting things you can do in that space. Really important too, though, if you're planning for a master's, make sure, like, if you're trying to start in the fall, those applications already happened, right? So I suppose maybe you're saying you were already accepted somewhere. If not, you'll just have to reset your plan a year because you need to be applying in December to get accepted in like January, February to then start in September, right? And yeah, in the meantime, try to learn more. You could always reach out to people and look for research experiences potentially, especially if you have good software experience, if you're from like reputable companies and you reach out, like if you work at Amazon, for example, you might be able to reach out to some prof and be like, hey, I'm interested in some ML research internship. Are you hiring anybody? And maybe you bring something to the table they find interesting. So those are things you could do sorry. So those are things you could do with your time. Basically, do something. Maybe it's easier to say what not to do. So I don't know, say what you're planning on doing and I can tell you if it's bad or not. Because there's lots of stuff to do that's good. Learning is good, doing is good. Learning is doing to some extent, doing is learning. Definitely don't try nothing. Like, it's too easy to grab the literal best models in the world that can run on, I don't know, is it 8B these days, 7B? 0.8B, there we go. I wanted the small one. You can grab the literal best models in the world that can fit on like the smallest consumer grade GPUs and poke them and like do things with them. There's just no reason to do nothing. That's what I'm getting at. So do something. First, learn the basics. So if 229, if you can go through this Torch tutorials and you feel like you're up to speed, if you can read papers like these and eventually understand what's happening, that's great. If not, spend a bit more time on that. But it would also be nice if you could find something that really interests you and try to dig in and figure out how it works and see what you think it does poorly and try to see if you can think of ways to make it do things better. Even if you don't think you have the resources to execute on those ideas, just coming up with those ideas can be a really healthy exercise. Then you can discuss them with other people, see what they think, get feedback, and sort of iterate on and improve the way that you reason about such things. If you're still in software, you can also look for opportunities to transition to teams that are more ML or AI facing. And that can be an opportunity within your professional sphere to kind of grow your AI ML skills. And, you know, the closer you get to the ML and the CV and the AI, the NLP at your company, the closer you might get to the people that know the research side and are able maybe to teach you or to bring you onto other projects. And hopefully it spirals and grows from there. Hope that advice helps a little bit. Okay. Benchmarking, discipline-informed reasoning, and image editing. So discipline-informed reasoning. I assume that means this is going to be like really specialized to, I don't know, like really like to math reasoning and to other kinds of technical things. Generated by state-of-the-art image editing models and the evaluation results. Challenging discipline-informed image editing exposes the limitations of current models and complex knowledge reasoning. Draw the edges of the shortest. So they're saying like it can't just draw the shortest path. It can't figure that out in the visual space. So it contains 520 discipline-informed image editing samples across 10 academic disciplines. I bet they use crowdsourcing to generate these, or crowdsourcing to filter these, one of the two, or both. So they generate lots of things like we saw before. Find the shortest path, annotate the graph, stuff like that, like complicated problems that can be solved visually, but they require like good reasoning abilities. We evaluated edited results on discipline reasoning via weighted question-guided MLLM judging. Good. You tell the MLLM what the discipline is so they can do the judging better. And then you have task-specific prompts based on like what the task is for the visual consistency. And then the logical readability, I assume, ends up being task-specific as well to give it like an ultimate score. And then you can aggregate the scores to give a... I don't like that it's aggregated at the end, but I suppose that lets you surface one metric. Yeah, so we get like reasoning, consistency, readability, then we aggregate them, summarize them, and we get like successes. Like, so how many times does it succeed on reasoning and consistency and readability, whereas all three, you know? And so there's a significant amount of the time apparently where the thing is readable, but not either consistent or reasoning, right? It is interesting too to see the massive divide between different open source models, right? Sorry, between the open source and the closed source. Like some of the best Quen image edit is way worse than the Nano Banana Pro. And hell, the Nano Banana Pro is running laps around Seedream 5.0, which that might not be the best Seedream to have brought. I think, like if we look at artificial analysis, man, Claude is running hella ads. If we go to here and we go like to the, let's see, what leaderboard do I want? Oh, video gen. Is it going to let me see this, or do I need to participate to see it? Dang it. Okay. Hopefully I'm right, by the way. This would be embarrassing if I'm wrong. Oh, wait. See dance is the... Sorry, I did want to be an image. I wanted to be an image gen. Text to image. Yep, Seedream 4.0, Seedream 4.5. So sometimes you train a new model and you get worse. You know, it's like minus 15 elo. Although 4.0 is better than the 3.0. And I'm surprised. We're really looking at Seedream 5.0? That's out? Wow, this paper is like on the cutting edge to benchmark like such, like they barely ran these evals. So that's pretty cool. So this gives you a very good snapshot at the current performance of these models, which is pretty neat. All right, man, we are so close to being done with this part of the stream. I am doing my best. Scaling endogenous chain of thought reasoning in diffusion models. I should probably know what endogenous means. I don't. Please tell me what endogenous is. Please, please, please. A framework that enables diffusion models to perform self-guided reasoning by iteratively exploring the semantic latent space and encompasses two primary components. Iterative thought guidance. Iteratively updates latent states in the MLM to create a genuine chain of thought-like reasoning process and to establish this correspondence to DIC's denoising process. Terminal thought grinding. Oh, geez. This looks cool. I'm not going to figure this out in my minute speed date, though. We'll come back to this. Oh, and we're like, are we having it solve visual mazes? For some reason, I thought this was going to be like diffusion LLMs, but, or maybe it's an MLLM with a diffusion head. Yeah, it's an MLLM that then feeds into an MMDIT, and then has to solve these like very complicated visual problems. Yeah, let's come back to this. Good speed date in that it showed that we're interested in this, right? But bad in the sense that I don't really know what the solution is. I barely know what the research problem is, and I don't know if it works. So didn't get most of our goals, but it's okay. It happens. Sometimes it even happens with papers that'll be really cool. Robust reward modeling and reinforcement learning for faithful image editing and generation. Okay. How do we get like the good? It's not coming across here. So they're just comparing different, like where's their method? Comparison, this is just comparing different, like where, okay. The firm edit pipeline follows a novel difference first design. Bottom. The firm gem pipeline adopts a plan then score paradigm to significant. Okay. So a source image and an edit image, compare the two images, difference description, get the differences, analyze and scoring with the difference description, execution, however the provide. Okay. So the score, so it scores just based on specifically knowing the differences, but the score is not necessarily human readable still. It's just like the MLLM model's opinion. Firm gen pipeline is going to have a scoring plan and then based on the plan. So how's the plan? So we give it to a generate. Wait. Oh, so we give it a pipeline, and then it's like these are the things I would score, and then based on that, it will what? Oh my goodness. Okay, I see what I was missing. The top is like how we would score an edit model, and the bottom is how we'd score a generative model. So we would take the prompt, plan a way to score it, then get the gen image, then score it. Whereas for the edited image, we're going to focus on the differences and score awareness of the differences. That's how you get the benchmark. I feel like they had their own model though. Is that just a LoRa trained with like a set of like their synthetic data? They initialize it from the Quen. They train it on their edit gen data, respectively, with an SFT process using Llama Factory. And then they compare it to the Quen VL, the Intern VL, the Gemini 3 Pro. Okay. Ah, and here they are comparing it to the actual, like, because here, I don't actually understand what these results are, if I'm being honest. Like, what do you, I understand this because we're looking at like the actual editing benchmarks, but what is the execution, the consistency, and the easy and the hard? Like that, what are those tables meant to show me? Do I want to come back to this and figure that out? I feel like I understand what I want to know. And I have so many papers open. That's the thing. So those of you that are joining late and we're here the whole time, part of why I'm closing papers, even when I don't know everything, is like sometimes I learned the thing that I wanted to learn. And I've got 30 papers open here. I want to spend 20 minutes in my deep dives. I'm not spending 20 minutes on 30 papers. So we're about to go back and close some that I originally thought I wanted to come back to. It is what it is. Okay, we're almost done though. Let's do this. Scene Assistant, a visual feedback agent for open vocabulary 3D scene generation. How do we do the open vocab 3D scene generation? Oh, this is too small. Here. Okay, let's try again. Scene Assist, a visual feedback agent for open vocabulary 3D scene generation. So open vocabulary text to 3D generation via Scene Assistant. Each scene exhibits high fidelity to long tail objects and intricate spatial constraints. Okay, so these are just the results, and those look interesting enough, but how do they do it? So our approach utilizes a vision feedback-driven closed-loop bottom left, where a VLM agent processes multimodal context, including rendered views, scene metadata, and system messages to generate reasoning and actions following the React paradigm. This framework establishes an iterative refinement process, progressively building complex scenes from step. Okay, because they're always taking the image input, and then they're going to generate some new output, and then they're going to refine until the scene expresses, until the current view rendered image, according to the reasoning, according to the actions, it basically decides it's satisfied and we actually got like a good version of the final scene. Okay, I think we get it. Do they, what kind of results does this allow us to do? Just the qualitative, basically? Okay, quantitative comparison, layout correctness, object quality preference. It looks like it improves all metrics. I'm not sure if these are measured via alignment to human preference. Yep, human participants who score their method better. Whether you trust that or not is up to you. I always find it a little sketchy because what this means is that like they give this to their friends in the lab at school, and we're just taking their word for it that their friends didn't already know what their method was. I think the results look decent though. Real world point tracking with verifier guided pseudo labeling. Okay. So verifier guided real world adaptation, given a query point in real world video, multiple off-the-shelf trackers produce alternative trajectory hypotheses. Okay. Verifier evaluates its per frame predictions, selects the most reliable ones, forming a refined pseudo label trajectory. Unlike native self-training, which randomly selects the teacher model for pseudo labels, this verifier adaptively combines predictions. Okay, so it's just like we're ensembling the teacher supervision basically for the student tracker. That's all that's happening here. It's an ensemble for the prediction of the student, I think. Or it's an ensemble for the thing we're going to supervise the student. Yeah, verify overview. Giving query points at frame t sub 0 and their candidate predictions. We extract local feature for both the query and each candidate, producing query features and candidate features. The query features are then decoded by candidate transformer, which consists of all these layers. The transformer outputs per frame reliability distributions of candidates. Oh, so they're like, this verifier is like their own kind of complicated model, huh? Like if this is the verifier pipeline, because the verifier has a candidate transform, so they have to train that somehow. I wonder how. And does it work? Seems to. We're not going to look at that more, but that seemed reasonably neat. And it's a theme that we're seeing a lot of, which is like come up with some way to ensemble multiple teachers for a single student. throw a lot of compute into, like, basically we already know training that maybe we don't have a lot of resources to compute backprop, and that takes time, or we don't have a lot of data. So we're going to spend a lot of time on inference with big models to get good supervision for our student. That's something to keep in mind for those of you with academic level compute. Oh, we are back to papers that I've already looked at least once. So this part of the stream's done. Speed dating's done. Unless one of you wants to throw a paper at me, I'll give you like 1 minute as I just like collect my thoughts. If you want to throw a paper at me. Otherwise, what I'm about to do, I am going to take a brief break. I'm going to spend part of that break stopping my recording in the background, which won't affect any of you. It shouldn't, at least. Checking the size of the file, making sure I still have space on my device to keep streaming, and then starting the recording again and going through and doing deep dives of some of these papers. That's the idea. So I'll talk to you while I do the first part. So I'm going to stop recording. And we're going to look at this MKV. I'm not going to show you my whole file system. Don't think I have anything here that matters, but, or actually I have like offer letters and stuff in my recent. That's pretty funny. Okay, so let's look at the video. Oh, I mean, I turned my settings up pretty good. Okay, this is the scary part though. So it's not as big as I would have thought. And so hopefully that's just because there's not a lot happening. Wait, why is it not rendering? Okay. Okay, so the text is not... I might want to... It's readable, but I'm not in love with it. So... Not that you guys can necessarily tell because I'm streaming at yet a different resolution. Like, it'll work. Will it work? Let me look at it on the small monitor. It'll work. It's definitely better than when I download from YouTube. Like, it's better. Yeah, like I can read the text that's the right size, especially. I can read that. But I don't know. Especially looking at the size now and seeing that the size is totally reasonable, it makes me inclined to see if I can turn up some preset real quick. I don't think I can while I'm live. So maybe for next stream. Okay. I'm going to start the recording again now because this really not that big of a file. And I don't want to forget. Okay. So recording is back live again. And we need to do two things. I need to grab food or I will die. And we need to pick papers. Also, I said I would look at this paper closer. It's a friend's paper. I said I would do a deep dive. So this is happening. It's kind of a mathy paper, which I'm not as good at as other things, but this is happening. And I also need to think of what to do about lunch. I don't want to stop the stream, but humans need food, and I am a human. So, and I can't just eat. I don't know if you notice what I'm eating right now. I am like basically microdosing caffeine, or maybe not microdosing, depending on quantity. I got these, here, let's see how the camera picks it up. I got these chocolate covered espresso beans, which I should look it up. How much caffeine are in these? Trader Joe's coffee, chocolate, beans, caffeine content. I've already had coffee today, so I got to keep 5 to 11 milligrams of caffeine per bean? Oh my god, I'm gonna die! What? Okay, I gotta be careful. Goodness gracious. This is like, it's gonna be like a Panera Bread charged lemonade situation all over again. Do you guys know about that, by the way? So Panera Bread is a US chain that sells like, they refrigerate sandwiches and sell them to you at outrageous markups. They had a thing called charged lemonade, which was a very big lemonade with like 300 milligrams of caffeine, but like it wasn't necessarily clear to consumers that 390 milligrams of caffeine according to this AI. Here, let's go to not an AI thing, just so that we know we're not like experiencing hallucination, right? Oh, does this not tell me the dose though? It was a 30-ounce lemonade with 390 milligrams of caffeine, which is insane. Like, that's a lot of caffeine. Because the thing is, when you drink coffee, you know what you're getting, but people getting this do not realize, like, oh, I'm like, this should be my whole caffeine intake for the day. And if I'm caffeine sensitive, I shouldn't drink the whole thing. But people didn't know that. So 1 or 2 people died. And so they discontinued it. And so what I'm getting at is this thing, that's a lot of caffeine. I just got to be careful, especially because I haven't eaten lunch. So like I'm hungry. Okay, anyway, we got to rank papers. I got to eat some lunch. I will figure that out. I'll be right back. I need to go to the bathroom anyway because I'm chugging water like a camel. I'll be right back with something that I can eat that I don't look disgusting eating. So give me a second. And if you stay, you're a hero. I'm back. Um, Here, let's change the scene. We are full screen mode now, which is nice. I'm done trying to make things short friendly. If I could, I'd kill the short stream, but that just sounds unnecessary. So we'll keep it up. Hopefully people get the idea if they're there that maybe that's not the place to be. Okay, so We got to rank some papers. I got food. I got a burrito. Of the freezer variety. Not freezer, actually, fridge burrito. Here. Egg and cheese and sausage and maybe potato. I don't know. It's got some stuff in it. I'm gonna eat it like an alien that's never seen Earth food before, with a fork and knife, so that I don't get grease on like my peripherals, because that's annoying. Anyway, I would feel much more sane if one person in the chat could type like a 1 or something to confirm that they hear me. Just because like YouTube always scares me coming back from the breaks, because it'll tell me that my audio bitrate's 0, even though I see the audio now in my OBS. I think it just hasn't like updated that it has audio coming through again. Okay, thanks, Stuart. Appreciate it. Okay, while I eat, we need to pick some papers. So there's some special considerations. I'm doing this one for sure because I wanted to. I mentioned in the last stream, want to do it this stream. These 3 were viewer suggestions. Was this one a viewer suggestion, or did it just end up in the back somehow? These 2 definitely were. This one wasn't. I think, okay, so there was something about this I wanted to understand. And we should maybe sort things. There's some of these papers where, like, do I want to do a deep dive? No. But did I have one question? Yes. And it'd be kind of nice to answer that question. Was I going to deep dive this? I don't remember. I think I did a pretty good job of this on the first time now. Yeah, I think I did. I think I really did. So unless Sam's is here and wants the deep dive, I'm just going to like probably close those. But basically for everything else, we just need to make a hard decision, which this paper is, this is Randopt. Yeah, this one popped off like crazy on Twitter. I'd really like to do a deep dive because this one was popular enough to where I might even be able to like put the title of it in a short and like I'd get search traffic from the title. That'd be pretty sick. So I'd like to keep this one, which I know that does not fit the theme at all of Diamonds in the Rough. I don't want to keep this one. I'm not going to justify myself. We're putting it, okay, so we're forming a close pile in the back. Okay, we'll put a divider. And you guys can save papers by saying in the chat, no, but I was really looking forward to that one. And those will be ones that we save. But for the most part, I'm going to try to be judicious here. Code as chain of thought. I liked this one, but I really felt like I got it in the short pretty well. Oh, there was one thing I was confused about, which was like when we're comparing the methods here, like, okay, we're comparing to Bagel, but like Coco isn't a model. Coco is like a paradigm for training a unified MLLM, right? So is Coco itself its own? You see, it builds upon Bagel. So does it fine tune Bagel, right? That was really the only question I think I had about this. Coco 10 can instruct visuals, yeah, so we're definitely fine tuning something because they're tiny. So they do a text to code fine tuning to equip the model Bagel. Got it. So we're definitely using Bagel. Okay. That's interesting. So they observe that the Bagel struggles with the code first, but they can get Bagel to do code. And then once they have Bagel doing code, they can do all this refining stuff and then get Bagel to do like really good T to I, even for like complicated things with like plots and text and stuff. So I like that. I think that's pretty neat. I think this is a good idea for an MLLM that can essentially teach itself almost, right? Because you give a prompt, you get code, and then you can generate a layout, then you give the model the layout, and then you can get something even better out, right? Do they operate like that at inference too? Right, that's not just the training. That's actually the inference, I think. So how much longer is the inference? Or at inference, are we able to take the text, like, because we're training with the law, like, okay. Do we just use this to generate these, and then, because we're computing the MSE loss here, which that's the real image. I think that means we have to follow this whole pipeline, right? It's like, okay. So it's a framework that leverages executable code for train of thought and a data set, and then validation that it substantially outperforms existing methods. Yeah, I think then that they're doing the code gen even at inference. Yeah, that I'm 90% sure that's true. Okay, let's close it. Okay, we are going to answer short questions like I said. Did I want to spend more time on fish audio? I did want to understand generated audio tokens, like what exactly this is that they're on this end of the diagram, right? Is this just referring to our AR, like we have the first token, then the second token, then the third token, etc.? Do I care about that enough to keep this paper open though? No. No, I don't. I did want to read this one more. I did. I don't remember why. I think because I didn't understand it at all. So, do I love this diagram enough to look at it more? We'll keep it, but I might come back and close it if that makes sense. Because like I'm gonna prioritize things where I think there's a diagram that I can sit down, look at it for 5 minutes, and then be like, okay, this is how this works. I'm so dumb. I just realized immediately what I got wrong in the 60 seconds. I'm like, how are they saying that the early layers learn first if they're just warming up the residuals, because the residuals are necessary for information to make it to the early layers. But each layer's residual has a different scalar. And so they just make the deeper layers take longer warm-up steps, so the scalars attached to the residuals in the early layers are relatively higher, which sort of like makes the loss slightly bigger there. So that makes tons of sense. So I'm dumb. Okay. The only other thing I want to know is like, what's the schedule? So let's see if we can find that. T is the warm-up length for the first layer, and L is the total number of layers. What about the warm-up length for the last layer? Because you said that's on a different schedule. Like, that's later, right? The warm-up length decreases linearly with layer index. Wait, what? Now I'm confused again. Oh, no, it increases. Warm-up length increases linearly. But, like, by how much? Where is that? Like, oh my goodness, like, linearly. They really meant that. Wow, so way longer. And what is T? Okay, do we get T here? I don't think so. Do we get T here? If any of you find T or know where it is, like yell it to me in the chat. I'll read your message and I'll zoom to it. Right now we're just hunting for this T because I want to understand like how much of the training are we saying we're going to have the last residuals turned down. Here's some alternative warm-up schedules like they said. So they're doing linear, which is T times L. You could do a linear square root by just doing square root of the whole thing for your alpha function, or linear square, or equal, or reverse. Those are a lot of different schedules. How do they perform though? I think we can see how they perform over here on the right in the table. So, oh, and we found the warm up. Okay, 1K. So if it's linear and we do 1K for the first layer, then in a 30 layer model, it's just 30,000 steps for the last one to warm all the way up, which is not crazy. We get divergence. For what exactly? Okay, so the equal is layer agnostic. Oh, interesting. So if we warm up all the layers the same, if it's a short warm up, we're fine, but if it's a long warm up, we diverge. That's interesting to know. Like, it's really important that the first layers do have the shorter warm up. Interesting. I guess because, well, why would it diverge? Like, divergence to me, it was not like a vanishing gradient problem. And that's what we would have if we're like warming up those early layer too slow. I mean, I guess they rely on the residuals, the early ones, so bad that like the later ones get like desync from where the early ones should be, and it's just unrecoverable. Or I wonder if they're playing a bit fast and loose with divergence, because I don't see any perplexity over 20. So is it diverged, or does it just fit poorly? It's one thing I wonder. Okay, I think we answered all questions that I had. So I think that's a decent medium dive. I know that we're not supposed to be doing this right now. We're supposed to be ranking the papers, but I don't know, it's hard. Did I want to know this one more? Zero data. I kind of wanted to know, but no, I don't think bad enough to look more. Okay, this one confused me. Like, I got bamboozled by this table because I was expecting speed ups, and they're pitching compression to me, which is fine. But I thought that would mean faster. And what do they mean 4x compression? 4x compression along what axis? Like, I'm looking at the parameters. They look... I'm confused, you know? Parameters look the same. Flops look the same. Where can I see in the metrics that it's compressed? We'll have to look closer at the paper. Should we do that now? Or should we come back? I'll still remember. We'll just come back. From narrow to panoramic vision. No. What about this guy? Ooh, see, this is one where I was like, ooh, that diagram. See, a lot of these have diagrams. And this was the pure learning one that says that they prove that it has better quality and follows the prompt more. We can try. Okay. No, not this one. What did I want to know still about this one? I thought I did decently the first time. I think this is an important one, though, because it underscores something we talked about when we looked at some of those later papers after we saw this one, which is, like, sometimes your reasoning helps questions where the model shouldn't need to reason, but the reasoning just helps. And sometimes it doesn't help questions where reasoning should help. So that's pretty weird. We'll keep it up. This is a decent diagram. We could try this one. That's a fun diagram. This one is similar to the paper that I like and compares to it directly. Okay, fun diagram, 9 enough to keep that guy. Fun diagram, but I'm not convinced I'm actually going to get anything interesting. So, for the stream. So let's be a little stricter. Okay, this one I just wanted to understand what the heck was going on. So maybe we keep it. I think this is just some sparse attention stuff from my look earlier too. That's what it felt like. It's such a dense diagram that it almost is just like a fun and easy caption, or not caption, thumbnail. Because it just looks crazy, doesn't it? Like, look at me on this thing. Like, I don't know. It looks so technical. Let's try this one. Not right now. Like we might have to. We'll have to prune again. I'm keeping too many for sure. I really want to know how this works because we verified that it's not plug and play with rope. Where it's plug and play. It's not training free with rope. But I think we showed that it was pretty lightweight. No, like the training was a lava. Yeah, it's just a lava. And it seemed to beat the rope and fix rope. So we're doing that one for sure. I should have a divider for ones that are like for sure that I really want to deep dive. Nah, this one's not happening. This one I have like one question. This one's, why did I have this one again? Because this diagram is kind of, yeah, that diagram's kind of sexy, I guess. This is like a strong maybe. Doesn't have to be 10 minutes. It could be 5. I say that. It's gonna be longer than that. This one's a yes, but maybe not a long one. I really want to know what's happening here. See, that's true of both of these. Really want to know what's happening. This one, I'm just like, oh, but the diagram. Oh, but the diagram. I'm gonna say, some of these diagrams are so clean. Like, this is a clean diagram. If this actually describes the model well, this should be pretty simple. I'll give it another try. No, I'm not doing this one. Unless I scroll. Oh, but this is the one where, but I got my answer, right? They're doing like CFG kind of on like the colors on the color vividness specifically. Do I kind of want that? I kind of want that. I also wanted to understand this, but not enough to look at it more. It's gonna hurt my head, and I'm getting kind of tired. Yeah, let's save my energy and get papers I can be excited about. Okay, I like this one, the token compression. I thought I got it the first time. We're basically gonna look at it and like, did I get it? Because I think I got it. I liked this one. Okay, we're gonna have to close some over there. We're gonna have to say I didn't get this. It could be a fun diagram. It's just not happening. This not happening. This no. Okay, so anybody want to tell me I just really need to deep dive either of these? I think Sam's, you had recommended these. Oh goodness, sorry, Sam's, I missed a whole message. I don't know if you're still here. Do I recommend PhD students creating some sort of online presence? Yes. The bigger your online presence is just another part of your actual presence, right? Are there people that everyone knows offline that aren't online? Sure. But online is just another way to help even more people know. And to some extent, you didn't mention one thing here, which is GitHub. GitHub's big. Like having code that people are like, yes, like they release useful implementation of things is a big deal. Including useful implementations of other people's stuff. Like if you could be the guy that is able to look at the latest closest Google thing and get like some like replication built out and it works, that's a way to really like blow up your presence. Yeah, the Twitter stuff, like those other things are just another way to use time to network. I will say prioritize stronger networking things first. Like make sure that you are taking advantage of the in-person opportunities at your university. You should know your lab mates. You should know your batch mates. You should know roughly the faculty in the department, right? Taking advantage of your in-person opportunities to meet and know and spend time with these people is probably higher leverage than throwing a blog into the void. Now, if we're talking about you becoming the next like Carpathy in terms of reach, like, okay, obviously that's higher leverage. But for the average person, like if you're talking about an audience my size, you're probably better suited having stronger, like real ties with the people you know than you are just building like a vague audience, because your audience is going to have a lot of people that are trying to learn, but not necessarily established. Whereas the university gives you a chance to interact with people that are established, the faculty, and people around you, the students, that have a high probability of becoming established. And also the direct person to person is just a lot stronger of a bond than the parasocial one, where like you write content, someone reads it, right? That's not social, that's parasocial. It imitates sociality in certain ways, but it isn't social in certain other ways. Okay, I think we said we're going to try to find an answer to one question about this paper, so let's do it. We said they're compressing, but the parameters aren't changing, and the flops aren't going down. The metrics are getting better, but like what's happening here? So let's try to remember briefly what this method is. It's the dynamic chunking diffusion transformer. And the way that that was working, if we look at their architecture, is that the isotropic encoder aggregates. Oh, I'm echoing kind of outside the room. Let's close the door better. It aggregates the local context across the input tokens, which basically does some pruning out of this routing module. And then we have a dechunking layer that tries to predict, like I'm not seeing the loss here. And also, is there a skip from the isotropic encoder to the isotropic decoder? And our conditions, by the way, our Y embedding and our T embedding go to both isotropic encoder and decoder. To try to no, that's not reconstructing the frame latency sequence. What the heck is going on? The isotropic encoder aggregates local context across input tokens. The chunking layer selects a subset of boundary tokens learned via a learned routing module, yielding a compressed sequence that is processed by these are the DIT blocks right here. Oh, and so this is like our noise prediction out here. We've decoded to our noise prediction. Yielding a compressed sequence, this dechunking layer restores the original resolution through spatial smoothing, followed by plug back. And this, I assume, is the plug back. This connection here is the plug back to like fully restore the spatial. Okay. So the routing module looks like it takes the encoder output as its input. That's this part. It has queries and keys. It does a depth-wise conv 2D on the keys, and then a dot product to yield the boundary, which the boundary exists with different probabilities. And if the P is 1, then that's a boundary. So this was a boundary, P1, P1, so those are both boundaries. And then somehow, whatever the threshold was, it must have been 0.3 or greater, because we filtered out all the 0.0s and 0.1s, but kept all the others. And so that's essentially how we do the boundaries. So I'm not sure quite what it means by boundary map, because it looks more like this is just a drop probability, or like a probability of pruning on like a per token basis. And it also looks like we have the same number of tokens here that we had in the input. So it looks like the only pruning we get is when this probability comes out lower. Does the DIT work with arbitrary sequence length and we're able to set P as the threshold? Or do we actually have a set number of tokens that we have to get to and we set the threshold that way? Let's see. And then in the dechunking layer, we get all the boundary tokens and we get the map that shows like select the mask. And we do a prediction of some kind, and then we do a spatial smoothing. I would really like to know more about like this mechanism. But I said I was mainly here to find out why we're not getting faster or like less flops. Let's try to figure that out. I wonder if it's just because of how big the our isotropic encoder and decoder are and their computational cost. So we have 2 target compression ratios. Okay, so what I said, well, is it a threshold or is it a set ratio? It's a set ratio. And then we set P according to like whatever would preserve the ratio. Okay, so the n equals 4 would have the same compression as the patches equals 2, which makes sense. The patches equals 2 and the standard DIT takes in like a grid of 32 by 32 input patches and turns into 16 by 16, which is 4x compression. And they're saying that's what their n equals 16 does. So their P equals 4, or sorry, their n equals 16 is like a P equals 4. So instead of 4x, it's 16x. And those are the compression ratios on the input tokens. Why does it not seem to speed it up more then? I would still think the bulk of your computation is in that diffusion module, especially at inference time. Oh, but you have to decode per step, don't you? Like you can't denoise fully in this space, so you have to like downsample, pass, upsample, denoise. Downsample, pass, upsample, denoise. So that's expensive, but still, is it really more flops per image? Or, okay, maybe they just flops match the baselines because that's a way to show us that they really are faster, right? If you can take roughly equal compute and do better, then you're obviously better at the faster. And that's nice because I think I commented when we looked at a different compression work and they show, yeah, we make it smaller and we get a little worse. That can be really hard to evaluate. How much performance can I stomach losing what I'm compressing. But on the other hand, if you show me at equal size I do better, well then I'll buy it more then when you actually do the faster. Like that's why it's better. Okay. So I kind of buy that. I kind of buy it. I would love though, and I'm confused why I don't already see, this is not the FID for like a state-of-the-art DATXL, right? That would be 2 point something. So what happened that they didn't beat that? I wonder. I don't know if I'm going to spend enough time on this paper to see that because I did answer our question. I don't really care much about the training steps fitting as I do about the wall time, because I know there's some overhead on their approach and I don't know what the wall time is. Oh wait, the router does get, I'm confused with the ratio now, because they're saying the router can retain fewer boundary tokens early on, which yields a stronger compression ratio. Is this from some ablation where like they use variable compression or something? Beyond, okay, chunk mechanism adapts its compression across the diffusion trajectory. I don't understand. I thought we're giving the compression ratio to the router. Is that not the thing we set? Are we actually setting P? And basically they picked a P earlier that yields 4x compression. That might be what it is. They're saying the threshold at P greater than 0.5. That does not match what I see here. Interesting. Okay, I spent enough time with that. I think we understand the parts that we wanted to. Okay, no one's saying to save these, so I am closing them. And okay. Let's see if I have it in me to do these deep dives. The nice thing about the deep dive is I want to be a little bit like less crazy. So I'll be quieter naturally. We can start the deep dive for this one, the scale space diffusion, with their website. And we'll try to do that for some of these. If they have a website where I think they have good demos, we can start it here. Am I doing the latent color subspace paper? I sure hope I am. Yes. Yes, I am. You want me to move it up? I'm happy to move it up. I'm not going to do it first. I do want to just get this one done. I'm happy to do it next, though. If anyone has order requests, let me know. Happy to reorder these. Some of these I'm just recording for a hypothetical offline audience. And am I actually going to publish 10 long form videos from this stream? No. I'm going to pick like 2 or 3. So if I don't get to some of these, it's not the end of the world. All right. I am curious too. Do they have a website? Yes, they do. Some kind. Oh, like a GitHub. With no code! No! It's okay. It looks simply enough to reproduce if somebody really wanted to. That's too bad, though. No demo either. This one would go so hard. This one would be crazy with the demo, by the way. Not even a demo, but even just something with like here, let me show you Ani's website. Like just something interactive. Like with his, you could like sample, this is like how long to generate the image. You could sample faster schedules and slower schedules. And then it would compare hours to the baseline, right? And so it's interactive and you can kind of visualize like how things go. With a paper like this, I would love to be able to visualize like how the colors change as I do different things. And so they could just dump a few like predefined like prompts, like original trajectory results, and like I see for a bunch of different prompts, a bunch of these, and maybe there could even be a slider where I adjust the extent to which we're manipulating the hue, saturation, lightness for a few pre-selected options. Obviously, they wouldn't be generating them on the fly. Just, I think that'd be really cool. Okay, so we have scale space diffusion. By the way, this thing here, the reason it's like low resolution, they actually generated this. It's low resolution. It's MNIST resolution. They generated it with a scale space diffusion trained on MNIST, which I think is kind of clever. And so the tweet for this paper looks fun. Anyway, so I want to emphasize the thing that's different about this compared to other works that do a similar thing is 2 things. So first off, you'll see stuff like, I'll just show you, flow pyramid. I've opened it before. Flow pyramid is also going to say, let's have the noise be tiny and the image be big. But check out what they're going to do to upsample. Check out what the up operation is. Okay? It is a sorry. I know what it is, which is funny. I'm not finding it in the paper like cleanly. Sorry. Okay. The upsampling is nearest neighbor, and the downsampling is bilinear. Now, what can you tell me about a Gaussian mask that we upsample through nearest neighbor interpolation? Okay, this is pretty straightforward. We can pretend that this is like Gaussian noise in my MS Paint, right? Here, wait, let's, how can I paint equal size squares in the MS Paint? Let's just make my brush huge, yeah? Nope, that's too big. Okay, so if this is my Gaussian noise, okay, and I simply upsample the Gaussian noise, this is obviously not Gaussian noise, right? Like we have filled in space. Every single one of my points that originally had like value now has that same value. That's not Gaussian noise. That violates one of the key assumptions of how the diffusion model is supposed to work. So will it work as a hack? Obviously, we just saw it, but it's not elegant, right? It's not like proven, and maybe doing it the right way would do it better. The other thing that's different is that other paper is doing it all in latent space, whereas this paper, part of the reason we're trying to process these smaller latents is so that we can afford to do it in pixel space. And so a lot of this is just showing you the results, but the gist of it is that our forward noising process can be characterized in terms of resizing and noising, and our reverse diffusion processes can be defined in terms of denoising and upsampling. And this should be reminiscent, for those of you that know, of Gaussian pyramids, which I will not explain right now. Okay, so this is an overview of the method mathematically. So the main thing that they're doing here is that they are mapping alpha, which is a scalar value, to a matrix-based linear operator. And in this case, they define that as a resize operator, right? So it's just a chain of such resizes, and the reason for the asterisk here, they're saying it just also includes an attenuation constant. So that gets into like a little bit of the details. But basically, they have added into the math of the diffusion itself a term to control for their upscaling operation at every step in the denoising process. In terms of the results, we might go to the paper for this. Yeah, let's go back to the paper. We've seen enough GIFs. We know that it is like a satisfying thing because you can see the image get bigger and bigger and clearer until you have the full size, fully denoised image at the very end. Let's look at the results and let's talk about potential like strengths and weaknesses, and do we think this method would scale? I think is a big question we should ask ourselves. Because the biggest they go is they go up to 256 by 256 on Celeb A. So they don't quite even train at the scale of doing 256 by 256 on ImageNet. And also, because we're working on pixel space, we're going to be working with UNets. So convolution-based UNets, which, who knows, maybe they could have used the insights from like the JIT, the just an image transformer, to do the same kind of thing in pixel space, and maybe that would work. But then upsampling is just kind of even weirder when you're doing with transformers. Long story short, all of the things we've learned about how to scale the diffusion transformers, which we need to do like production level image gen, it might be tricky to figure out exactly how to get this to apply, right? that being said, let's look at it for what it is. And one thing that they're immediately going to try to sell us on is that we can train these models more quickly. And they say that the DDPM might get like the better final result, but it's going to take longer to train. And who knows if some of this is because like the number of iterations that they're able to run, right? Like notice that the DDPM is a lot closer to theirs when they're able to train longer, but still they get a point that is better than the DDPM, right? They don't get points that are better than the DDPM here, but who knows? Like, does this point eventually, like, does it end up below or above the DDPM by the time you get out there? Basically just the same thing I said again. Does it scale? It's a little hard. I like papers like this though, because they present like a new idea, right? Nobody's doing it this way. You see stuff in the state of the art that does hacks that are reminiscent of this, but this like cuts through that and gets back to like the actual theory of it and provides, some experiments to try to explain it. Here's a nice plot though that shows the information measurement in the diffusion state. And they prove that this very noisy image doesn't have very much information. The information increases as you get cleaner and cleaner. So why spend so much of your diffusion computation, an equal amount of your diffusion computation, even when there's no information? I already explained the only thing about the math that I'm going to bother explaining, although if you're interested in the math, I think this is a great paper to go through. I know the authors personally. They spent a lot of time solving this. It's all very well fleshed out. There's even tables that make it really clear. A lot of papers wouldn't do this. They would throw notation at you. You'd be left to go back to the prior works and try to come up with the mapping. In this particular paper, they even color code for you exactly what's changing between the baseline, a concurrent work that does a similar kind of thing versus their work. And so it's very easy to follow the differences in the diffusion math itself, which I think is very helpful to the reader. Okay, so this is an overview of the training pipeline. So you sample X sub t's at resolution R, and then their model is used to predict a clean image using their loss, just MSE loss. We can double check. So a loss that is upscale aware, right? We apply the upscaling operation to the X sub 0, like the real one, and then obviously we get our X sub 0 predicted by the model. So this is essentially like an upscale aware MSE. Now, let's see. Is there anything else to say about this other than, yes, that's something important to say. So an image is like, has a height and a width, right? And because of the way these models work, they like to upscale by factors of 2. And so you can't like continuously upscale. Let's say you have a 250 step schedule, but a 256 by 256 image. There aren't a lot of clean, elegant ways to upscale. I suppose you could do a strideless upscale and upscale literally every step. What they have to do though is upscale by factors of 2, reminiscent of existing works. And that just means that not every denoising step is going to be an upscale step. So some steps are only denoising, and some steps have to handle both denoising and upscaling. And so that's something to keep in mind. Okay. Is there anything else that I wanted to say about this part? I think this might take us through all the stuff I had to say about the paper. They showed that diffusion models and scale spaces share an information hierarchy, and they quantized the connection mathematically. They observed that highly noised states contain low resolution information, and so they proposed a flexi unit architecture in order to do the simultaneous upscaling. The simultaneous upscaling and denoising. Something else I should have pointed this out when we were on the figure before. So the whole thing here is their flexi unit, but note that like when we're processing the little map, the way that they do it is we're only using the bottleneck when we process the really noise thing. And as we upscale, we add more and more layers. First we add a decoder layer, then to the next resolution add an encoder layer, and then a decoder layer, and then an encoder, and then a decoder, and then encoder. So we're slowly adding layers basically, but the inner part of the model, which is operating at lower resolution anyway, is initialized and initially trained at that lower resolution. So that we have a model that's able to, basically it's like we turn off parts of our model to operate at the lower resolution, because that's how we have to do it, because our model is to some extent resolution aware, right? And so I think that's a pretty interesting innovation as well, is sharing the weights in that manner. So that way you're not just storing like infinite weights for infinite resolutions, which is like a hacky way to do it, but not a very nice way. And then the other way to do it obviously is like if you have latents like the pyramid flow, and you're just upsampling, like your DIT just consumes tokens, right? And the token length is always going to be the same. And so the fact that your sequence length is changing doesn't necessarily matter to the DIT, and so you can get away with changing it. But here, it does matter because otherwise the shapes break. So anyway, that's how they solve it. I thought it's pretty cool. Like I said, if you like diffusion math, definitely check out the paper. That part of it is pretty cool. And also feel free to go see their poster in person at CVPR. How do you add an encoder layer without adding the corresponding decoder layer? That's a good question. It's because when at that scale change step, your input is lower resolution than your output because you're doing the upscaling. And so the effect of adding that decoder layer. Oh, sorry. How do you add an encoder layer without adding the corresponding? Okay, I am answering that question. Basically, in order to upscale, you have to add a decoder layer because the bottleneck keeps things same size. Encoder layer makes it smaller. Decoder layer makes it bigger. So we take 16, go through the bottleneck, it stays 16. But then we come out the first decoder layer, it goes to 32. Perfect. We needed that because we're upscaling. We can add an encoder layer without adding a decoder layer when we're now operating at the same resolution as the output again. So this 32 will get downscaled to 16. Bottleneck keeps it the same 16. Decoder sends us back to 32. Now when we got to go up again, we need to add one decoder layer so that we go from 32 to 64 while still processing 32. But now that we are upsampled and we want to process 64, we need the corresponding encoder layer to do the downsampling. Does that answer your question? I hope so. I'll give you a second because I need, okay, perfect, cool. Yeah, no, I think like it's really cool looking at the math and then looking at this and seeing how, and I was like around for while they were doing all of this. It was just very cool to see how they had this feedback loop between solving the math and like gradually making the modeling itself more and more elegant in this way. And I think what I like about this is even if I'm unconvinced by the actual scaling they've proven so far, I am somewhat persuaded by the elegance to the point where I wonder if, even if their instantiation doesn't scale properly, perhaps there's a few very minor things they can add that would have made that scaling happen. Like a great example is, I'll go to it now. Back to basics. I open this paper all the time. What if this paper, which says let denoising models denoise, had only ever used this, xpred x loss, 1.5 FID worse than when you use the v loss? Or what if they didn't know about the t-shift? 6 FID worse, not using the t-shift. What does the t-shift even have to do with their method, really? Nothing. This t-shift has nothing to do with their method. It is like a very hand-wavy resampling of the time step, which I would argue is totally disentangled from their overall motivation of letting a denoising model denoise, right? That doesn't even appear on the teaser that sells you the method, but it's necessary. And without that, with that 6 FID difference, would this table exist that shows the RADIT destroys sorry, that's not their method, that the JIT is so competitive with the SAT and the DIT and the repo? Would that exist? Could you look at this? No, this would not exist if they didn't find that trick. So sometimes those tricks make all the difference. And so I feel like it's important to actually read the papers sometimes and see them for what they are and give them a fair chance, knowing that maybe all that happened is they didn't find the one trick that makes the method work like magic. So just something to keep in the back of your head. Okay, I'm getting like tired. I'm definitely going to make it through this one. Whether I make it through others, not likely. How long have I been live for? 6 hours? How do people stream for 12 hours? I follow streamers that are live for 12 hours sometimes. I don't know how you do that. I always thought you could do it just because the thing is really fun and like you're just talking, you kind of pass the time. But doing it myself, this is like just beyond exhausting. And I don't even have a chat. There's like, I appreciate those of you that are here, but like, I don't have like 20,000 people to moderate. I'm just talking to 2 or 3 of you. I just don't know how it works. Anyway, I think this looks so cool. I hope it works as well as it seems to. So if I do put the long format, it'll start with that paper date that I did, but I'll still just say the title just to make sure I have it. We're going to do a deep dive. Latent color subspace, emerging order, and high dimensional chaos. This paper looks super interesting from the 1-minute preview earlier, and I just really wanted to look at it a little bit closer. And I think one of the things I wanted to understand is the controllability part. So they make this interesting observation where when you take the flux VAE, which is the part of the diffusion pipeline, to be clear, let me paint it for you. Okay, so just a little reminder, when you are doing latent diffusion, typically you have your image, but your diffusion model, let's call it D, does not want to see the image directly. Instead, you want some encoder that makes your image something the diffusion model likes. VAE latents. This is your VAE encoder. And we are going to feed that to, we'll call this the diffusion model. We're going to feed this to the VAE decoder. This is a D, just so you know, which is going to turn it back into an image, okay? And so the big finding here in this paper is that for the specific VAE encoder that Flux uses, when you look at the features, so like these latents might normally be of length like 4 or 8 or 32, something relatively short. When they take those latents and they do the principal component analysis, which means they basically see like what are the important parts of it and convert it to something, in this case, 3-dimensional. So like, let's say this is an 8D latent. Oh my goodness, I can't write 8. Let's say this is an 8-dimensional latent. They would convert it to a 3-dimensional latent, and then you can project them in 3D like you see here. I'm not sure then where the colors are coming from. Unless those are literally the RGB colors, in which case that's crazy. I need to look closer at their diagram. Oh my goodness, that's what they're saying. Like, they look at the color of the things, they plot the PCAs, so like this point is a token where the color tended to be this red, I think is what they're saying. And they notice that like, okay, so let's look at the PC2, PC3 plane. So we're slicing it like, see PC2, PC3, we're slicing it here if you can visualize it. So if we slice it on that plane, then yes, hue forms a circle, right? We go from reds to violets to blues to teals to greens to yellows. Okay, so we're in that circle here. Saturation is distance from the black-white axis. Okay, yes, we're more saturated on this end, less saturated on this end. And then lightness lies on, oh wait, no, that's lightness. Sorry. We're light on this end, we're dark on this end. And then saturation, okay, sorry. Saturation is distance from the black-white axis. Which axis is the black-white axis? Help me out here. I almost feel like the black-white axis is like a skewer I can stick straight through the middle of, like a line, like in the middle of PC2, PC3 that goes all the way through it. And then like the further I get from that, the more saturated I am, no? That's what it seems like to me. Anyway, so they find that there's color representation in the VAE space. And to explore that, they use 512 solid color images sampled uniformly from HSV space. And they encode it with the VAE encoder, producing some latents. And then they average each image's L patches to obtain a single latent vector. Hold on. Oh, but they're solid color images. Okay, so they get like an average VAE latent for the whole image, which all they're doing there is removing any weird spatial bias because the whole image is uniform if they're same color, right? And then they're going to apply the PCA to the latent vectors after centering their mean, reveals that the first 3 principal components account for 100% of the variance. So that color information is combined to a 3D subspace of the VAE latent space. That is so cool. And that's the latent color subspace. To understand the structure, they project the average latents into the subspace, yielding average color coordinates, which reveal well-organized geometry. And that closely resembles HSL, organized in a bicone. Okay. So next we analyze how color representations change over time with a prompt. We project the latent representations from various steps into the latent color subspace, which they know from the last step, focusing on the hue. Latent patches start as a centered color mixture Gaussian and gradually cluster towards blue, yellow, and brown, showing smooth evolution towards the final colors from early steps. Because in the case of yellow and blue checker tiles, some tiles have to be yellow, some have to be blue, and so you're going to be able to get the VAEs out and just see, like, you know that at the end, because of how your VAE works, it's going to look either blue or yellow in the latent space. And all they're trying to see is even when you have the noisier latents, like how do they move over time towards the colors? And at that point, you can expect a position of latent patches at each step given the final color, because I suppose you would expect it to move smoothly from whatever the random state is to the final color. Okay, so they generate 26 plane images. Oh, and to understand what the expectation is, they have 26 plane images quantified some color wall according to some colors, just a bunch of common color codes, I guess, that they'll want to understand, like schedules to expect for. And then what do? They observe the vectors gradually moving outward from the origin as the FM distribution requires latent patches to start near mid-gray. Okay, so they have the mid-gray embedding, and then they observe that it moves towards the color. And so is it roughly linear? To get its expected LCS position as time step t, we have to account for the distribution's time-dependent dynamics, independent of the generated colors. So for each t, they compute the shift and the scale shifts. You can never get away from scale shift. Shift means you're adding, scale means you're multiplying. So you can describe the movement from the gray in terms of a shift, a thing you add for that t, as well as a scale for that t. So every single t has its own scale and shift. But luckily, it seems like that's global for all colors. It says it's independent of the generated colors, which makes you think that it's like global. So they use the 26 images and project their token average latents from time step t into the LCS, and then the shift is computes the mean over all the images and scales as mean magnitudes. Wow. Oh, and then they report the values of those. Let's see. In the appendix somewhere. Let's find them. Yeah. So it's global, it looks like. For each axis, I think. Right? The shift and the scale. But it's not like color independent. It's not color dependent. Like they said, it's color independent. That's really helpful, because otherwise it'd be a lot harder to model and learn. So that's how they model its movement through the subspace over time. Okay, so to use this, we construct an approximation of assumed bidirective mapping between the LCS coordinates and HSL coordinates using a small set of canonical anchors. The anchors correspond to 6 hues and black-white extremes. So I guess 8 anchors, right? Yeah, 8 anchors. And then they're going to just use a solver, right? Like a linear solver. Given a coordinate C, the lightness L obtained by projecting C onto the chromatic axis, yielding the hue is determined along the polygon defined by the 6 hue anchors. So they get the angles. So yeah, you can mathematically solve back and forth. So this is the decoding function, solved with the anchors, basically. Well, how about encoding? So given the HSL coordinates, corresponding point in the corresponding point in LCS is reconstructed using the same geometric principles in reverse. The lightness is placed along the chromatic axis, the hue is the target point, and then finally the point is positioned along the real direction of the chromatic axis base to the hue point, which defines the encoding function. And so you can just go back and forth in an interpretable and well-organized LCS hidden inside the model. Right, hidden inside the model, because who knew that the VA had this LCS, right? The latent color subspace. So interesting. We can easily go back and forth. That is so cool. I assumed this part would be learnable, but no. Like, I mean, it kind of is, right? Because we have the PC in the first place, don't know what the LCS is, but then we just take the anchors. And you just take 6 hue anchors and the black and white. Okay, let's look at, so I think we mostly understand this. Mid-generation color observation. We can observe the colors which the model is most likely to generate in the final image directly from the LCS projected latent at time step t for our decoding function. But we have to remember D is defined in the default VA latent space, which corresponds to the final time step. Not your VA is not aware that you're ever going to noise things. So that is important to be aware of. So, but they have the statistics for the change over time, so you can kind of guess. So they start by computing the coordinates normalized to time step t50. Okay. Each normalized coordinate is mapped to HSL using function D. The results are arranged in a grid to produce patch level visualization. Interesting. We'll look at that more if it comes up. That's not what I'm trying to understand. I'm mainly trying to understand what the intervention is. Okay. So although understanding how the model represents and processes color could enable color manipulation, how and when to intervene remains unclear. Yeah. Because it traverses from noise to image distribution, with each end of the process implying a fundamentally different way to manipulate color. At late time steps, the patch colors are fixed, and interventions have to preserve the inner patch relations because we already know the layout of what we're generating. So, hence we shift the mean of the patches to the target color in the HSL space. In the LCS, this translates to adjusting hue, saturation, and lightness via rotation, shrinkage, and shift along the black-white axis, respectively. However, color... I think I just had a big frame drop. Let me check stream health. Says we're healthy. Okay. So color is not yet a property of individual patches early on. So yeah, the mean. Since FM treats the trajectory as an interpolation between image and noise, we interpolate between the color interventions of the same proportions. Section 5 qualitatively examines these two strategies and their interpolation. Okay. Concretizing color intervention. We consider a target color in HSL format and its application at time step t to the LCS coordinates of image patches. So we denote the collection of L patch coordinates at time step t. We first normalize coordinate c to reference time step t50. We now shift all patches to the desired color via the same intervention. There's two interventions. First, we can compute the mean of the normalized coordinates, encode the target color to LCS coordinates, and shift all patches by the same offset to get shifted coordinates. That seems really harsh, though. Alternatively, we can decode C to HSL colors, then obtain the mean HSL color across patches and shift each patch in HSL to produce... Oh, so we're doing the shift regardless. Like, we're just... Interesting. Interesting. We can also interpolate between both intervention types, defining shifted LCS coordinates as... Oh, so we can do both, yeah, and we can just weight them. So we apply type 1, type 2, and interpolate intervention. Okay, so this one is type 1, direct LCS. This one's type 2, look at the HSL and translate it back to the LCS to shift, and then interpolate it as when we just use both. To alter the color of individual objects, we leverage semantic segmentation maps derived from text-image cross-attention. Oh, really? Okay, cool. So they want to do that automatically instead of using some, like, pre-trained model. That's a cool way to do it, I guess. So the transformer itself dictates everything. We don't need some external models to do this. So I'm trying to understand what this VAE sub T is. Because they have their method. They're looking at the color differences between file images and latents at time step T, observed by VAE decoding, and interpreting the LCS. Note that by Flux's design, VAE 50 is the final image, and latents at T50 equals... Oh, okay, that's what I didn't know. Okay, cool. Sorry, I didn't realize that was the nomenclature. Okay. Oh, that explains more why it was T50 before. I guess that's something I always forget about Flux. Okay. So yeah, our VAT, this is the final image. And then earlier on, remember, we're always computing the color difference between final images, like the clean image, and the latents at some time step, right? So the VAE, almost in a linear fashion actually, gets closer and closer to the final color. Whereas for their method, they're always able to keep it reliably very different from the final color. Which I think is just proving that, I don't know, let's look at where they cite table 1 and see what they're trying to say with this. We quantitatively evaluate how accurately our observation method represents the final downscaled image with the change of E. We compare this to how well direct decoding of the latent represents the final image. Geneva single object, day 26 plain colored walls. So our methods use low color prediction errors on both data sets for both per pixel and average evaluations. Wait, what? Okay, sorry, I thought I was understanding this, but I really wasn't. They're saying for time steps less than 20, they're outperforming What? I'm missing something here. Dang it. Oh, they're saying in the average setting, they outperform the other things by getting closer to. There's still something I'm missing here. I guess they're saying that their latents have less perceptual color difference in the average pixel case than the VAE. And that's true especially or even when it's noisier. Which basically means that their latents are like taking on the color sooner, basically, I guess. I'm not I don't think I'm gonna get it just by staring at it longer, so I think I'm going to stop trying to get the part that I'm not getting. Okay. So yeah, it enables both observation and intervention. And this is both things, by the way, observing and intervening and quantifying the fact that their intervention is effective, right? Yeah, I think so. So, okay. They're computing. So this is something I'm interested in is like some of these benchmarks are generate an image, generate a teddy bear that's purple or something. So like I wonder if they're going to show me that like they can start with the prompt generate a teddy bear and then make it purple with like their color intervention. That's what I'm kind of curious about. So, okay, as a baseline, we use Flux with prompt specifying only objects without color. Without modifying the prompt, we inject color in two settings, global changes and local changes. We compare to prompt-based color injection. We report accuracy on Jenny Val's color task. Sweet. So they do exactly what I just said I think I would like to see, which is like using no color injection or like having it in the prompt like the benchmark or keeping it in none, but like injecting it via their method, right? And wow, they get really close to like the prompt level accuracy just by doing it in the color space or in the latent color subspace itself. And they preserve the original image structure more faithfully than prompt-based color changes, is what they say. Because that's a cool idea too. So like everything you put in the prompt is work that your diffusion model has to do to like attend to the text. And for a lot of these models, the less you put into that, the better. So something that's nice about a method like this is you can save your tokens in your prompt for things that aren't color, and then you could use the after the fact color modification to change the color. Also, something that I'm seeing here. So color shifting latent patches directly in LCS. Okay, I need to understand. I'm pretty sure what's happening here is with the time step, we're saying where we start the intervention, I think. I think. Let's go check. I wish the text was a little closer to the figures so I could easily go back and forth because the captions aren't super self-contained. Here it is. Okay, that's actually close. That's my bad. Figure 6 presents type 1 and type 2 interventions. All remaining results using the interpolation strategy at time step 9. Okay, I think I'm right. I think we're applying the intervention at the indicated time step, which means obviously if you do it at time step 0, there's nothing to do, so nothing happens. Type 2, apparently, if we apply the transform too late, it just doesn't really listen. And then it doesn't really apply it super thoroughly if we do it at this point either. Um, but then it doesn't work at all if we apply it too early. I mean, all of these are failing if we apply them too early. It does seem like there's a sweet spot around time step somewhere between 8 and 10, where we still get a decent background texture and our object looks decent. So I suppose they're saying that's the right time to apply it. Wait, why did I say t equals 0 would be a bad time to apply it? T equals 0 is like, oh, you're applying it to the pure noise, so there's nothing there, so maybe it like loses it, basically, is what happens if you apply it. Because, sorry, this is, I forget, it's backwards. This is early. These are the early steps. This is applying it at the clean. So when you apply it at the clean, it's like you're just superimposing it, and even t equals 20 apparently is too late. Whereas if you apply it early, but not too early, you get both like the textures that you're supposed to get at the end, mostly, and you get something that looks like the good strawberry. And it's blue, which is what they want, right? They don't want the red strawberry, they want the blue. Oh, my wife is calling me. I should take that. I should take that in a minute. Okay. I think that's what I wanted to get from this paper. We can change the colors of things to guide them to target colors while preserving a lot of the high-level structure. Look, we get a bear, all these bears. This is probably my favorite figure. If I were to make a website for this, it would be like you'd have all these pictures in one color, and then you'd like click the color on the top, and they'd all change colors. I think that'd be pretty slick. Anyway, I think that's good coverage of this. The latent color subspace, emergent order, and high dimensional chaos. I think it's really cool that you can not only analyze and see the colors in the latents of the VAE, but if you find the right time steps, you can even manipulate the model to, with no prompt, force it to be a certain color. And I think that the math behind it is, I don't think I did an amazing job covering it here, but I think we did just enough to mostly understand what's happening. I'm going to take this call from my wife. I'll be right back. Okay, I'm back. I do need to use the bathroom. Viewer count's also dropping. My energy's dropping. None of those things are like the end of the world. Except it might be a good time soon to wind down the stream. I want to get a couple more deep dives in because I wanted to do some long form videos on some of this stuff, and I want to make sure that I'm not missing like my favorites, I guess, so that I have good candidates for this. Maybe I need to turn off the stream though and take a break for a minute and like breathe. Uh, I really wanted to look at this one and this one. This one I could pass. This one I really wanted to. This one I really wanted to. This one was like a decent candidate for stuff. I'm not doing this. This one's fine. This one I did kind of just want to see. Okay, I'm not doing this for real. Okay, we cut it. We just cut it a lot. I'm gonna take a break and I will come back and I'll see who's here. I think that's a good plan. I just need to no more than 2 to 5 minutes. Like water, same thing I've been doing. Because I am motivated to get a couple more things covering a couple more of these papers so that I have stuff to edit during the week. Be right back. Okay, I actually thought about it for a minute. One concurrent viewer, I think, is a good time to call it for now. Leave all these papers up. I can even rewatch, maybe. No, that would take forever. I'm not doing that. But I think I want to take a break, do something to like fix my brain, and then come back and go live and deep dive 7 papers. I might do that in like an hour or so. Um, I don't know if the person that's listening, if you'll still be around then, but that sounds smart to me. Because right now I'm not quite feeling right. I've been sick for 2 weeks. I think that's part of it. And then streaming is tiring. That's another part of it. So I think I'll do a much better job on these videos. And I really want to do a good job on these videos. These papers. I think I'll make much better deep dives of these papers, which are much likelier to turn into like the long form videos that I want them to be if I like make sure that I feel good before, like my brain's awake, my body feels good. So I'll try to come back later tonight and do it. I definitely don't want it to wait for the week because I'm too busy during the week. Anyway, take care and hopefully see you all in a bit.